any issues with the connection link. Guys, let me know on the Click Meeting chat for the Discord. Okay, I've got the thumbs up coming from Ryan, so I'm gonna take it as I'm gonna take it as I'm actually audible. Okay, so cool. So you got more and more of us coming down to the party. So let me warm up my voices, and we're gonna start right off in a sec. Okay, just a quick spin up. So this session will be recorded naturally. I'm going to be having two different means for recording it. The first one coming from the platform Click Meeting itself. That recording is going to be provided to you right after the session commences, after each day. So once the training day ends, you're going to be provided with the thank you very much for joining, kind of an email containing the link for the Click Meeting native recording. However, just to have a backup option coming with a slightly better quality, I'm going to be running OBS Studio here as well. So that's just about it. So that one, the OBS recording will be, I'm going to be sharing it with a slightly tiny little bit of a delay. I think 1-2 hours after we start our race, after each day. But even though it's going to be there, I promise. Okay, Ryan, Salto, can I kindly ask you to mute your mics unless you are you're willing to use them? So that
sorry about that.
No worries. Okay, that's cool. As it was said already on the Click Meeting chat, let us guys stick more with the Discord channel for having our comms and sharing links or snippets, because otherwise we're gonna be losing the Click Meeting chat's history after the training day ends, because Click Meeting doesn't let me retain the history. So whatever you want to discuss, let us go with the Discord instead. What I am doing is that I'm having the Click Meeting window on one monitor, then the Discord channel on the other one. So in that way, I'm able to be always up to date with any kind of questions you might be having. All right, let me see if everything's recording. Yeah, okay, we got it. So let us formally begin then. Hello, guys. I'm super excited to have you here in the class. I hope that it's not too early or too late in your time zone, at least. So good morning, good evening, depending where you are sitting right now. I hope that you guys are full of energy and passion to sit these 3 days highly paced session with me here, and I hope that you guys will be taking a lot of inspirations and tricks to your own gigs coming up coming up soon. So as it has been already stated, we're going to be having the recording, so it's absolutely fine if you need to drop off for an hour or so, or you just need to drop off earlier. That's totally fine. You'll be having links to the recordings placed in your student area in the Binary Offensive website, as well as here on the Discord channel. So these are two places where you can be expecting those recording links. Then, if there is anything you would like me to talk with you, any kind of your own issues, your own questions you might be having, I really encourage you to shoot me with the DM messages, any kind of private messages over the Discord, email, Twitter, wherever you feel is most convenient to you, because I really enjoy and I really get easily triggered into discussing all the issues related to initial access as well as red teaming concepts myself. So I'm going to be trying to help you as much as possible, at least as much as I can. So be sure to shoot me any kind of message or question you might be having. Okay, lo and behold, let us go over to some introductions maybe. So I'm gonna just throw a little bit of a dime coming from myself. So my name is Mariusz. I go by the mgeeky handle. and you might be recognizing me for some of my codes shared on the GitHub repository. What I love to be what I love to share red team related tools, snippets, and scripts that aim to help fellow red teamers in their daily delivery struggles. Since I am a red teamer operator myself, I happen to be working in actually, it's a funny thing, but I found myself working across 3 different large banks. In one, I'm employed on a daily basis, and the 2 other ones, I'm just helping them on the freelance contract, which gives me this unique perspective, unique insight into trying and testing various hypotheses, various payloads, initial access ideas across 3 different highly protected mature environments. And since I'm mostly involved across these 2 other banks as a rather smaller team member, then we are having mostly the palpable teaming, breach simulation kind of an exercises, instead of fully fledged, full-blown red team ops spawning across several weeks. Hence, I'm quite frequently finding myself in an assignment when we take several initial access formats, vectors, and then throw them against banks perimeter and see what's gonna stick. This is why I'm so in love in the initial access, and I'm having a little bit of an exposure there on this particular step of the delivery, and hence why we're having this conversation today, and for the 2 next days in the first place, because I'm just happen to find myself the most passionate about the sole moment of breaching instead of the post-exploitation phases that happen afterwards. So start also just a one tiny little bit dime, and we're gonna be moving off. I started off as a anti-malware analyst as well as researcher. So I did my share at the asset starting in my career. I was involved in developing portions of the asset antivirus, along with its advanced disinfection and cleaning engine. And also, I was involved in analyzing malware samples, writing signatures myself, so I know a thing or 2 about static and behavioral signatures, and hence the entire defensive background I'm having and putting and combining with my offensive requirements. This is something I'm going to be trying to give away to you. So the plan for these 3 days. First and foremost, do expect that these are going to be quite highly paced, very intense sessions. So so be sure to check out recordings whenever you feel like you're missing behind. That's totally okay. Also, today we're gonna be starting off with a slightly more theoretical section, when we'll be just discussing bits and pieces about modern cybersecurity stacks, how they are structured, their multifaceted architectures, and then what are the pros and cons and weaknesses to various systems. Then, after the very first break, which is going to kick in 2 hours, we're gonna then move into more of the practical terms. We're gonna start off quite easily with the Windows script host, and with the Windows script host subsystem. So just a thing or 2, just a few interested pieces about scripts, such as Visual Basic, and then I promise we're gonna be during the in the midst of this day, we're gonna be moving off to quietly more relevant vectors, such as shortcuts, MSI shenanigans, and the further into the forest, the more exciting the journey will be. So let's embrace it then. The plan for tomorrow we're going to be speaking mostly on the more modern, more relevant vectors, such as click ones, such as code signing certificates. And the day number 3 is going to be totally devoted to executables and their related struggles. So, hello world. bit of a disclaimer here. This training does not aim to give you fully undetectable samples, or there are no promises you're gonna be running stealthy in your environments. Naturally, we need to expect that each environment is different. Each set of policies, products, and their internal configurations are going to be vastly varying across the environments. Therefore, I am in no position for telling you this technique is going to be undetectable, this will not, because because at the end of the day, I'm going to be biased by my own experiences that I drawn from the environments I was operating with. So please do take my works with a little bit of a distance here, maybe, and please do not ask the questions, is that particular technique is going to be fully undetectable, because no one has a magic ball to answer that kind of questions. However, we're gonna be trying. I'm gonna be trying my best to indicate which techniques, which ideas worked most of the times, worked most reliably to me, and this is one of the quick wins I'm really looking forward to be giving you. The training is considered intermediary, so some concepts might be considered as slightly more novice, but then there'll be also others falling into more advanced category. So I hope that all kind of audience will be satisfied here. Wall of text of the slides, I'm not going to be reading through all of them top to bottom, I promise. The idea behind fully packed slide decks is just to give you with a lot of contents for you to grasp in your own pace. So in terms of the objectives, what we are trying to achieve here, first and foremost, I want to guide us through the most relevant, most up-to-date set of file formats, vectors, and ideas for breaching environments currently in 2023, as well as try to give you a bunch of quick wins, insights, and kind of a tips what worked for me, at least what didn't work. So at least you're gonna cut through and just get down right to the formats that were deemed as somewhat relevant and more successful. So that's gonna be kind of a quick win driven presentation throughout these 3 days. So with regards to credentials, some of you might have already seen that my credentials email started ending up in junk folder. I think that this might be because of that big ass one-liner I pasted into the email, that SSH known host something that you might have seen there, and that might be the reason, that might be the culprit for some of you not receiving the email in the first place. If you don't know what I'm talking about, if you firstly see those student X kind of a lingo here on this slide, then please do be sure to shoot me with a private message, and I'll make sure to send you your credentials and link to the VM virtual machine during the very first break. This is the issue I'll be looking forward to sort as soon as possible. Otherwise, I'm gonna assume that most of us already have their credentials. So guys, do let me know if you are having any kind of issues gaining access to GitLab, maybe Metic, PoundDrop, any of those. First and foremost, our most important resource that comes with this training is going to be GitLab instance. It looks like follows. So that's gonna be GitLab repository where you'll find the training repo. So you can use that training repo to pull the latest materials, updates, and commits. As we'll be progressing through the training, I'll be adding snippets, I'll be adding samples we'll be working on to the repo. So just make sure to always have it up to date. Even yesterday, I pushed out an update to the slide deck. So you might see that sometimes my slide deck might be slightly off compared to your version. So just be sure to pull the latest training repository release in order to ensure you've got the latest pack. Okay, so what we're gonna find in the pack? First and foremost, beacon samples. If you happen to have yourself a Cobalt Strike license, you can use it throughout this training, and in order to save some time and not reinvent the wheel, I'm just giving all the beacons, beacon payloads and shellcodes here attached to the training repository. Then the exercises directory that's going to contain all of our snippets and various scripts we'll be discussing as we progress. Please do ignore this kind of a nasty error message. I was trying really hard to fix the GitLab container, but for some reason I failed. So please do excuse me that. Then the day 2, day 3, naturally, you'll find plenty of goodies there. I even decided to leave you with the VBA macros stuff, because like 1 year ago when I was having this training, during the day number 2, we were discussing VBA macros. This time, this session, we won't be touching on the macros, I promise. However, the snippets are still out there, so you can just check them out and work through them in your own time if you're interested. No worries, Nick. No worries, absolutely. Okay, Mythic directory. Similarly to the Cobalt Strike, we just have a bunch of preset, pre-generated payloads, pull forwarding. If you want to connect with the Cobalt Strike, you're gonna need to have SSH key naturally in order to expose the Cobalt Strike port. Here you'll find a bunch of convenient scripts helping you on that. Slides is pretty much self-explanatory. Test shell codes. If for some reason you don't want or shell or Cobalt Strike Mythic doesn't work for you, make sure to at least plug in the calc or notepad shellcode just to see how the particular vector works for you. And the tools is going to contain vast amounts, sheer amount of various tools executables will be using throughout the training. Okay, then the Mythic console. I'll get back to this in the next slide. For CS. Okay, so Nick is giving us some guidance on how to fix permissions on the SSH key. Thank you very much, Nick, for that. Highly appreciated. Okay, Cobalt Strike pound drop. The pound drop. Here's how it looks like. If you haven't yet been playing with pound drop, I really recommend you trying it out on some of the maybe. Anytime you want to have a nicely good-looking GUI for hosting your files, maybe it's not that dramatically useful during the actual ops, because we all can just simply upload the files and host them using Apache or any kind of web server. But even so, we actually use it a bunch of the times during the actual ops, and since it's quite good looking, I just decided to include this in the training. The gimmick is to always browse into pound drop over that hard-coded magical URL. Otherwise, you're gonna be redirected to the very infamous internet song, which is probably something you never wanted. So the pound drop is going to be used by us to host the files and then to pull them from the internet whenever required during, for instance, stage delivery approaches. So that's pretty much all to it. Let me know, guys, if you have any issues gaining access to the repo, Mythic, or Cobalt Strike, and I'll try to walk through them with you during the first break. So that was a little bit about me. Maybe let us guys have a little bit of a warm up, just to squeeze some juice out of the gray cells. And how about telling a bit or two about yourself, your background, your interests, and maybe a little bit about your experience, naturally without disclosing any kind of sensitive stuff. So if you guys are willing to tell a bit or two about yourself, please do so on the Discord, or just use your mic, use your cam, however you please, so that we can get to know each other before we properly begin. I can already see Whiskers typing along the stuff.
Hello. If we want to use mic, we should do a request.
Sorry. Well, we all are granted to use the mic, so I'm actively granting you the permission. So you should be now good to go with the mic, if you please.
Now, can you listen me?
Absolutely, we can hear you.
Hello, I am Nikos. I'm from Greece. I'm working at Ernst & Young Greece. I'm red team operator, but I think I'm a junior red team operator. I like to write offensive security tools in different programming languages. I have already published with my colleagues who are today here, George and Chris, a new tool, Supernova. You can check it on GitHub if you want.
Mm-hmm.
That's for me.
Okay, so thank you very much for the introduction, Nikos. So I hope that you'll be able to find some juicy stuff for you in the course's agenda, and I'm looking forward to hearing your feedback as we proceed. So thanks. We've got also Odi with us. Hi, I'm Odi. I'm a penetration tester and red teamer. Looking forward to learning more about initial access. Hello, Odi. It's great to be having you in the class. Also, we've got Whiskers, professional red teamer, aka noob. Okay, so yes, advanced simulation red teams, 8 years in IT, 6 in security, 4 in OffSec. Plenty of experience behind your belt, Whiskers. That's cool. Not much of a dev, but trying to learn malware dev. Well, I think that in the age of ChatGPT, the actual development experience doesn't apply that much anymore, because probably just a bunch of intelligent prompts should be enough to get one complete his development tasks. But yeah, this is the era we're living in. So thanks a lot, Whiskers, for introduction. It's great to be having you here as well.
Hi
Chester.
guys.
Yeah. Hey.
Sorry.
Go ahead.
Hi guys, so I'm Lenny, I'm a French pen tester, maybe a little bit more about 10 years old of experience. I do mostly red team for 3 years now, and I'm an operator and a red team leader now. Of course, now that I have 2 kids, I lack severely of time, so it's mostly for that I was happy to take this training, because I have many ideas. I know how to dev some simple malwares or things like this, but now I want to go fast using a big experienced guy like you.
Oh, that's great. So a dad and a red teamer, how one can even combine those duties, those roles all together? How are you finding time to actually catch up on the
I wait that they are sleeping, and then some days of the week I will say, sorry, my girl, but now it's my time to work.
I see. I think that sleep deprivation is quite common across the researchers and red teamers, so that's okay. I myself, I'm suffering from the same phenomena. So thanks a lot, Rennie, for your introduction. I hope that even a guy with your experience will be able to find a trick or two in the agenda, and then it will be becoming useful pretty much soon. I hope, at least. So thank you very much for saying hello. Now we've got Chester with us. Hi, I'm already 5 years in global internal red team in GE. I am looking for new techniques and inspirations for future operations. I can imagine nice synergy with the new Evelyn Jinx release. Yeah, Kuba is making a lot of efforts for sharing his war stories behind phishing simulations. So I think that actually it makes a lot of sense to combine my training, which is mostly revolving around Windows and file formats, along with Kuba's phishing take on the same problem. So absolutely makes a lot of sense to combine those. Hello, Chester. It's super cool to be having you here in the class, and I hope you'll be enjoying it. Okay, we've got also Offsec J. Hello, I'm Jay. Would like to talk about my tech not cooperating. Red team lead for KPMG in EU. Have some certs: CRTL, GXPN, OSCP. Can conduct successful red teams, but looking to elevate my trade club with the great MGK big fan. I'm super right now well flattered to be having you in the class, and I'm also keeping my fingers crossed very hard so that you will be actually having a trigger to give away from this training. And I'm looking forward to hearing your success stories. Whenever you find some idea working that got you actually the bridge, let me know. I'll be super excited to hear about it. So hello, Jay. Nice to be having you in the class. We got also 0x Reboot with us. Hi. I've been working as a threat management specialist, mostly responsible for vulnerability management, threat hunting, cyber threat intelligence, and also been working with VAFs in one of the financial institution. I was attending a lot of offensive courses just to write detection rules in CM and EDR. Now I'll be trying to the same after this course. So we've got the blue team guy with us in the class that's gonna be looking after us, and is gonna be signaturing all of our juicy stuff. Behold. So guys, there's always this combination of blue and red folks in the class. Some of them are going to be just taking duly notes and then closing down on all the juicy stuff shared. But this is totally okay. We are here. All of us are here to just push the boundaries, to just move the industry forward. So it's absolutely super cool to be having minds coming from the blue and from the offensive perspective. So Reboot, I'm looking forward to your insights, to your cool stories. Whenever we'll be discussing what works, what not, what can be identified, what can be found, or what is going to raise some detections, I'm looking for your insights and your feedbacks. And whenever you'll be wanting to share, hey, I would catch that. I would be seeing that in the logs. That's gonna be super relevant feedback to have. Thank you very much for introducing yourself, and hello in the class. We've got also Isis. Hi. Hi all. I am red teamer based in the UK. Have been red teaming for about a year and a half, and prior to that, have been pen testing for about 2 years. So I'm very new to the space. My love is fishing and always on the hunt for new vectors. Well, the fishing is the ultimate approach we are all going towards when Microsoft decides to kill all the cool stuff, all the file formats, as macOS is actively trying. All of us are going to be end up running fish most of the times eventually. So it's absolutely great. So it's absolutely great testimony. And it's absolutely relevant to the story. Thank you for the introduction. I hope that you also will find a lot of juicy stuff in the agenda for yourself, and it's gonna give you a lot of inspiration for your future gigs. Hello then, Isis. Okay, we've got also Papado with us. Hi, I'm Chris. Hello, Chris. Working as a pen tester, I want to go more into red teaming. I don't have huge experience, but I am quick learning. 2.5 years, I was working as a waiter. Okay, that's cool. So, Chris, I'm looking forward to hearing also your feedback and looking forward to whatever you'll find interesting and insightful, and also then hearing your success stories once we complete the journey. So, I hope that you'll enjoy the party. And thanks for being with us here. We've got also Pepino. Hi together. I'm a red teamer, and I think we share the same love for building initial access vectors. Hello, fellow Pepino. Looking forward to great ideas. And I am looking forward, Pepino, for your ideas, for your insights. Maybe you're gonna be complementing the agenda with some of your tricks, ideas, or gimmicks that you'd like to share with the class. I'm very much looking forward to brainstorming. And all of us, whatever you find something is relevant to the discussed concept, be sure to just share some links, share some GitHub repos or snippets with the class so that we can all evolve and then learn from one another. Okay, let me see if there are any introductory messages. Okay, I think that pretty much sums it all. So with that being said, I think that most of us already came and said hello. So let us now proceed then. With regards to the breaks, I don't know if that was actually if that was really visible in the Click Meeting trainings agenda layout, but there are going to be a bunch of breaks as we proceed. So starting time plus 2 hours. We're going to be having 10-15 minutes break, depending on whatever you think is going to be most whatever is going to be suitable for you. Then you're going to be having dinner break, which happens to starting plus 4 hours. It's gonna take 45 minutes then, up to 60. It's just absolutely up to us how long are we going to want to have that break. And then the next break, it's gonna be start plus 6 hours naturally. So next 10-15 minutes, something like that. We're gonna be having 2 shorter breaks, and then in the middle the lunch break, or your maybe supper break, depending on your time zone then. Okay, hang on. Let me catch up with the Discord, see if there's anything. All right, if there's anything relevant to the slide deck. Okay, Cobalt Strike. Quick setup. If you haven't already, naturally you can connect up to the Cobalt Strike. You'll find a limited user SSH key in the training repo. Let me now see if I can connect there as well. So just give me a sec. Give me a sec. I'm gonna see if I can connect there as well. Sorry, I should have prepared the Cobalt Strike connection up front instead of doing so right now. Okay, one sec. All right, there we have it. So as you might see, the console is already overwhelmed with a lot of trashy beacons coming probably from the sandboxes. So don't feel too much intimidated by that. It actually happens pretty often during the class when somebody maybe inadvertently, sorry, I'm just lost, Cobalt Strike, maybe inadvertently losing some beacons and then giving them away to the sandboxes. That is still okay because the infrastructure is going to be really highly vulnerable. We're going to turn it down after the training, so it's just to test the vectors and see how they work. So absolutely nothing to be scared too much about. Okay, so the Cobalt Strike. Should you be having any kind of issues with the permissions, then Nick has kindly shared a bunch of icacls commands to quickly set them up for us. We just need to ensure that SSH is happy about the permissions on the SSH key itself, and then Yummy Malware 23 without the exclamation bar mark at the trailing post should be a way to go. I recommend you trying setting up the port tunneling with MOBA X terminal, because it's pretty convenient, pretty good looking, and the GUI is also pretty nice. It looks like so. This is the MOBA SSH tunnel. Let me maybe show you the entire MOBA SSH terminal if you haven't seen this already. So this is my MOBA. This is actually a free of charge kind of a software. I'm very used to it. Pretty simple stuff. It gives us file browsing and file uploading functionality. So just the SCP along with the mobile SSH tunnel functionality, which is pretty convenient when you need to set up multiple tunnels during the meat of the engagement. Okay, then we've got also Mythic with us. So for those who don't have the Cobalt Strike license or just want to simply try with something else instead, we're gonna have Mythic. I'm not gonna be delving too much into what the Mythic stands for because there are plenty of great explanatory materials on that. Just a very quick kind of a 1-2 sentences of a summary for those who haven't yet heard. Where have you been for the past 3 years if you haven't had Mythic 10 before? So the Mythic is a very flexible framework, that C2 framework being maintained by a very clever guy from SpectreOps, and it is giving us that flexibility for writing C2 agents in various languages instead of just pushing us to the one and only architecture, one and only language. So this flexibility is something what we are very much looking forward into whenever trying with new, lesser known C2s for the stage one, for the initial breach perspectives, because during the modern deliveries require to decompose our breaching payloads into two independent stages. The stage one being a very lightweight kind of a C2, and then the stage two, which would be then created off the stage one, would be the fully fledged malware, actually coming with a lot of functionalities will be creating for. Does anyone use Mythic during their ops? So I am using Mythic for my ops, especially the Merlin payload is very stable, and it's very very often flying past the radars. So just to recap, if you haven't been incorporating this approach, this mindset yet to your ops, and you'll be finding yourself running against the mature environment, then be sure to leverage the concept of a stage 1 C2 and then stage 2 C2, where the stage 1, among its requirements, we expect the stage 1 needs to be a lesser known lightweight malware. Let me just increase that the font size. I'm going to be sharing these scribbles, these notes files in the repo. Lightweight malware. The stage S1 C2 is expected to get whacked within first minutes after the breach, and equally we're going to use it only to collect some initial intelligence, like for instance domain name, username, installed software, registry keys, and maybe try to and maybe results of reaching out to various URLs looking for egress potential. So what I mean by that is that we might be, for instance, looking when you run your C2, when you run your stage 1 C2, be sure to use a buff such as curl, and then for instance check out whether you can resolve endpoints like Amazon AWS, and maybe DigitalOcean apps. I just forgot the full URL or the worker def and workers def domains. So just this kind of domains that that are very well known to be abusable for the C2 aggressing, because we all know these days we want to make sure that our C2s are going to be aggressing through some third party very well known servers and infrastructures such as Cloudflare workers, DigitalOcean droplets, as well as Amazon AWS Lambdas. Therefore, after we breach environment and we are operating in the heat of window of opportunity spanning across the several minutes until we get kicked out of the network, then we're gonna need to see what endpoints are going to be actually accessible from that from the perspective of that network, which are not filtered away. And then next time we're gonna get back to the network over the another employee phished, then we're gonna make sure that our implant will be aggressing to that particular previously established resolvable cloud environment. So I'll be discussing this concept a little bit more during the next slide. Then the stage 1 C2 is expected to only give us like CD, CWD, list processes, upload, download, and most importantly, means to pivot to stage 2 C2. So for instance, shellcode inject, maybe inline execute for .NET. So any kind of a execution primitive would be expected coming from the stage 1 that's gonna take the shellcode or take the .NET and then run it in memory, either within the same process or across the remote process. And this way, we're gonna be having the notion for pivoting from a straightforward, simplistic stage 1 to the fully fledged stage C2. If you haven't been following this kind of a delivery regime, be sure to incorporate that approach in your next gigs, because this is the modern way to be doing delivery these days, especially against aggressively monitored environments. Examples. I've been having a lot of success with the Mythics Merlin C2. We've been also playing with, naturally, when the Havoc was released, we were also among the very first ones to be using it during the very unstable version. These days, I would say that Havoc is no more a stage 1. I would consider it rather to be far heavier, fatter kind of a C2. So maybe stuff like Nimplant, Porsche C2 is absolutely terrific. Sorry, Porsche C2, absolutely lesser known implant there as well. Recently, there was a hard hat being released, also coming from SpectreOps guys. You might also find probably a bunch of other cool and lesser known, lesser incorporated yet C2s. The thing behind it is that whenever there is a new stage 1 coming to the party, then the red teams all around the world are going to be laying their hands immediately on that repo, looking whenever that project can be somehow modified, just to shake off some of the immediately outstanding IOCs, such as HTTP headers, user agent strings, maybe some hard-coded strings, this kind of stuff. Before you can use public stuff, naturally, we need to get through the code. We need to look for the obvious fingerprints, obvious values, then redo them, recompile the tooling, obfuscate that tooling, or just mangle it with any kind of your own protectors, obfuscators you'll be using in-house, and then throw it against the target. So this is the typical way to be doing stuff. And then naturally, finally, the best we can actually have is the custom C2. Whatever you can put up together in your own time, in your own environment, in your own team, just a straightforward .NET C# or maybe Rust, any kind of very straightforward piece of code that just happens to be connecting with the external endpoint over any kind of a channel, whether that's going to be HTTPS, maybe Teams channel if you can code it like so, then just implement a bunch of very simplistic stuff like running shellcode going through some directories, upload, download, that's gonna give you the very nice stage 1. And then once you have the stage 1 up there and nicely beaconing to you from the infected perimeter, and you've been running it for a while, and you've been observing it that it actually survived, you can then roll the dice and try to pivot. We are pivoting into more capable, fully fledged malware, like for instance Nighthawk, naturally Cobalt, Sliver C2, which is nowadays considered as a stage 2 because of how frequently it was used by threat actors, as well as how many capabilities does it implement. Not to mention Havoc, and probably also other stuff like Broodrat, which is actually one of the most frequently used by my colleagues lately. However, I'm not much of a big fan myself. Okay, let me now catch up with the Discord just to see if there were any questions I've missed. All right. What's the difference between stage 1 and stage 0? I think, well, stage 0, I would probably say that there isn't any point in messing about the lingo. Stage 0, stage -1, stage -2. Maybe some guys just consider stage 0 to be just a Trojan downloader, like a stager, that just a straightforward piece of code that pulls something from the internet and then executes it. Maybe someone may consider the stager as a stage 0, but there's just no point in delving too much into the terminology. Just write yourself a stager, a piece of code that download your next payload, like in the rocket payloads delivery. Then you're gonna actually deliver the stage 1, collect preliminary intelligence, then get back to that network once you kicked out, and then execute your fully fledged C2. What has to be stated here is that stage 2 cannot touch the hard drive in any capacity. This has to be very very loudly stated. Hence, why it's in caps lock. In no under no circumstances we should be actually leaving the stage 2, the Cobalt Strike beacon, in a file in the file being left on the hard drive, because of how aggressive AVs and EDRs are actually when we are messing with the hard drive, based on their presence on the mini filter layer that the Windows system exposes. So with under that requirement, it becomes pretty much visible that whenever you want to drop a payload for your persistent purposes, or for the privilege escalation requirements, like for instance, when you are installing some printer spooler and you need to drop a DLL to the hard drive in order to load eventually that DLL during the escalation of privileges approach, then be sure to use stage 1 DLL for that purpose instead of stage 2. That's gonna get you far further in terms of your delivery compared to leaving your stage 2 behind. So these are just kind of a safety checks and way of working requirements for the successful operators. Okay. Process injection techniques to move from stage 1 to stage 2. Process injection techniques. Yeah, we'll be delving a little bit more on this during the day number 3, but the gimmick of it is that unless you are having some more sophisticated, more advanced implementation of the process injection at your hand, at your disposal, you should be rather looking for staying in the process instead of migrating away. So the idea is that currently those low-hanging ideas, those simpler notions for process injection, are pretty much very well covered by the EDRs based on closely monitoring ETW, ETW feeds, along with naturally what we know as hooking the syscalls. However, if you can in any way survive in the same process instead of migrating away, you'll be better off rather than just doing the process injection ideas. However, we'll be discussing some successful notions during the day number 3. Would you have both stage 1 and stage 2 in the same process? Sometimes yes. Sometimes we are having both of them injected into the same process. Even more, I would say, we are also looking to be running operations when we are using multiple different C2s during one op on a one machine. So it isn't actually too much surprising to be having like 4 different C2s coming back from the very same endpoint, very same workstation. This way, naturally, whenever one gets killed, the others will survive because of the rule: 1 is none, 2 is 1, 1 is none. So we always need to ensure we're having more than one C2s operating in the compromised environment. And then naturally, it all pretty much resolves to your idle time, sleeping time, ensuring that your malware remains obfuscated, cloaked whenever sleeping, like the Cobalt Strike does, or the Nighthawk does. Okay, let me now proceed because we need to be moving along with the agenda. Let's quickly get down to generating some implants with Mythic, just to see how to start playing with that. I'm gonna drop down to my Mythic now. If you haven't been playing with the Mythic yourself yet, let me just give you a bunch of tips how to start working with it. Oops, it's not that. All right. So first and foremost, you're gonna notice, assuming you have never been using Mythic in the past, first what you're gonna do is that click on that Operation Chimera label and then switch to your maldev followed by the number operation. If you have received an email from me that you are, for instance, student 15, then naturally switch to your maldev 15 operation, make it current. And also, as you can see, you are an admin of your own operation. No one is having access to your own op. So in this way, we are kind of separating ourselves, so not to mess with somebody else's implants. Okay, then as we have previously discussed, the Mythic is a flexible framework, meaning it is giving us a lot of different payloads. By the payload, we mean beacons, right? There are going to be beacons. There are going to be payloads specific to the architecture, specifically written in various languages. If you want to quickly gain a grasp for what agents are available in the Mythic, what you can play with, then I recommend you going for the Mythic Agents website. Something I'm going to also toss in our random scribbles file here. And then you'll see whether a particular implant is actively developed, what is the language it was written with, and what platform does it target. So with regards to the quick wins, we've been working a lot with Upfell. Anytime we are working on the macOS, the first thing we're gonna actually want to go and use is going to be Upfell. Upfell flies like a beast against most of the EDRs we've been seeing on the macOS world, assuming you'll apply straightforward JavaScript obfuscation. So if you just drop vanilla plain Upfell JS to the hard drive, Defender or any other EDR on the macOS will complain. But then when you pass it through some mild JavaScript obfuscations, no more detections on the macOS world. Apollo is also fully fledged stage 2. It is comparable to the Cobalt Strike. I would rather say that at times Apollo might be even exceeding Cobalt Strike features or stability, sometimes at least. So it's absolutely terrific C2. However, as you might already expect, it is equally detectable these days. So if you can deploy it in a posteriori approach, from the grounds of the stage 1 just to pivot to it, then you're gonna be having some outstanding experiences. We've also been using Medusa. The Python compiled to executable works like a beast. So the only problem naturally to solve is how are we going to turn the Python to executable. That's going to be left for the day number 3. There are a bunch of different ways we can compile Python. Some of them are superior, some of them are inferior. We're going to be discussing those. Day number 3, Merlin is the absolute quick winner when it comes to the lesser known C2. However, that C2 is actually been developed since like 6 years or so. So plenty of vendors already are very well aware of Merlin. According to our experiences, when we passed Merlin's Golang executable past the garble obfuscator, it absolutely flies undetectable. So we've been using it a lot for the initial access purposes. The only downside is that it waits a lot because this is a Golang executable. Hence, expect to be having like 7+ megs worth of a file. But if you can write your own stage 0 loader, stager, just a piece of code that pulls Merlin from the internet and then unpacks it, runs it in memory, then you're free to go. Also, what we've been using, the Nimplant. However, we've been using Nimplant in the standalone version. Cass has been doing a great job maintaining it for some time. Now Cass is on vacation, so don't expect updates coming anytime soon. But okay, let me now get back to the Metic console. So just a fast forward, hamburger menu, create, payload. Pretty self-explanatory and intuitive. Then we're gonna go with the operating system. This is a no-brainer. We're gonna be working with Windows. Then whether that's gonna be Merlin, Apollo, anything you please. Let me go with the Apollo. Then each payload is going to be having its own specific set of building parameters. Naturally, it's up to you for playing around with those, seeing which ones work for you the best. For instance, whenever we're working with Merlin, always ensure to turn on the garble obfuscator, ensuring your executable will be somewhat unique compared to the other vanilla ones. The way that Metic works underneath the hood is that there's going to be Merlin or payload-specific Docker container running underneath the hood that's going to take the source code, fill the source code with all the required parameters, such as URL and ports, and then compile it dynamically, hence giving you somewhat unique samples. Okay, I'm going to go with Apollo now. Then the next stage, this is actually a unique trait for the Metic. Metic gives us that perspective for tuning only the capabilities we are actually going to use in order to try to minimize the source code base of the generated implant. So since this is a training environment, we're gonna enable all of those at once. Then C2 profiles. So the means for the payload to establish connectivity with our server. Don't be tempted into enabling more than one here, because otherwise you'll be seeing that your beacon never actually gets back to your console, because it's gonna be awaiting for all of those channels to establish connection before actually yielding it back to the console. So instead, just stick with one. I'm gonna go with HTTP. Then for the means of this training, we're gonna fill it as follows: HTTPS c2.b10.it, followed by 443 port, naturally standing for HTTPS, and then the URL will have to be get URL will have to be API followed by v whatever number, like v1, followed by who am I, and then similarly in the post URL we're gonna just end up having that REST-alike URL to wrap up with the update stuff. This is only these URL requirements are only to satisfy my modRev write setup that I'm having on my web server. Let me just show it off to you. So this is our initial access EC2 instance, and then as you can see, I'm having this HT access file, and it tries to demultiplex incoming traffic and then redirect it into subsequent specific C2s. In this way, we can run multiple C2s on one single server. So first and foremost, we are going to enable read-write engine. Then whenever there is GraphQL related request, just push it to the Mythic console. Then anything that happens to be having that /API portion in URL, that's gonna be naturally routed down through to the Mythic. The same goes for the Cobalt Strike. Based on the Cobalt Strike user agent, we're gonna redirect the incoming beacon to that specific C2 instance. So this is the why portion behind setting this particular URL here. Then we're gonna go for the next. Just give your payload some meaningful name, and then simply hit the create payload. Okay, I'm gonna be building one now. Actually, instead of running this in my own machine, let me just switch to my VM and access the console here as well. Let me just enable the VM. So it's building. Oh, that's unfortunate. Okay. Anyone else also experienced Apollo crashing itself? It's actually quite unexpected. I was building payloads literally yesterday. Probably some bit I'm missing. If that's the case, if it breaks, I'm gonna jump right into it during the first break. So don't worry about it. Let me maybe check whether the already preset executables are actually working there. So sorry for that. It's just so unhelpful that the very first kind of a demo starts breaking. I'm gonna check whether I'm gonna check whether the pre-built sample will work actually. I'll jump right into it during the first break maybe. Okay, we've got Mythic, Apollo. Yeah, well, for some reason that preset pre-generated executable actually works. I'm gonna need to sit down to this during the first break. Let me know if it breaks for you as well. If it does, then this is unfortunately this is currently expected, but I'll sort it out. Just please, just do give me some time. Once you generate Mythic, once you generate Apollo executable, you'll see, if you haven't been playing with Apollo before, you will see that this Apollo executable that you'll get from the Mythic is leaving that nasty console window in the front. So now this is naturally something we don't want in the actual op. So any idea how to get rid of that console window without spending a heap ton of time digging into the source codes? Any quick win, silver bullet idea to whack out that console UI? Anyone's having any thoughts? Just a hacky way to change some things. GUI compilation. Okay, that's warm enough. Go with a shellcode. Yeah, that's somewhat about it. But I just want to play with that particular executable, with that file. So the question is there anything we can do with this particular executable file to make the console window disappear and still retain the Apollo's functionality? Just a hacky way to remove the console UI. CMD-C, closer and closer, but I would rather want you to focus on the file itself. Like, is there anything we can do about the file to remove the console UI? Okay, wanna have a hint? I'm sure somebody will figure it out pretty much soon. Hit a window like you can do in a W script. Yeah, but you're thinking of ways how to run it in a hidden manner. I am asking, how do we get the file so that it, after double clicking, it runs again without the console. Yeah, well, we could jump into recompiling stuff, changing properties, absolutely, but that's quite time consuming. I'm thinking in terms of like 1 minute solution, like without spinning up the Visual Studio, which itself is going to consume like 3 minutes editing the manifest. Okay, here comes the hint. How about the structures? Is there anything we can do about executable structures to get rid of the console UI? Okay. Structures, does it ring any bell? Like portable executable structures? That's okay. That's okay if it doesn't ring any bell. Change to DLL. Yeah, well, but I want to have executable, and also after changing to DLL, the entire executable wouldn't run because we've got win main instead of DLL main. Start info to hide. Okay. So it looks like we don't have a clear winner now, but this is absolutely okay, since at least it looks like a trick I'm going to be able to share it with you. So every devoted malware analyst or even executable tinkerer will know that the executable file starts with the portable executable structures, right? So there is a very nifty tool pre-installed on our VM. It's called Detected Easy. Detected Easy is a tool that's a follow-up from the PEID, a straightforward tool that was used to be matching some fingerprint signatures on the executables, aiming to recognize the packer used, technology used. Here we've got Detected Easy that tells us that, hey, this is a .NET executable. It looks like a library maybe, and it's been linked with a linker. Like, yes, like PEBAR on steroids. Actually, Pate and Detected Easy was there before Hasherazade came up with her brilliant PEBAR. But the thing is, this Detected Easy will be using it a bunch of times throughout the training, because it comes with a plethora of very useful features from the offensive perspective, at least. And sure, we've got that advanced checkbox checked in here. Once you've got it, we're gonna go straight to the portable executable structures editor. PE stands for those metadata pieces of information that designate how the executable is layered, is structured, how it looks, how it runs. So we'll find things like what's the architecture of that executable. This is one of the ways to recognize whether your executable is a 32 or 64 bits itself. Another way we could go about determining whether the executable is 32 or 64. Let me just increase the font size because it's absolutely undigestible here. Let me do it maybe 14. Why not? Okay. Another way to recognize whether our executable file is a 32 or 64 is by recognizing that PE field. The PE standing for 504500 PE.D. It stands for 64-bit executable compared to the 32 bits, which in here stands for PE.L. So I take it like it's kind of a it's not that evident, but by just simply looking at that L versus D, we can learn whether the executable is 64 or 32 bits long. But let's get down to the structures itself. Now we've got the structures. Among of them, the most important ones is the image DOS header, the MZ stuff, followed by the field called alpha-new, which points to the empty headers, among of which we'll find the so-called optional header. And in that optional header, there's going to be a property called subsystem. It tells us what is the expected subsystem for that executable. And here we can see that currently it is designated as QI, standing for console UI, just a value of third. Now, what happens if we change that 3 to 2? Then all of a sudden, oh, hey, I'm unable to check it. The reason being is that nasty, tiny little, non-visible, absolutely checkbox called read only. Naturally, I'll be better off unchecking it, right? From QI to GUI, end of story. I'm gonna close it down, close them once again, and then you'll see that our executable literally changed. Is changed now by a least significant bit, that flipped the value of 3 into the 2, and this is going to translate into an executable being this time a Windows GUI application instead of QI. Lo and behold, I'm throwing enter. We're gonna end up having next Apollo payload, right? And this time no console. I know that this is a cheap trick. I get it, but you'll find that plenty of times, very skilled malware developers on the GitHub, they tend to forget about changing executable properties in the Visual Studio solution properties view. So this is a poor man's idea trick to get rid of the console UI. Okay. All right. So if you next time will be working with the Apollo, just make sure to get rid of the nasty UI. Now I'm not sure which Apollo is mine, so I'm just gonna go for the process hacker, and I'm just gonna whack them all. Okay, it looks like it's only that one. Sorry for your payloads that they are crashing. I'll just sit down to this during the first break. Okay, let us carry on. Questions. Maybe, guys, it would help me a lot if we could indicate that the question is a question, maybe prefix it with, I don't know, Q or so. I don't know, Q, anyone's up for a lasagna. That kind of a prefix, the visual cue would give me that helping hint that, hey, there is a question, I need to get back to this, instead of, because we are very talkative here on the channel and I don't want to miss any of the questions. Okay, cool. Okay, so that was the absolutely straightforward nifty trick for getting rid of console UI. Now, with regards to the shellcodes executables, naturally, Q. What was the header name mod? Yes, let me get back. So let me get back to the VM. So once again, Whiskers, if you missed it, right-click on the executable, take it easy, make sure your advanced checkbox is checked. Then you're gonna go for the PE, and in the optional headers structure, you'll find the property name subsystem. It's somewhere about here. Then just make sure to uncheck that read only before you enter any changes. Okay, let me now get back to the slides. Cool. So the Apollo executables, whenever you'll be working with them, sometimes your Apollo will be 64, sometimes 32 bits long, depending on whatever mythic framework version you're using. So now you learn the trick how to recognize the architecture. You can either go for the structures. After right-clicking on the executable, in the structures you'll find the property called machine, and that machine property will tell you whether that's going to be 32 bits long or the 64 bits long architecture on the file itself. That's one of the ways for skinning a cat. Other is just to look for the very first letter after the PE. L standing for 32 bits, D, minor d standing for 64 bits. This is just yet another way to skin a cat. All right. Now, the shellcode is the most primitive form for our weaponry we'll be looking for. And this is because most of the times we are not interested in taking somebody else's executables, assuming they're already busted and they're already very much fingerprinted and signatured by plethora of vendors around. So instead, we are mostly interested in taking the shellcode and then encompassing it into our own shellcode loader, or just delivering it in any suitable way. long story short, shellcode is just a weapon, whereas the executable is a weapon in a box, and we don't want to expose, and we don't want to show off the box to anyone. So there are a few at least ideas how we can change from one form to another, and one of the mostly recognized infamous one is going to be probably Donut. The downside behind Donut, the upside is that it's absolutely straightforward to use, very reliable, and quite cool, just to be simple put. But then because of that, because of how preferable it got across the past years, it is equally very much detectable these days. So first, quick win for working with Donut. I'm not having any benefits for bragging about somebody else's work, but there is on the GitHub this company, the initiative called Porchetta Industries. And the Porchetta Industries is just a collective of a very skilled hackers that tends to work and maintain the commercial or the sponsorware versions of a popular tool sets like CrackMapExec, or for instance Donut as well. And you'll find that ClassVirus is maintaining Donut sponsorware version, which is slightly lesser known, lesser signatured, and also coming with, for instance, direct syscalls compared to the public version of it. So if you have some spare bucks worth spending for the open offensive tool sets, then I'm really recommending you considering supporting the Porchetta Industries guys, because the value you're gonna get from them, the value for money is absolutely outstanding. Unfortunately, these are the times when in order to get reliable tooling lesser used, we're gonna need to spend some bucks for somebody else's time, because a lot of juicy stuff is actually hidden behind sponsorware wall. I myself also do that when I'm just sharing my own tools behind the sponsor wall in order to first extend their usability kind of a window of time, because assuming that not too many of the folks will be using the tool, I'm assuming it's going to be flying undetected for a longer while, because vendors are also will not be tipped off about that particular tool. Not to mention that some folks are just maintaining their own forks of the typical public tooling just to throw in some additional functionalities there. Okay, let's get back to the slides. Now, the gist of that slide is that, okay, there is a bunch of ways. My preferable is always SRDI. SRDI stands for shellcode reflective defined injections, something like that. It's just a straightforward Python script, but also coming in, I think, C++ or Go implementation as well, that takes a DLL on input, spits out a position-independent shellcode on output, which is absolutely something what we are looking for whenever trying to turn from one format to another. And since it is slightly lesser abused, it might be having some slightly better chances for getting the job done. So the thing behind using them is that we will finding ourselves in a mess for learning and memorizing new tools as they come up. And I'm also on the same train wagon. I'm also a red team operator myself, so I know the pain behind learning a new tool. Hey, there's a new tool. It's coming with like hundreds of switches. I ain't got no time for learning how it works. I just want to get the job done. Hence, I tried to build a tool called Protect My Tooling. You'll find it in the C training tools Protect My Tooling. And this is just a straightforward wrapper around various packers, protectors, obfuscators, and shellcode encoders as well. The way it works, we're gonna need to run protect my tooling GUI script, which gives us this cool and dandy user interface. And now it works by asking us for the input file. Clearly, I'm gonna go with Apollo. Here, I'm gonna browse for the Apollo executable file. Then the script recognizes what is the type format of the file, .NET assembly. It now auto-completes and suggests us with a list of packers, obfuscators we might wish to use, but I don't want to obfuscate my executable at this point. I just want to convert from exe to shellcode, and I don't remember all of those donut flags and switches. I don't have time for that. I just want to quickly use the donut here. So the idea is following. I'm gonna add the donut into my packers chain. Now I'm gonna just slightly adjust the output files extension to bin, right? And now simply hit protect. After clicking it, you're gonna see that protect my tooling, which is absolutely straightforward wrapper around those cool tools, is gonna now automatically complete the reasonable set of flags and switches to us, giving us the job done for quickly turning executable into shellcode. I didn't have to go to the GitHub website, didn't have to review the donuts help message. I just wanted to get the job done soon as possible. So just a straightforward quick win. Protect my tooling works also from the console UI, so it can be nicely automated here as well. This is one of the ways you can go about turning from executable to the shellcode, because at the end we want just to work with the shellcodes instead of somebody else's executables. Like we all understand, in 2023 we in no way we could simply deliver executable to the target, Cobalt Strike executable vanilla, Cobalt Strike executable to the target, and then awaiting for the connection coming back to us. This ain't gonna happen because of how very well signatured and modeled those executable wrappers are currently, as seen by the vendors and their products. So this was about absolutely straightforward, pretty quick jump into using Mythic and into converting from one form to another. Now let us embrace, I think, 30 minutes tops of a theoretical introduction to how the modern cyber stacks are layered, what are the pros, cons, weaknesses, and advantages behind various layers, what we can do about them. And then I promise, after this block, we won't be dealing with too much of the heavy theory for the past until the end of the training. So just try to stay with me. Don't get bored too easily across these throughout the next several slides. And then I promise, somewhere around the very first break, we'll be wrapping it up. So sip your cup of coffee, lean back, relax, and just enjoy the discussion here. Guys, there's going a lot of communication, a lot of brainstorming on the Discord, which is absolutely awesome, but I'm not really able to catch it up on the real time. So just be sure, if you would like me to jump in and then just relate to some questions, be sure to kind of visually indicate that I should jump in. Okay. Modern cyber defense stack. So if you've been in the adversary emulation business for some time, you probably have been working with the mature and the lesser mature environments. Some of the startups, maybe public administration offices, they might be running lesser structured and lesser protected environments, just to say the least. And that might be, for instance, lacking some budget, lacking some skills and proper people behind those technologies to properly set them up. So plenty of time you'll find, at least this relates to my personal experiences, I've been seeing critical infrastructures running using merely antiviruses, like commodity antiviruses, without having the proper SOC CM established either in their own company or just outsourced to a third party. Neither they were running EDRs nor proxies. So you'll find that some of the times, in some countries, in some administrations, in some industries, there will be actually still plenty of customers that are lacking absolutely basic protections, such as the ones included on the slide deck here. However, we are not talking about those, because in those cases, we'll be probably having some elevated chances for actually breaching the environments and then carrying on with our objectives, and then naturally helping the customer to close down the issues identified, not to mention to have some rationale behind spending, or at least unleashing some additional budget to the security personnel for deploying those technologies. However, let's just discuss the more sophisticated environments, the more mature, the more locked down ones, because they are just kind of funnier to break, funnier to tackle. I don't find any joy in actually breaching too easily, because this is like opening already open book, right? Instead of just skimming through and getting to the juicy contents yourself, learning and reading along the way. So banks, military environments, secured government environments, not to mention, for instance, very well-funded IT startups. They will be typically having already established and experienced security operations center team, either their own in-house or the outsourced one, that will be experienced to the point for actually deploying several different agents across workstations, network equipment, and various servers, and then pulling the relevant telemetry from those assets into one single centralized repository that we are going to be calling as CM, and then they're going to be ingesting and then enriching that data in order to make some sense, looking for the needle in that information haystack, just to make sense out of it, proactively looking for the threats. However, the problem with the SOCs, the design problem, is that the typical security operations center is expected to be digesting, to be fetching as many signals, as much information as technically feasible, ending up being prone to so-called alert fatigue problems, when plethora of different signals are going to be eventually fatiguing the blue team personnel by having some hard time distinguishing whether a particular signal was in fact a true positive or just a false positive, because some employee just browsed into a random website and then attempted to install, for instance, WinZip software or something. So the point I'm getting is that is that even in the mature environments, even when we are biased that hey, this CM or EDR is probably already detecting that stuff, that technique, that tool, that idea, it doesn't really mean that somebody is actually going to pick up the alert generated and actually do something about it. So if you've been in the business for a longer while, you already probably seen those instances where your customer actually got all the signals, got all the alerts coming from your side. You attempted to Kerberos. You just pulled all the Kerberos-able users from the Active Directory, and actually Microsoft Defender for Identity, previously ATA, they actually seen your attempt, but nobody actually reacted on it. Nobody picked it up, because either there wasn't a personnel during that particular shift, maybe in front of their console. Maybe the ticket is still yet to be processed. Maybe somebody is still yet to pick up that alert and do something about it. Maybe contact the employer, or maybe simply that particular alert or incident wasn't having the enough magnitude, enough severity to just hit the thresholds and then correlate into a bigger alert. So this is kind of a problem I'm seeing pretty much often when, for instance, we've been using DLL sideloading for the execution, and the defender actually picked up the DLL search order hijacking attempt. There was an alert left in the console. It was rated as of the medium severity, but no one made anything out of it because of how many different alerts they've been preoccupied with during that particular time. So the analysts, they have to embrace denial of service attempts, alerts coming from web application firewalls, the attempted network port scanning approaches, especially when they are considered as false positive. Long story short, from the offensive perspective, don't be paranoid that there isn't anything we can do to remain stealthy. Far from it. We can still pull off the old school lateral movement ideas, initial access tricks, and the EDRs will know, they will tell, but the analysts, they might be just too much swamped with their daily job, their daily tickets, they won't actually notice. But let's get back to the trenches here. Cyber defense stack. It goes without saying that mature environments, they understand that the cybersecurity is a process, multifaceted one, hence they need to have bespoke, tailored solutions specific to the particular technology layers. Whether that's going to be email can act as the entrance doors to the organization. Then the organization will naturally be very much interested in purchasing an email security suite, an secure email gateway that will be doing all the black box security, blinking boxes, blinking lights kind of a detection, telling suspicious mails apart from the legitimate ones. So the emails, hence the emails. From the attacker's perspective, whenever we approach the employee over the email, naturally, we need to anticipate, we need to model the fact that, hey, behind the perimeter, there's going to be the system. There can be, for instance, FireEye MX. And what's gonna FireEye do about my email? It's gonna rip it apart. It's gonna break it into pieces. It's gonna shred your attachment and tell everyone about it. Your attachment is gonna end up on the VirusTotal. And now the question is what you are going to do about it. How are you going to anticipate the fact that your beloved malware that you spent last 15 years writing and devolving on is going to end up on VirusTotal? How are you going to react on this fact? So the knowledge, the exposure, the experience gives us that initiative for proactively equipping some guardrails, some ideas for fighting back on that particular layers of the protection ecosystem. First and foremost, we're going to be having the email, for instance. Email naturally is going to be looking through the network characteristics of our domain, of our web server, SMTP headers. Then there's going to be some statistical analysis based of the contents of our email. You know, all those Bayesian chains, this kind of stuff. Whether that email has been seen across the world in any other customers, across the tenants. Then the attachment naturally will be put into the sandbox, detonated, and observed closely, looking for any remnants of potentially suspicious activity. All of the links will end up leaving in the email will be teared apart. Crawlers and spiders will be first to observe our website. And this is something we'll just need to embrace and prepare for. Then, assuming in some way we actually managed to lure the victim onto our landing page, on that landing page, which we should be rather hosting off somebody else's reputational service, just third-party cloud assets, then there's going to be naturally some HTML analysis coming from the crawler, coming from the spider, such as, like for instance, implemented by the Microsoft Safe Links technology. That's going to try to look for some obvious fingerprints identifying that, hey, this landing page might be impersonating some banking logging form, or maybe some Gmail logging form, any kind of those very well-known websites. Even we know we have some evidences that that technologies known for scanning websites, they are even applying AI machine learning models towards computing the resemblance, the similarity score between our landing page to other very well-known, for instance, login forms. Take the Gmail or Office 365 login form for an instance. Your faked Office 365 login form is going to be looking just the same, one-to-one, very similar to the genuine one. Then there might be some machine learning model taking a snapshot of your faked Office 365 login prompt, and then comparing it to the snapshot of the benign legitimate login form, seeing that they closely resemble, therefore constituting that your website is suspicious, which is going to end up marking you as the unsafe website. The Google Chrome safe browsing might consider your website as suspicious, not to mention Office as well. So these are the ideas we need to embrace for. Naturally, we'll always think of some clever ways for evading those notions. There's plenty of ideas we can do about them. It just takes creativity and proactive approach for understanding what they do, what the defenders are doing, what the vendors are doing, and then spend a significant effort trying to make their life harder, but absolutely still doable even in 2023 against tightly locked down environments. It just takes more efforts. Question, sorry for the inconvenience. Should we reduce the text here? Less noise. The text here, less noise. You're referring, Salto, to the email, right? To the email content, like the body of the email. Is this the question you have? Q. Another question coming from Salto. It's getting harder to get trusted domain, categorized domains. Cloning sites like Gmail login is gonna be flagged quickly. Ideas to tackle that. Let me postpone your question to the few slides next. Okay, we're gonna be discussing what we can do about domains. Long story short, make sure your domain is warmed up and don't burn it too easily. That's the best idea we can have here. No, I mean, sorry, if we're spamming the Discord channel. No, absolutely don't. The Discord channel is for us. I'll be also very much looking forward to catching up with the entire discussion during the very first break. So please do.
Sorry, can we create another one channel for questions?
Sure, absolutely. Great idea. Let me now just do it.
It's not my idea. It's the idea of Isers, and I think he did first the idea.
Okay, so we've got the questions channel. Brilliant idea. Thank you very much, Nikos. I don't know how I just missed that notion to just create a separate channel. Let's just use the questions channel solely for the questions, okay? Like where each post is going to be actually Q1. That's going to be even simpler to handle. Okay, let me just catch up on the agenda, because I just need to ensure the tempo and the timeline here. Okay, then once we lure our victim into the landing page, we then are gonna be typically getting that victim with the drive-by download, letting him download the file that's going to be driving our infection there. So we're gonna be dropping a file, typically using HTML smuggling approaches discussed a little bit later on. Now, before we actually browse the website, before before the victim actually lands on it, there's going to be security. There's going to be secure web proxy analyzing, dissecting our domain DNS characteristics as well. Not to mention the proxy itself is going to be also deciphering the traffic and then looking for the known bot across our HTML code. So the stuff like Palo Alto, Zscaler, they are known for extracting the files from the traffic flying past them and then detonate them, analyze the files being downloaded, maybe block the attempts in the first place, depending on the domain we are aggressing for. Let's just take, for instance, you wanted to constitute a channel over a Google Docs. You found that you came up with that brilliant implementation for Google Docs C2 channel. You thought my malware is gonna aggress over an Excel spreadsheet over the Google Docs, but then you throw your malware to the target. You even managed to get that target execute your malware, but then all of a sudden no communication getting back to you because the proxy blocked the Google Docs endpoint based on the policy applied across the company that the personal data exchange or documents exchanged services are just denied in this organization. So this is where the proxy kicks in and then just blocks our traffic. It is just yet another layer to be worried about, but we'll get to that. Now that we know how many hiccups, how many obstacles, struggles, and steps we have to take, let's try to work them one by one and discuss few ideas for trying to survive, for making it a living. First, common ways into the organization. So I just made a little bit of a polling here, questionnaires, trying to look for the typical, very well recurring patterns for breaching into organizations, as observed from the threat actors, as observed, as shared and discussed by the Red Team folks across the Slacks, Discords, or Twitters. And this is what we came with. It isn't that much surprising that email still stands for #1 breaching vector even lately. I would say that myself personally, we try to stay away from using emails whenever possible, and instead we are trying to interact, to engage with the employees over third-party channels, like for instance LinkedIn. So LinkedIn channel, maybe website employee chats. You know, that right hand side lower part chat box is gonna pop up on various customer landing pages, where we can actually interact with the employee and then talk him into opening our files or receiving an email from us. The communication is a key. If we talk our victim into expecting the file coming from us, that victim will be proactively working with us to get that file, to receive the file and open it, disregarding all of the antivirus prompts or many other mark of the web stuff. So it just takes a little bit more of the social engineering creativity into talking the victim into cooperating with us. If you take any kind of a negotiations book, like Robert Cialdini Persuasion, like Chris Voss, the FBI professional negotiator, you'll read about plenty of success stories where those negotiators were in the position to actually make the other party make their negotiation partner to actually do what they expected him to do. So the same applies to the social engineering pretexts. Not only do we need to be brilliant hackers, we also need to be very talkative, very charming guys that are just actively seeking for help, for others' help, and eventually we'll end up having an employee who will be very much open for collaborating with us. This is what works for us these days. Spear phishing, this kind of a watering holes. If you have some a priori knowledge about your target, you know that it, for instance, is interested in Kubernetes, you can just send this guy with some Kubernetes PDFs, maybe, and maybe some Word document detailing how to set up his Kubernetes course credentials, maybe by just simply inviting your target to the webinar, to the free of charge Kubernetes webinar. That's gonna be very tempting pretext scenario for him to actually pull your own malicious WebEx installer that's gonna infect his machine, and then whenever the webinar's time comes by, he's not gonna actually get the invitation, and you're gonna be just explaining that there are some maybe technical difficulties or so. Reusing stolen credentials, password spraying, exposed RDP assets, especially in times of cloud-based resources, is a pretty reoccurring scenario when we are just finding company-related assets exposed on the clouds. The bigger the target is, the more assets will be actually exposed, and sometimes we'll be having some initial accesses in there as well. So these are the very well-known reoccurring patterns. You will also find two hidden slides that I just skipped. These are going to be in your slide deck. There are two very nice pictures depicting the initial access vectors collected by Florian Roth, as well as there was the ransomware anatomy of the ransomware attack image among those hidden slides. There's also nicely pictures. Pretty relevant initial access ideas that are still reoccurring these days. Now let's talk about email. Let me now catch up. Oh, there's a question. Okay, for credentials harvesting, do you prefer Modliszka or Evil Engines? Actually, I prefer Murena. In Murena, well, at least I haven't yet catch up on the Evil Engines free capabilities. I know that Kuba was working hard on upgrading Evil Engines lately. I just haven't yet time to stick with it and see what it has to offer. But Murena comes with the Necro browser extension, and let me just Necro browser. That's the one. And the Necro browser, Murena as well as Necro browser are being maintained by Michel Leroux, anti-snatcher, who is also very well known for maintaining Beef framework, the XSS framework from the past, the 2015 project or so. The Necro browser is just a plugin. It's just a plugin that uses Puppeteer. Puppeteer is the Chrome automation JavaScript framework that just instruments the browsers into doing some stuff. Now let me give you a practical example when we actually used Murena with the outstanding result. So consider there is a bank, and you found that this bank uses Azure DevOps, right? Azure DevOps for storing their source codes and defining CI/CD pipelines, right? Now you got into the org. Now you're moving laterally. What we did is that we've sent internal phishing, right? Just on behalf of compromised user, we sent an email, and that email lured the victim into Office 365 themed phishing page. So far, so good. So far, pretty well-known pattern, right? And then what we then did is that once the victim, who we chosen to be a developer, exposed his creds, our Necro browser in the background, what it's called? It's called unattended. In a headless manner. It just steered the Chrome into adding SSH key to that user's Azure DevOps account. So we were able to backdoor that Azure DevOps user in a glimpse of a second during the time when he provided and exposed his credentials. So our Necro browser script, it just took the tokens, it just took the authentication tokens, the MFI claim and so, and then just shoot away a bunch of requests to the Azure DevOps by adding a SSH key. This way, we were able to not only gain access to that user's repositories, but we've also gained access to the OAuth token to that GitLab, to his Azure DevOps account, and we are then able to list repositories, list hidden projects on behalf of that user. So there was a brilliant use case scenario for using Chrome automation technology, such as Necro browser exposes, in order to do some activities unattended without our manual interaction. And this actually comes very powerful when you cannot really predict the exact moment when your victim is going to fall into your phishing and it's going to expose your credentials. Maybe you're just having your lunch break. Maybe you're just sleeping. Maybe because that victim works from another time zone or so. It just very nicely weaponized what we can do after gaining access to somebody else's credentials. So hence the Necro browser. We've been using Morena. However, I'm not saying Evil Engines is any worse. I also heard that Kuba is actively working on the Necro browser alternative. So there's going to be eventually an addition to the Evil Engines that's going to be also giving us the ability to quickly fire away some requests after stealing tokens. So absolutely brilliant idea. Okay, emails. So long story short, attachments are no-go in 2020 and onwards, unless you can make them look benign. So what we are seeing these days very frequently is that threat actors, they tend to include attached PDFs to the emails, and those PDFs will be having the website, the URL, just embedded within the PDF. In this way, the email body doesn't really contain any kind of links, but the PDF in question does. So we're gonna lure the victim into opening the PDF. Then it's gonna be that bigger font styled URL, tempting the user to move along to our landing page, and then we carry on from that ground. In this way, we hope, we believe, we expect to fly past email scanners that might be looking for the URLs embedded within the SMTP contents, within the body contents. But as you might suspect, probably this won't work in the tightly locked environments. However, there's another aspect to this problem. The organizations, they cannot just simply disable receiving attachments at all, because at the end of the day, there are going to be departments and personnels that are just expecting to be receiving some documents like invoices. The procurement team expects to be provided with invoices coming from the merchants, resellers, and stuff. The investors relationships team also is expected to be provided with some kind of reports, offers, and other Excel spreadsheets with some questions coming from investors. The legal departments as well, they are also expecting to be receiving various documents, agreements, contracts, and other documents that they should be reviewing from the legal perspective. In other words, at some point, every organization will have to accept the fact that the files will be flowing towards them. They just need to be provided, and they just need to accept some files. The only thing is for us to map out the files that they can accept, and then think of ways, now that we've got, for instance, PDF that they can receive, what shady, what nasty we can do with the PDF. Currently, The short answer is, unless you're having some 0 day, which is far from likely, then the best we can do is just to blatantly paste the URL and then just naively lure the victim through that PDF containing URL. Other than that, if you are doing the purple teaming kind of an assessment or the attack detection path mapping, attack detection assessment, you can just try out various extensions, various files, even if macros are not relevant anymore, and you are just simply mapping out the threat exposure that your customer might be facing. How about thinking of lesser known, more exotic files like PowerPoint with the macro, Microsoft Access Database with the macro, Visio diagram, Microsoft project file with the macro, and such. So there's going to be plenty of files we'll see eventually in one of the slides. There's like 80 plus different files that can constitute the danger to the Windows ecosystem that we might be wanting to map out during the purple teaming kind of an exercise. But then still give away, long story short, I would say that attachments are very hard trick to pull off these days, unless you're using them in a nice manner, like just by simply just hiding links, hiding URLs, or further guidelines, steps, how the victim can get infected. In order to install our cool WebEx webinar platform, please go to the website attacker.com, then download the evil.msi, then click through the mark of the web. You get the drill. Okay, so what else? Links. Naturally, currently, the only usable aspect from email is to either establish a very well grounded, legitimate, benign conversation with the employee without dropping anything suspicious, or just simply convey the links. In terms of the links, it really makes a difference what are the names for your get parameters, the number of get parameters that constitute in your URL. It really does make a difference. Not to mention that leaving just a straightforward extensions might be not the best idea. That goes without saying. So actually, I spent a lot of time. I've spent a lot of time sending emails back and forth against Office 365. Long story short, I came up with the conclusion that, for instance, if there is a Viagra keyword in the email subject, naturally, that's aligned with our intuition, that's going to be the anti-spam rule, or the rule that was just matched on the message being present in the SMTP headers on the receiving party. So if I am the recipient of the message, I will see in the SMTP headers that, for instance, Microsoft Forefront or Microsoft Office 365 will mark the message on the SMTP headers that, hey, there was this opaque number that designates, well, the number of anti-spam rules that matched my email. If there is the same email with and without the Viagra, those two emails will be just differing by one opaque number being present in the SMTP headers on the recipient side or not, giving us this clue and observation that, for instance, some words might be triggering some particular anti-spam rules that we don't have anywhere defined, documented, because Microsoft doesn't document their rules. However, though, we still can draw some conclusions. And then, for instance, I've sent an email containing a URL without get parameters, and that I have then sent an email containing one get parameter, and all of a sudden, to my surprise, those two emails were having varying number of anti-spam rules being present in the SMTP headers, giving me that conclusion that the presence of one single parameter applies one additional opaque anti-spam rule number, which I don't know what stands for, but I see that there is one more number. And then when I appended like few more get parameters to the URL, I've seen yet another number, just completely different number of a different value. This gives me yet another conclusion that the number of get parameters actually do translate into the number of anti-spam rules that might be hitting your email. I don't know what's the severity magnitude of those rules, because we don't have them documented anyway. I just have that conclusion. Therefore, my idea from the offensive engineering perspective, I'm going to be working towards getting an email having the least amount of anti-spam rules numbers being matched on my email. So the simpler the message, the less cool HTML tricks, divs, spans, images you can get there. Well, probably the higher the chances we can get to the organization. That's something I try to kind of implement in my script called phishing HTML linter. If you are interested, let me just link it. If you are interested in taking it for a spin, I just paste the link on the GitHub. Sorry, on the Discord. Just a straightforward script that takes your HTML phishing message text on input, and then spits out all of the recommendations for you how you can rework your message so that it blends up nicely. Now, the question to you guys, because we just hit the break time, question is, are we doing the break time, or should we carry on with, for instance, I don't know, like 1 slide, 2 slides, or let's just stick to the break time resume? Break time, that is. Okay, perfect. So my just one tiny little idea, maybe let's just not ask questions during the break time, or maybe instead do ask questions during the break time, but I'll get back with the answers after the break time, so we can have the break being a break. We don't actually we'll actually be having a chance to rest. So what I'm going to do now, I'm going to throw in the 10 minutes timer here, and let us just see each other within 10 minutes. And now I'll try to work with the mythic problems during the break time. Okay, so see you in 10 minutes then. Okay, just give me 1 sec. I'm gonna answer the question now and get back to you. Hang on a sec. Okay, let me get back. All right, so okay, so now with regards to the phishing tidbits, once again, it's a hell of a wall of text slides. Naturally, we won't be reading through all of that top to bottom, but instead, let us just give a tiny little bit of a gimmick here. First and foremost, I'm gonna share with you 2 more links. Let me now paste them on the Discord, as well as put them into our notes. First is going to be F-Secure Insights from a Large-Scale Ops. It's a really cool research outcome from my colleagues who were running this massive phishing simulation across several large organizations. And here are some of the conclusions they drawn. Especially, you can find here at the end of it. Oh, that's uncool. It actually looks like the report isn't there yet. But there's just a nice gimmick of what departments were more likely to click on the phishing links than the others. And finally, there was a very cool presentation on the Black Hat quite lately, related to the phishing pretext that threat actors are using, as well as specific references to the threat actor groups. So, for instance, job offers, like, do you want to work in our company? Yada yada yada, and then somebody follows along with job description or some other malicious documents. It doesn't really matter what file formats they used. This presentation is mostly concerned about the pretext they were using instead of the macros or not macros. This is not that much relevant here in this context. But the gimmick of this entire big hell of a slide is following. Firstly, if you are going to be targeting, for instance, Office 365, then you are in luck, because you can set up your own Office 365 developer program, free of charge subscription, that when Microsoft gives you access to the Outlook, then you can also spin up pretty cheap Microsoft Office E3 or E5 subscription that will give you access to the Microsoft Defender for Office 365, as well as Defender for endpoint licenses, and then you could use those to plug in your MDO, Office 365 scanner, so to say, and then try to send messages from your, for instance, Gmail controlled account to your Office 365 controlled account, and then exchange emails back and forth, seeing what the SMTP headers are popping back on your developer program account. Then you might be having those SMTP headers coming back to you, and you could use those to see whether your HTML message, whether your phishing email will be actually having some chances to get past the target's perimeter. Even if that target doesn't use Defender for Office 365, you can still somewhat apply the same conclusions drawn from one email security gateway to the others, regardless of what they will be using. So this is one of the ideas you can equip yourself in order to kind of up your chances. Other than that, there's a notion of domain warming. So there was actually a question, I think, coming from Pepino, if I'm not mistaken. What do we do? What are the tricks behind actually getting our domain somewhat trusted? So this is a natural big problem. We end up purchasing a domain. Then 4 months later, we plug that domain into our red team op, and we believe that if we just throttle down the number of emails being sent to the target, we'll be actually reaching their inboxes. But it turns out it's not that easy anymore. It used to be a few years back, but these days, the email scanning solutions, they are more likely to actually blacklist the email based on some fuzzier concepts, based on some fuzzier observations. So, for instance, if there is an email that haven't been seen, if there is an email coming from a domain, the domain hasn't been seen across any email sending providers databases, like for instance Microsoft Defender for Office 365. It maintains its own database full of well-known email domains, like the domains known for sending emails. If this domain hasn't been seen in the world sending an email, and now all of a sudden it just sends the email to that protected customer, and it just so happens that this email coming from previously unseen domain contains attachment or link, this is an immediate junk. This is the rationale behind those scanners. So firstly, we've got the domain. It just sent an email. That domain was never seen across the world. That email contains link or attachment. This is anomalous as hell, and it's gonna make a no-brainer decision for considering that message that just reached the customer's inbox as a junk. So what we can do about it? We need to think about making our domain resemble a well-known email sender. So if you have a chance to use your just registered domain, send a bunch of benign emails written by ChatGPT to various Office 365 protected recipients. Maybe also your own. If you can set up like 2 subscriptions, 2 developer programs, and you've got like 2 different tenants in Office 365, you can send your benign message written by ChatGPT against your own controlled inboxes protected by Defender for Office 365. Then, if you can just send bunch of absolutely random messages to non-existent recipients, like NDR, non-delivery report, to some blah 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 małpa, sorry for Polish, blah 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 at contoso.com, then your domain will start figuring here and there across the thread feeds, across the logs, across the databases, and this is what we call domain warming up. It just means to send 20 emails against random targets just to make sure somebody did take a note that, hey, I am sending emails. This is expected from my domain to be sending emails. This is going to in a kind of a fuzzy, twisted manner, increase our chances for the delivery. Then another thing is that if you can establish a multi-step conversation with your recipient. So instead of just throwing away very first email in a fire and forget manner and then just delivering the bloody attachment, instead send an email with hi, somebody will respond you with hello, then you're gonna do a little bit of a social engineering there. Naturally, it isn't that simple, but the idea we like to do is that, hey, I am having this unpaid invoice. Somebody will write you back, hey, I am not expecting an invoice, and besides, I'm not even working with the invoices. Are you sure you've got correct email, correct address? you'll then answer, can you point me to the right direction? What is the expected procurement team email address? Something like that. Then at this point, you have already exchanged a few emails with that domain, with that tenant, right? So your domain is becoming more and more recognizable as you exchange more and more benign, legitimate emails. After a few of them, you can then finally take the final blow with sending an email containing a link. And the idea is just to make it stupid simple. Don't be tempted into using some fancy HTML code in your messages, because most of the times there are some undocumented opaque logics behind whenever one HTML is considered bad or good. So also what we found working absolutely the best is that if the employee is pretexted enough, he's already working on the assumption for receiving something from you, that employee will be actively looking to receive the file by checking his junk folder, by clicking through all of the warning prompts, messages, and also those reminders that, hey, this message comes from the external address. Beware of clicking links if you don't trust them, right? You probably already seen those protections, those reminding countermeasures applied by mature environments when the email is preceded by this reminder notice message telling in yellow or red that, hey, be cautious about clicking on links in that email, in that message, because it comes from outside of the organization. We can lure victim into cooperating after establishing a very well-funded pretext, which takes time and efforts. So simply put, if you want to be successful against Apex environments, you need to be patient, and you need to be charming and very helpful and very much lost and requiring help from another fellow. Otherwise, it's not that simple to deliver files any longer. We also found to be devastatingly, to be wildly effective, to be interacting with employees outside of emails using any kind of channels. I've seen phishing popping here and there. Absolutely great idea. Just simply call your victim, explain that victim is about to lose access to the internal resources because the Global Protect VPN update was released, and he failed to update Global Protect in time. So either he loses access to the intranet, which will force him to get back to office, which under the work from home circumstances nobody really wants, and then that victim will be nicely cooperating with you towards downloading MSI and such. Nick has a lot of war stories with phishing. If you want, let us know. Maybe you would like to describe some of them in the Discord. Maybe like without any sensitive details.
Well, I have a good story about this. I started phishing when I have first red team as leader. The client the client uses Mimecast protection, so my emails couldn't deliver to the victims. So I used the phishing in order to find another solution. Because of COVID-19, a lot of companies, especially in Greece, used some external VPN services. So I used the Modliska to clone the website of VPN. Exactly, it's not a clone. It uses only a proxy between the victim's website and my server. I found from LinkedIn um, a man from accounting. So I called him. I said that I'm a new colleague from IT. I have a request from his IT manager. By the way, his IT manager was working there for 10 years, so everyone in the company knows him. So I said to him, we are building a new VPN infrastructure, so your credential doesn't work. We have some notifications about that. I have already sent you a mail, but I didn't send him a mail because they have Mimecast. He said me, I don't have a mail, so I said him, okay. I don't know, probably it is in spam, in junk mails. By the way, we can use this URL to unlock your account. I fixed Modliska in every request to return again login page in order to see that it doesn't work. So he opened the victim site and he put his credentials. I took the credentials, but they have MFA. So I said to him, I will call you in 2 minutes. After 2 minutes, I will call him again. And I said to him, okay, in order to establish all settings, you will receive a pop-up. Okay, please accept this pop-up in order to establish and save all settings, and everything will be fine. And that's it.
That's cool. That's cool. So it looks like a very well established pretext here as well. Thanks, Nikos, for sharing. So as you can see, it isn't that hard to just talk somebody into helping us out, or maybe helping himself. Just be Kevin Mitnick yourself, and you'll find how easy it is to approach employees over the voice channels.
Sorry for this. I want to add something. A lot of times after this, I found strict to use a domain, as you said, because a lot of companies uses whitelisting in their domains in order to protect external domains. So in order to bypass this, you can use a Microsoft domain from Azure. It's absolutely free if you have an Azure account. So most of times it bypasses the firewall because all the infrastructure is made by Microsoft, and you can this domain you can use this domain to bypass all whitelisting filters.
Okay, that's great. That's cool story here as well. So as you can see, based on the Nikos example here as well, if you haven't yet tried calling directly to your victims, or maybe reaching them out over WhatsApp or any other channel that isn't an email, try to incorporate such a scenario, sell it to your customer, hear whether he's actually interested in pursuing that avenue, and you'll be surprised about that. You'll be surprised about the results. Naturally, among the quick wins, we know that there are text message gateways that let us spoof the caller's number, that let us send the SMS messages over the spoofed identity. So that's something we've been using. Just the registered for the exercise SIM cards, along with some calls, and then followed by some very nicely very well laid out pretexts are also going to be quite convenient, especially if you can combine phishing, calling to your employee, with the Teams phishing approach. So the Teams phisher, you probably have came across it already. If you haven't, you are missing a lot of fun here. Teams phisher, actually a tool weaponized by Alex Wright, Oktoberfest. It works by using your external Office 365 tenant to create a group conversation with your victim. Then the victim is going to be added twice to the conversation. This This configures the teams into creating a group message and allowing external tenants to create a conversation with your target tenant. So you've got your external Teams tenant, you've got your target tenant, you have this one-to-one conversation with your victim. You just called him. We are about to update your VPN. Can you help us out? He's gonna be collaborative. Then you're gonna send him a message over the Teams. That message will be containing zip archive. In the zip, there's going to be the MSI installer. You have the story. That's something we've been also using. Actually, we only use it once, so I'm not very much. I don't have this like plenty of exposure to that particular social engineering pretext, but it worked absolutely like a breeze. Also, you can also try to invite users into webinars ideas, like we've used, like we said before, working off their interests. Kubernetes developer will be very tempted into free Kubernetes book, or maybe Kubernetes slide deck, this kind of stuff. So OSINT, Recon, and once again Recon. Okay, back to the story. So domain warming up, that's one of the ideas we can use. Try to leave the URL sending for the absolutely later stage of your conversation. And then what we found to be working somewhat reliably was that pretty twisted architectural layout. I don't know if you can see here. Here, let me just go for the green screen, for the green drawing here. GoFish running on our physical server that we had back in our office. That GoFish. Then we are creating the profile to communicate over the Google Suite account. On the Google Suite account, we've got our attacker's domain, configured in the Google Suite, and now GoFish authenticates to the Google using those credentials we just exposed. Naturally, you would need on the Google Suite to configure to enable so-called legacy protocols, so that GoFish can actually reach out to the Google SMTP, well, over SMTP, because by default it's actually disabled. Now GoFish pulls the traffic over to the AWS straightforward micro instance. That micro instance then has exposed socket listener on 507, which stands for SMTP, the secure SMTP protocol, and that traffic pulls the traffic down to the smtp@gmail.com 507. Now we've got this mail relying but authenticated one. When we just push our traffic through a complicated set of next hop servers. The thing is, the gist of it is that we want to blur away, we want to hide away what was the original server that created the message. Problem is that naturally we know that GoFish exposes its own header. We can get rid of that by simply recompiling GoFish executables. That's first. Secondly, we can lose the track of the GoFish host name by just pushing it through that AWS redirector, and we are believing that probably when the Office 365 seen messages pushed down that chain of servers, probably the reasoning is following. Office 365 considers that, hey, this message comes from SMTP Gmail.com servers, which I trust. I trust Gmail servers because this is a very well-known email services provider. But then I'm going to look for the very previous hop that preceded that Gmail server, and now I see AWS IP range. Now the Office 365 there needs to be some relaxing rule applied by the Office 365 administrators that tells if the email comes from the very well-known email services provider, like the cloud environment is, because AWS exposes this service called Simple Email Service, SES, right? There's this AWS SES. probably there is some reasoning behind that Office 365 maybe just falls into trusting that this mail probably comes from the SES endpoints, which is something I have to pass, I have to accept, because otherwise plenty of email marketing campaigns would be failing across the world. So since those MailChimp and other services selling the email marketing functionality, they have to exist. They are also using cloud assets such as OVH VPS service, or the Google or the DigitalOcean droplets, or maybe AWS email sending services. Since they exist in some way, there has to be some whitelisting applied on those Office 365 scanners or so. If message comes from AWS, then trust it, because this might be SES. This is what we are trying to naively abuse here. Naturally, this is the explanation is merely a far shot. No one of us is having access to the documentation. Hence, we can only explain what we intuitively can feel. This is only a speculation, right? But it looks like it kind of works. Other than that, it goes without saying that you have only like a few chances. We've seen that we can send most not more than 5 emails probably from one domain, until Office 365 begins throwing our further communication to the junk, unless we establish successful conversation back and forth with the employee beforewards. It is absolutely crucial to establish a conversation with your target before you send URL, before you send attachment. Otherwise, you will fail. This is at least aligned to my experiences. Then, with regards to the proxy, we've got some questions hitting up. You have some information regarding CDRS banning. Did a lot on that on the past, but I don't use it anymore, because on one exercise I blocked Zscaler AP pools, which was used by our victim. It was really hard to troubleshoot. Yeah, well, I used to be using ban lists, but I also failed once or twice. Hence, we all get that feeling that this is just not scalable approach to the solution. I know that there is a very, very well recognizable fellow, Vincent Yu, and Vincent tells me that his secret sauce for successful fish is just to maintain this big ass full of seeders that he updates every time he sends a fish. So probably there is just some there is some success to this madness. If you have energy, efforts, and patience to be collecting, naturally you might be successful, but it takes a lot of work to maintain such a list. Myself, I'm not using it because of that problems that arise. A lot of user agent filtering, yeah, but user agent is just so shakeable. We know that all the vendors can just impersonate user agents, so there's just not much. Yeah. Then proxy. Proxies are going to be reacting on our DNS based on the DNS characteristics, on their categories, and then on the HTTP request URL, maybe some headers, and then on the responses. If there is an organization that doesn't let its employees to download executables from the web services, then the easiest solution to go around the proxy policies is to use HTML smuggling. Ever since we learned about that idea, like 5 years ago or so, after Outflank's article, we've been incorporating it to all of our deliveries. I cannot really recall when was the last time I didn't use HTML smuggling. It has to be equipped 100% of the times. Anytime you want to deliver the file, it needs to go through the HTML smuggling. End of story. If you want to get past some HTML, some proxies, and the reason being is that there isn't any silver bullet for detecting HTML smuggling. If you use HTML smuggling, it just revolves around some creatively crafted JavaScript. You can obfuscate that JavaScript as long as it can get, hence bypassing the proxy. So Then secure DNS. I just need to ramp up on the pace in order to kind of maintain the timeline here. But don't be worried that we might not be able to wrap up all the slides today. If that happens, and it happened to me during the past sessions as well, so that's absolutely anticipated. If we won't be able to wrap up the slides, we'll just move them for the tomorrow. Tomorrow's day is a little bit more relaxed compared to these days, so don't worry about it. I promise I'm slowly wrapping up DNS, AV, EDR, and that's all to it. Okay, the secure DNS. Whenever you register, purchase a domain, it wouldn't hurt. Actually, it is quite important to always go for some well-renowned domain threat intelligence interface, and then see what characteristics are hitting back on your domain. You can see here my B1 OIT is untrusted. That's a boomer. Wouldn't use that domain during the actual gig, right? If that's the case for your domain, what about my binary offensive? Maybe that's one of the ways you can check your own domain's reputation here. That's actually unknown. Other than that, you can naturally also put it into the virus total and then see what sticks. You could see whether there are some hits coming back on your coming back on your URL. Not to mention that a typical straightforward whois, I like the whois XML website. You could also just fetch some absolutely straightforward characteristic of your just purchased domain, like see if you have just exposed some of your own private details. Like I am here, that's exposing some addresses, but this is fine because this is just my legal entity registered here. I have nothing to hide, but you get the drill. Just a straightforward set of characteristics. First and foremost, I would say that probably the expired domains approach doesn't work any longer. It doesn't. It doesn't apply. We used to be purchasing domains previously expired, assuming that we'll just reuse their credibility and their categories. It doesn't work anymore because of the fact that threat hunting vendors, and they are maintaining an actively updated list that is proactively looking for the expired domains, as well as the SNI TLS feeds. I just forgot how was this. What was the name of the service? You know, when we acquire the Let's Encrypt certificate, that request is going to be occurring in the database full of those SNI requests. Just forgot that interface for pulling that information. So threat hunters, the EDR vendors, they are naturally taking an eye on those lists as well. Therefore, this approach doesn't really scale any longer. So what works? First and foremost, if you can use somebody else's domain, if that's even possible, maybe instead of sending an email from your purchased domain, if you can think of a pretext coming from an individual email, like, hey, I want to apply for the job offer. I am reaching out to you from the Yahoo or maybe Hotmail. That's gonna be totally fine as long as it fits your pretext. Otherwise, if you want to impersonate the domain, well, naturally, it goes without saying, purchase the domain soon enough. Then you might be tempted into going for the categories like the blue code category domain, this kind of interfaces. Long story short, this approach doesn't really work. You can really suggest some categories for your just registered domain, but you'll see that most of the times those categories won't be actually applied on your domain disregarding your request. So the tricks behind submitting your suggested categories behind your fake domain, I would just toss them away. That approach doesn't really scale and doesn't really apply anymore. long story short, the best we can do is just to purchase the domain with a great just soon enough before the training kicks in. What we do internally, we are just purchasing batches of domains every quarter, like during the when the year starts, then maybe after the Q1, and after that we're just kind of purchasing the domains we feel that might be usable under certain pretexts. So just making an investments. Then we are naturally making sure that they are going to mature enough before we can use them. Sometimes we are applying those categories because even if it doesn't work that much, maybe it wouldn't hurt to apply some categories. Actually, we've got that implemented against a bunch of providers. Bunch of providers didn't expect CAPTCHAs, so we could just simply automate the process for suggesting categories against domains. Hardly they are actually applied, but you get the drill. It doesn't really hurt. But then again, the best we can do actually is use somebody else's domain. Cloud assets is the way to go these days. The more clouds have to offer, the more services they have to offer, the bigger the landscape, the bigger the window of opportunity for us. Plenty of services, platform as a service, infrastructure as a service offerings, they expose the URLs to the assets we have just created. Take AWS S3 bucket for an instance. We got S3 bucket. It lets us configure the static website. We upload the HTML. We got the URL back. That's a win, because now that we have somebody else's domain, Amazon AWS, we also got their TLS certificate along with their credibility and their trustworthiness, right? So it's absolutely great. It's absolutely great to be having that. Question. Guys, let's just skip with the questions channel. Let's just keep only questions there if that's possible. Otherwise, let's just use maybe threads, the rep list to the messages, because otherwise it's gonna be just okay. The queue is here. Afai, is your slide 32, the last screenshot bottom left, does still work? Afai, providers like Azure, they block such provide. No, actually, Azure Front Door, Azure Edge CDNs, they still let you register your own CDN and then push it towards your own attacker's infrastructure. So absolutely still relevant. You can still use Azure Edge CDN. You can still set up Azure Front Door. Even you can automate it with Terraform. This is something what I'm doing myself. So this still holds useful. But then again, it really depends on your environment. For instance, in my bank, in one of the banks I work with, there are naturally, like in every other bank across the world, there are some local divisions, right? Well, Polish bank division, German bank divisions, and so. Some of the times, in some organizations, those divisions will be allowed to have their distinct set of policies and distinct set of technologies. Let's just assume that in my bank, across the several countries, for instance, domain fronting is being actively detected by the tailored custom rule that the threat hunting team has put up, and that rule was quite clever. If the host header's value differs from the actual peer's endpoint domain, then this is an attempt for the domain fronting, and this is going to be causing some signals, some alerts. Some divisions in that bank have that role plugged in. Other divisions in the same bank that might be using services of their local SOC, they won't be having the same rule applied. Therefore, you can still pull off that domain fronting trick against them. Hence, this is a little bit unpredictable. Sometimes domain fronting will work for you. I would say that the domain fronting still works against plenty of clients I work with, but some other mature ones, mature blue teams that actually had a red team at least once. They've seen that tactic being used against them. They actually made efforts to close it down. They will got that sorted. Q. What about domain fronting via DOH, the DNS over HTTP, TrustWave? So I have to be honest with you. I myself haven't been using that. I know that my colleagues use it in one of their exercises. They used it for the egress. Actually, there's I think Austin Sec Idiot put up that Titan loader UDRL for the Cobalt Strike that is implementing DOH egressing functionality on the GitHub. If you're interested, I can link it over to you. So I think that they have used it with a great success, but for the domain egress, right? For the communication egress. So that was something actually useful. Myself, I haven't been plugging DOH yet to my gigs because I just really didn't have to, because most of the times using serverless redirectors, like I am using 90% of my ops, I am using AWS Lambdas, serverless Lambdas for my egresses. AWS is doing absolutely bad job detecting abuse of their services compared to the Azure. Don't you ever be tempted to use Azure functions for your serverless redirectors, like pushing your Cobalt Strike traffic over the Azure functions? Don't you do it, because myself, we found that Azure turned down our entire subscription after 1 week of abusing Azure functions. So Sentinel, that's AI machine learning driven anomalies detection, it actually did work against us. They got us busted, turned down our subscription, and then undone our several hours work of workload for setting up all the services. Hence, don't you play with Azure functions, but do play with serverless redirectors, especially against the AWS or the DigitalOcean droplets, because they work like a beast. 90% of the chances, as long as your target environment accepts traffic coming outside to the Amazon AWS. Recently enough, Microsoft announced the functionality called MS Dev Tunnels. I haven't been playing with this myself yet. I just wanted to have you the absolutely cutting edge, latest updated slide deck. So I'm leaving it for you to play with. Dev Tunnels, I've already heard that guys are using it. It's like ngrok. If you have ever used ngrok yourself, Dev Tunnels are just like ngrok, letting you expose your local services, local servers that you got behind NAT in your home network to the outside internet. And then they give you the URL back. So you can run your Cobalt Strike on your Kali VM and then get a pretty cool devtunnels.ms endpoint that would just redirect traffic down to your local VM. It's absolutely terrific idea, especially given the fact that will be provided free of charge with the Microsoft TLS certificate. That's a quick win. So, long story short, if you can abuse cloud services addresses like Windows.net, Cloudflare workers, some CDNs like Azure, StackPath, maybe Alibaba. We've also been using personal cloud drives for hosting malware, especially SharePoint kills a bird with the fact that in some organizations, in some banks, I have seen that SharePoint was added to the intranet trusted sites. Like, you can only imagine SharePoint.com, wildcard that SharePoint.com sometimes gets added to the trusted sites, which gives the implication that macro-enabled document downloaded from SharePoint.com won't be affected with mark of the web flag. I'll get back to this later on. I'll bring up that example once again. Just really need to rush to the end of this section because we are having it far too long. AV. Long story short, AVs are only successful during the cloud reputational analysis and whenever a file touches the hard drive. I would say that this is the only moment where the AVs are actually shining their capabilities. We know the drill for the different signature types. Static signature, which is Yara-like, looking for byte patterns, absolutely straightforward to shake off. Just write your custom stuff or apply some packets obfuscators. You got it. Heuristic signatures are a little bit more complicated to get rid of. Like for instance, imports hash, imp hash. So they will require a little bit more finesse to it, but still pretty shakeable, especially when you write something of your own, custom-based malware, or similarly, you apply some packer, especially the lesser-known packer. That's gonna get you nicely shake off those heuristic ones. Behavioral signatures, on the other hand, the AVs aren't doing the great job determining whether the executable is behaving or not. The shortfall for AVs is that, and I was told during my very first weeks when working in Asset, that AV, first and foremost, needs to be reliable, stable, and favor least false positives rate. So AV cannot absolutely accept throwing false positives. This is what they do. In that regard, AV doesn't come with any threat-specific detection or remediation. They don't have any Guku, buzzer loader, or any kind of crypto miner specific logic implemented in them, any feeds, anything like that. They tend to be as generic as possible, hence why they'll file short behind the EDRs. But then again, EDRs nicely complement AVs. EDRs are mostly concerned with the behavior layer. They're mostly concerned in what is going on in the system, whereas AVs, they mostly judge us by our look, by the way we look. So AV takes the file, rips it apart. EDR isn't that much concerned with the file. It's mostly concerned with what the file does. It doesn't mean that EDR doesn't scan through the file. It does, but EDR is mostly concerned about telemetry. I'll get to that. So naturally, the only moment that AV comes really hard to get by, to get around, is the cloud reputation scanning, which, for instance, McAfee is quite good at. And then whenever there is an on-write or on-access activity happening in the system, when we drop the file to the hard drive. In order to combat that, as we said that previously, first and foremost, at any capacity, we shouldn't be dropping too detectable, too noisy, too well-known malware or arsenals or just tools to the hard drive. Try to only save whatever you need, and always something custom, something lesser known to the hard drive. And in order to combat cloud reputational analysis, the rule of thumb is we'll be better off using DLLs and scripts instead of executables these days. But we'll get back to this discussion during the day number 3. There is also a very niche area for bypassing cloud reputation by backdooring existing legitimate software and then pretending we are just another version of the same very well-known Firefox.exe. This is where the cloud reputation scanners also fall short. I'll get back to this in day number 3. So AV is mostly about contents of the file, how it looks, has it been seen previously, or maybe does it exhibit some traits that are generically telling that this file might be suspicious. Like, for instance, the file was treated with the Temida protector, with the Temida obfuscator, which is kind of a SUS. The EDR, on the other hand, was created to fill the gap where the AV couldn't really fill. EDR tends to be threat specific. EDR is mostly based on the feeds, on the threat feeds it is being fed with. So there is going to be this. So behind every EDR, there is going to be that threat intelligence team that is collecting feeds, putting up together all those Sigma-alike rules, signatures, looking for instance, file names, paths, registry. Can you hear me well? Because we've got some rainy weather here. Is my voice still recognizable? Okay, you can hear me well. Let me know if I become undigestible because there is some raining behind the window. Okay, cool. So EDR is all about telemetry, and it is all about comparing, making sense of all the telemetry collected and correlating it with the feeds they have on us. So if there is, for instance, a command line switch and the EDR sees that somebody used that command line switch, then there might be some event coming back telling there is something shady coming in the system. Also, if the malware just tried to open a process and then mess around with that process memory, then this might be constituting a chain of signals that will then correlate into a proper alert. Hang on, give me 1 minute. Give me just 10 seconds. I'm going to close down the windows because I don't hear myself. Sorry about that. Just 1 sec. Slightly. Yeah, it's a good radar. Okay. So with regards to the EDRs, since it's all about telemetry, we'll be trying to incorporate set of tactics in order to either not leave too much of that telemetry behind, or just leave the telemetry that isn't yet recognizable by the EDRs, or even maybe try to overly flood the EDRs with telemetry so they don't know what's going on anymore. There are a bunch of ideas we'll be using in order to attack EDRs by their design. Let me see, any questions? Okay. Then here, for instance, you can see another absolutely great aspect of EDRs, since they correlate signals into events and then events into alerts. A great off-the-shelf market-leading EDR will give us this, will give analysts this console for further understanding what was happening in the system when the alert occurred. Here, for instance, we can see that EDRs are very good at correlating parent-child relationships, as well as trying to match different events with the parent, with the processes that generated those events, giving the analyst ability to understand what was happening then. Here you can see my example. This is a defender, and you can see that there was a sharp PRT executable that attempted to access primary refresh token that is used to steal token credentials for the Office 365 user in order to impersonate him from the attacker's machine by bypassing MFA claims. So that tool, it actually attempted to access the PRT, but guess what? Can you spot on this very image something that is concerning here from the blue team's defender's perspective, and very promising, tentative from the offensive perspective? Can you see a little bit aspect of that screenshot that really shines us with some with some potential. It really gives us some hopes for pulling up the PRT attack, even though the PRT attack was actually detected. It doesn't really matter, because the PRT itself alert was rated as of magnitude being low, and this kind of supports what we've been saying so far, that we don't have to be paranoid that great EDR will see everything, because even if they do, the blue team, the SOC personnel will be just so swamped with their work, with the amount of tickets they have to process and close, with the amount of other tasks, calls, and other duties, they will just disregard low severity incidents. Therefore, we can get away with accessing and stealing PRT tokens, because EDRs just rates it as of a low fidelity, as of a low severity. Here, for instance, my tool Sharp PRT copied a browser core executable, which is one of the ideas for stealing PRT. It renamed it. So that process was used to extract PRT, and then EDR did a great job to correlate back that Sharp PRT was the parent of that offending process, which was then created off the CMD of the total commander. It tells us the root cause here. And what's even more concerning here, just take a look, that Defender, for instance, is able also to get some insights from the VM here on the VMware. So if you are running some shady stuff in your VMware, Defender will also be able to pull some telemetry from there as well. Here, can anyone let us know what caused the alert in this picture? So the analyst sees that kind of a picture here. What is the root cause here? What is the story? What caused the detection? What we could do about it? Acrobat is launching CMD, a pure anomaly to every seasoned analyst. Absolutely. Who am I? CMD. Great. Those are some great observations here. So the attacker here attempted to pull some initial intelligence, like the who am I IP config, what we could use to make it better, how we could make it better, how we could avoid using built-in who am I's and other stuff today's in 2023. BOFs, absolutely. There is none better technology than using BOFs these days, which is just running some piece of native code and then pulling the same amount of information from the same sources, but using the built-in mechanisms without following this all heavy fork and run .NET related execution primitives. So absolutely, probably you've seen a lot of threat actor reports denoting that lesser skilled threat actors, they are still very, very fond of using tools such as Net, Who Am I, RP, this kind of a built-in tools. So actually some attackers are still going on the path of least resistance for using those very, very well-known commodity tools built into the system. And as we suspect, all the EDRs that are equipped with the threat intelligence feeds, they will actively see for the employees using Who Am I too often. If you happen to run yourself Who Am I, followed by ipconfig, followed by net yourself in your own domain joined machine, you'll quickly receive a call from your SOC team. Then also CMD. So there's a parent-child relationship that doesn't really look any good here. The CMD was used to create that stuff. Naturally, this is why we're using BOFs. In BOFs, we don't create a child processes, hence no relationship whatsoever. And also EDRs, after being deployed, they are being set in that learning mode when they try to learn the user habits, learn the organization habits, for instance, browsing SMB shares, various file system paths, programs installed. So they will quickly learn that Acrobat has never been seen to be creating a CMD process. If there is an Acrobat somewhere across the Office, somewhere across the Microsoft Defender customers, if there is a signal flowing through the security Microsoft Security Cloud that Acrobat was seen spawning CMD, that's gonna be pure anomaly, because that shouldn't be that way. There is no legitimate scenario being seen, observed in the wild for Acrobat to legitimately running CMD, hence why the anomaly that will constitute into an alert. There's a queue. Is it smart to bomb SOC with medium or high alerts first from another source, then land? So the bomb, what you're referring is actually denoted by that alert fatigue idea, by just flooding SOCs with various very well-known or lesser known alerts. Well, we used to use it at the later phases of the engagement when we are told to be explicitly, deliberately loud. Then we are kind of a bombing and flooding SOCs with the events. But I don't think it gives us any advantages during the actual engagement. When we just try to blend into the typical user behaviors, there's just no explanation for being overly loud. Like after we breach an environment, we want to look, we want to quack and walk and behave just like the user. We just want to blend into whatever that user is doing, websites he's browsing, and the software he's using. This is the absolutely cutting edge approach for being a sophisticated threat actor, for just blending into the environment. And generating a lot of noise is quite the opposite of blending in, I would say. Now comes the final slide, and I promise to you, we're gonna be now doing some hands-on. Finally, I'm super happy that you guys survived that amount of theory block. I promise to you, no more heavy theory coming onwards. Just one last slide here. So now the absolutely greatest advice we can have 2022 onwards: fish to persist instead of fish to access. Whenever you are modeling and designing, architecting your initial access chains, think of ways to drop your bombs and then bail out as soon as possible. So instead of dropping your Meterpreter and then actively looking for Meterpreter session 1 opened, and then just immediately having your callback getting back to your infrastructure in the phishing to access approach, instead think of ways for only installing persistence when you have code execution opportunity. If you can run some code, don't establish connection yet, install persistence, and then bail out. This is the best we can do against mature environments, and to kind of derail the way the EDRs reason. Since the EDR looks for the chain of signals to correlate them into alerts, what happens if there is insufficient amount of telemetry for the EDR to understand what the heck is going on? EDR is expecting, let me now do some crazy drawing here. I'm gonna now, hang on. I'm gonna now equip my outstanding drawing skills. Oh, sorry, I just have to, yeah, my outstanding drawing skills. So we've got the breach, we've got the execution. Hang on, actually, I can do better. I can do, oh, sorry, I can do even typing. Hang on a sec. Yeah, we've got, we just dropped the file. Then, well, there was just a write file. Sorry, that was just the email followed by I don't know, Word, followed by write file, followed by execute the file, and followed by C2, right? So this is so this is a typical set of chain of actions that's gonna be undertaken by a typical classic threat actor, but we can do better. We can instead we can instead just try to kill that attempt in the middle by just simply going for the email word, dropping the file, and then nothing happens. But then next day, all of a sudden, there comes C2. So in order to do that, we just want to look for the ways for executing our just dropped persistence by somebody else's, not us, not the Word or Excel or any other program that was used to deliver your initial access, but instead just cut that execution in the middle. So now on the practical side, how to go about doing that? Well, for instance, COM hijacking, DLL side loading, and just DLL planting. Like in the infamous example, that doesn't work anymore. Don't you be tempted into using it. But we used to be dropping version DLL for the teams, right? And then the next day, the user get back to his workstation. He logged into the Windows. The Teams was started. That Teams would then pick up the version DLL, auto-starting our malware, right? There was a absolutely brilliant example behind that phishing to persist methodology, mental model. So just drop your malware and then wait indefinite amount of time until the system or somebody else picks it up for you. Scheduled task if it works for you. It doesn't work in my, at least in one of my environments, where the scheduled tasks are pretty are put under the very, very close scrutiny. But you may see that probably some of your customers will not be that much exposed to the scheduled tasks. So how about running from your LNK or from your MSI a command to schedule a task? Next time user starts, next time user authenticates, there's going to be malware being executed, right? Also, Office persistence like XLLs. There's going to be also an XLAM being discussed today. Outlook macros. Outlook macros are also terrific, often oversight way for running stuff. We'll be getting back to this mental model, but just try to bear in mind to look for the ways for installing persistence once you got code execution, instead of gaining the callback immediately back to you. Okay, let me catch up, see if there's anything I can relate to. Okay. Okay. Forward. First and foremost, very much in love in initial access. From all the typical breach stages that we all know, the initial access was also my beloved pony, and that was because I'm very much interested in development. In the breaching moment, it's just so exciting to have your beacon coming back to you, which kind of gets me bored. What happens afterwards? I just prefer breaching. So with that being said, I'm really disappointed, and it's really just such a shame for me to be actively observing when the Microsoft is actively killing the vectors that used to be working in the past and doesn't apply anymore, like for instance macros. So the gist of it is that initial access is getting increasingly harder and becoming an art, a domain of knowledge, and an area of expertise on its own. Hence, why we are sitting on this training today. If you compare the Windows thread landscape to the macOS thread landscape, if you have ever been actually sitting and trying to solve the initial access problem on the macOS world, you might probably have noticed that on the macOS there are merely a handful of files we can actually use. There are some JavaScripts for abusing JXA, right? But they are not double-clickable, unfortunately. There are some .app files, which are actually directories, that are somewhat double-clickable, but only when the file is standardized /signed, code signed. So also far from perfect. We could also pull off the macro streak against macOS, but then again, macOS is having the quarantine bit technology, which is an analogy to the mark of the web flag in the Windows. The macOS gatekeeper ensures that even if we run on top of the Office VBA macro, that Office application is going to be enclosed within the system sandbox, and some entitlements are going to be imposed on it, limiting what we can actually do from inside of our beacon constituted from the macros. But then again, macros still work. At least I've checked it like 4 months ago, I think. Macros even more. Excel 4 macros, which are probably no-go in nowadays against Windows Office suite. Excel 4 macros doesn't really pose any threat these days. On the macOS world, instead, the SLK files, they still do. So you can still pull off the SLK trick against macOS. And I am not an expert in the macOS initial access, but there is an absolutely brilliant tool on the GitHub maintained by one of the macOS red teaming gurus, and it's called Mystical. So Mystical nicely integrates with Mythic, and it nicely gives us a lot of choices for how can we come up with creating some initial access payloads on the macOS world. So if you are going to be having some macOS engagements anytime soon, and you haven't heard about it, I strongly recommend you trying it out. I added it to our notes. We'll share them later on the GitLab. But where am I getting? I am getting to the point that on the macOS we only have like few extensions, and it's freakingly complicated to get actually the code execution on the macOS. At least without talking the employee into clicking several different pop-ups and notices and providing his passwords. So this is the same route that the Microsoft is currently following. They try to close as many initial access vectors as they can. Especially this can be seen after introducing Mark of the Web. I have been on the forefront for Mark of the Web cat and mouse game because when I first had this training, Mark of the Web hasn't been yet enforced. Then they enforced it, so I had to change my slides. Then there were like few different bypasses for the Mark of the Web. So I used to be having one session when I was discussing bypass, for instance, OneNote or zip bypass for Mark of the Web. And then all of a sudden, during the next session I had, like 1 month later, that was silently fixed, silently patched, even without letting know the community. So it just indicates how aggressive, how motivated and focused Microsoft is towards closing all of the gaps they can, and then increasingly upping the bar for breaching Windows targets. But there are still some fun and cool ways we can abuse that still work, at least still. And I would say the following: LNKs, even though this is a threat known from like 2000, I think, like since 20 years or so, LNKs still work like a breeze. They still get passed through even aggressively configured EDRs, as long as the LNK itself is somewhat kept simple and short. Other than that, executables plus DLL sideloading, we'll be discussing them more during the day number 3, but this is absolutely the way to go today. These days, code signed executable that will eventually sideload unsigned backdoored DLL is the best code execution primitive we can actually achieve, and it's gonna fly past cloud reputation scanners and other ideas. So this is the best we can get, and even more. Tomorrow we'll be discussing a .NET variant of that idea called App Domain Manager Injection. Then the MSIs. We've been using MSIs for quite a long time. MSIs are also impacted by Mark of the Web, but I'm gonna show you a trick for kind of a, maybe not bypassing it, but just working around the mark of the web on the MSI world, and it's called transform files, MSTs. We're going to be discussing them even today. Then we got the click ones, VSTO, complex chains. Also, you can look for lesser maybe known or observed technologies to just auto it. Actually, there are plenty of threat actors using auto it, but yet we are about to see an influx and an increase of seeing auto it abused quite soon enough, and I think that might be because of how nicely it can integrate with the idea of complex chains that we're gonna visit tomorrow. Containers, ISO, IMGs, XLLs, this kind of stuff, somewhat can still work. ISOs, cool vector. OneDrive standalone updater has a scheduled task that is default. Go look for a DLL sideload. That's super cool, ISOs. Thank you for sharing. Absolutely brilliant idea. So as you can see, a great red teamer is a red teamer who has his own bag of tricks, right? So it's all about collecting those tricks and catching them all. The more tricks we have in our disposal, the more successful we'll be in the actual gig. So the current threat actors, they think in chains, right? These days, we are not really sending one single file like we used to be doing back in the old times, sending meterpreter.exe and in the attachment, right? And then seeing the sessions being flowing back from several employees. These days, instead, we're gonna use several different file formats linked all together to constitute a shady, bumpy chain that will eventually deliver the final code execution in some twisted manner. But in terms of chains, we'll postpone them for tomorrow. Today, let us see a bit on scripts, LNKs, and some of the basic concepts that will later on act as a building stones for the chains. Let us start with some scripting. I promised that there are only like 2 examples, very first 3 maybe hands-ons with the scripts, and then we're gonna drop those scripts for the good. So in plenty of environments, in plenty of lesser mature environments, scripts will still pose some elevated level of danger. So VBS scripts, J scripts, they still will pose the risk to the organization, especially from the internal perspective. If you can get access to the organization and then send the VBS script, maybe attached to the email, maybe not attached to the email, because that email eventually might flow through the Office 365 servers. So that's far from perfect. But for instance, drop it on the shared drive and then link the UNC path to that file in the email and then send that email to the internal employee, then you might still be having plenty of opportunities working with VBS. However, a downside is that Microsoft announced that VBS is going to be obsoleted and available only opt-in, starting with some future versions of Windows. Currently, I think they are deploying it on the Windows Server 2022 or so. So, long story short, VBS is going to be, well, obsoleted and disabled by default pretty damn soon. So, why are we even having this conversation behind VBS? Well, just to give you some, I'm just going to lay out some fundamentals on the example of VBS that you can then easily translate to other technologies, like I will show you later on. Long story short, HTAs, VBSs are not that much usable anymore, but there is one exception to it, and this is a JScript. It actually turns out that JScript is not going to be obsoleted anytime soon, but at least that wasn't publicly stated by Microsoft yet. And also JScript, since it is based on the JavaScript lingo, it is having some additional opportunities for us to further obfuscate it. I'll show it off to you later on. Now, whenever you're thinking of scripts, regardless of the technology, if you are writing your own script in VBScript, JScript, PowerShell, AutoIt, the first problem you're going to tackle is what do you actually want to achieve? When you got your code executed, what's going to happen then? So the one of the successful strategies is going to be file dropper, right? Just pretty straightforward notion for getting file from somewhere. That's going to be that can be either unpacking the file from itself in a stageless delivery, or just pull it from the internet in a staged manner and then dropping it to the hard drive. That's going to be absolutely terrific, absolutely brilliant, still reliable approach. Next idea, .NET to JScript. This is a sophisticated way for running .NET assemblies in memory, using some foundations that James Forshaw laid out several years, well, 5-6 years ago. We'll touch down on this. This is still my favorite implementation to have in the scripts. Whenever I'm thinking of scripts, whenever I am incorporating scripts to my initial access, most of the times I'm thinking of ways, can I plug .NET to JScript here, or Gadget to JScript? Is that going to be viable? Then XSLs, XLAM droppers will be going through those. One of the choke points for the scripts is the sole moment of running something from the script. You can, for instance, drop the file, you can save the file to the hard drive. That's going to be tolerated by the defender or other EDR. But the first moment you're attempting to run the file that you just dropped, that's going to be killing your script. So if you can avoid running any kind of commands from your script, if you really need to, there are plenty of ways you can go about running something from the script, like, for instance, popping a calc. In the day number 2, there is an appendix called macros, VBA macros appendix. I am there discussing like 6 different ideas for spawning a calc from the VBA code, which also translates to VBScript, JScript, and wherever. But rule of thumb, if you want to maintain lower detection rate, don't you implement the launching primitive at all, the launcher, the idea for spawning calc. Don't you even put that code into your script. That's gonna give you the opportunity to lower down the detection rate itself. Now let us see the very first example when I just want to discuss various bad smells and ideas that we should be rather more vigilant for and looking for from the development perspective. So this example, I'm not going to be bragging how successful or smart or elegant it is. Far from that. Let's just focus here on judging our own development skills. This is the code I have written. Now, before delivering it to the victim, before shooting it away, I need to play a little bit defender myself. If I was a defender, what would I focus on to detect and remediate the threat I have just written? Now, give me your ideas, what you doesn't like about the script, and how would you rework whatever you don't like. So by the looks of the script, what really stands out? What would you do about it? This is the proof of concept, first version of your sophisticated Trojan dropper. Now you're working towards making it lesser detectable. This is the second round. You just want to refactor the code. Names of executables, functions, and variables. Absolutely. Straight off the bat, we would rather want to disguise our intents by getting rid of the digestible symbol names. It's a great pattern to always prepend your variable names or function names with some predictable prefix, which then gives you the ability to write a Python script that will act as your obfuscator. So if you follow that regime for prefixing your symbols, a simple, straightforward Python script that will cycle through those symbols and rename it will be acting as a straightforward obfuscator. Then the exe. The problem with exe is that when we drop an executable, first and foremost, naturally, we don't want to leave the exe out there in plain because it really stands out, especially in the URL. It doesn't really applies anymore. This wouldn't really actually work against any kind of EDR protected environment. I take you that. But there is also one other lesser visible problem with exe, especially in the environments protected by the Defender. So in the Defender, when we execute the save to file function, actually there is an attack surface reduction rule, I think, that is going to react on the fact that save to file was used to save file with a name ending on exe. So if you save the file with .exe using a.db stream interface, and there is no other way in VBS world for saving binary files other than using a.db stream, this is just the only way for doing so. Well, there's also the open and put lingo, but if you happen to use save to file and you save exe, then this isn't going to happen. The AMSI will kick on and will forcefully terminate the W script, C script, or whatever process was running that VB script. And the reason being is that the simple, straightforward observation.exe followed by save equals known bad. So what we could do instead, let me now maybe open it in my VM. What we could do instead is that we can change .exe. Oh, sorry, it's not that. We can change .exe to, for instance, .jpeg. So just simply change the extension here, right? And then, in order to run that executable with renamed extension, we would need any idea how to run it now? What would you use to run such a blatantly renamed file? Anyone has any idea? Protocol handler? Well, that will be an overkill approach. Let me show you something simpler. So actually, I hope that's visible enough. Let me maybe increase the font size. Font size, let's just make it like 11, maybe even 12. Hit it with the Olecon host. Absolutely. Just use some low beam that simply doesn't care about the extension. Now let me show you what I mean. This is a autoruns JPEG, right? And now there are some low beans that just simply don't ask for the extension, right? End of story. And you would be surprised, this bypasses attack surface reduction rule AMSI. I promise it to you. Try it out yourself. Try enable Defender. Try the script that save to file. It should get whacked during the save moment. You won't see file coming by, and then when you change extension, that's gonna fly past the ASR rule. At least unless they have changed that, unless they have reinforced the rule that was picking it up. I actually implemented this in my framework, and I was just so surprised how straightforward that was to fly past that rule. So the exe is something we can naturally rework. Other than that, what will also function names, function variables? Surely, one of the simplest obfuscators is our code editor. We're gonna find obf_shell symbol and rename it with whatever, right? But don't be tempted with using two random names. Instead, maybe some English words, because using English words tends to expose lesser amount of uniqueness character in terms of the layout of the characters, thus turning into slightly decreased entropy of the entire script. So this is one of the things to be wary about. Any other ideas? So, any other ideas what you don't like about that script? Obvious IOCs that stand out absolutely right immediately. That that even a novice detection engineer would quickly pick up and made a Sigma URL rule out of them. Anything that we don't like about the script? URL, yeah, clearly, absolutely URL here. Just directly pointing to the file is absolutely the worst idea. Instead, we would like to put here some cloud-based landing page, such as S3 blob URL, or maybe Azure blob storage URL, and then host the file there itself, because naturally, firstly, we don't want to expose the extension of the file in the URL itself. Secondly, if we can hide the file name, that will be even better. Thirdly, we need to be very cautious about the domain and its characteristics. So that URL, it's gonna initiate the HTTP request, which is then going to be closely analyzed by the proxy, and then we're gonna need to do our best in order to get passed through the proxy by just using somebody else's reputation. So cloud hosting is the great example here. Encryption based 64 strings will get flagged. Absolutely. So some kind of a straightforward encryptions might contribute to the effective suspicious score of that script. However, by their own themselves, isolated, they won't probably make too much of a difference. However, naturally, they will contribute to the effective factor. Okay. Other than that, wscript.shell probably isn't very much good looking here. And actually, there's a trick to get rid of the com proc IDs. Here we are instantiating a com object instance, right? And that com is going to load the wscript.shell interface and then acquire an instance to that object and then invoke its static method called run, clearly. But we can do better with the moment of referring to the com object. And here comes the James Forshall tool called allofview.net. Absolutely great idea, Whiskers. CLS class ID. So in our C training tools, there is a tool called allofview.net made by the terrific researcher James Forshall. And after we double click on it, it's gonna list all of the registered com servers across the entire system, and then let us briefly skim through them based on their prog IDs, class IDs, and whatever, as well as inspect the exposed interfaces or methods. Let me show you what I mean by that. allofview.net is absolutely brilliant tool for researching what the heck is installed in our system, especially when you found yourself doing some kind of a local privileges exploitation analysis or so. allofview.net, followed by registry, followed by prog IDs. I am now listing all of my com objects, which you can find. I've got like more than 11K of different com objects installed in my system. Now I'm gonna go for the wscript, right? wscript.shell, and now right-click properties. We've got the class ID. So the trick is we're gonna copy the class ID here, and instead of using wscript, what I'm gonna do instead, Control H to find and replace, and I'm gonna use the so-called com moniker. The moniker is going to be named like new. New standing for instantiate a new object based on that ID. And now I forgot. I'm not sure. Should I add the curly brackets here or not? Or no? I think I should. So I'm gonna try with those. So the syntax is the com moniker new, followed by colon, followed by class ID. The only thing I am not really sure of is whether the curly brackets apply or do they not. And the funny fact is that this simple trick will get passed through several different static signatures, especially those especially those looking for the double script statement in the code. Here we've got here we have Justin Els from TrustedSec. He's having that repository called Extracted Defender. He collected results of Comial, another French researcher who were able to actually extract and decompile Lua rules implementing ASR rules in Defender. Here you will find a rule which I don't remember actual name, so I'm gonna just try to look it up. Maybe double script. Oops. Well, there was one of those rules that one of those rules was having the regular expression looking for double script references. Odie, I'm gonna get back to your question in a sec. Just let me wrap up with my thoughts. Okay, I think I might be having some troubles finding this real quick here. Just the thing is that double script can also be recognized by just simple regular expression. By using class ID com object reference, we are evading that straightforward dump approach for finding double script, hence, well, constituting a very cool and straightforward bypass. I don't recall the actual class. I don't recall the actual rule name. Maybe you will be able to find it out. If you are interested, I'm just pulling the repo. Now the question, Q. Def not sus, absolutely. What else? Yeah, entropy. I'm not sure what's the question here. Yeah, okay, so this is Odie. Could you show how to get the class ID? Absolutely. Maybe the pace was, maybe I just rushed too much through that. Sorry, I'm just trying to align to the timeline. Once again, let me just close it down. Sorry about that. Naturally, you'll have this on the recording, so even if you miss some bit, it's still going to be there. I'm making sure to have the OBS Studio capturing the entire bit, so don't worry about missing some bit. But let me just show it off to you right now once again. When it loads, another moniker besides the new that we could use is the following. The crate object can expect naturally the prog ID, right? But it can also accept the new followed by GUID. That's what we are showing right now. But also it can accept moniker called script, and the script, interestingly enough, it accepts URLs. Attacker.com followed by evil.wsc, WSC or SCT. SCT com scriptlet file. It's a file that defines com object. This is something this is a file type that we know from the squibbly-doo reductor and the infamous regsvr32 attack, which doesn't really works anymore because all of the EDRs, all of the blue teams adapted to that idea. So anytime they see the regsvr followed by the URL, they're gonna quickly react on that. So that doesn't really apply anymore. But the core functionality that we abuse here is the com moniker that creates com object based on the remotely hosted SCT file. So it's just another moniker that we can use here. Okay, alleview.net once again. So this is a repository. This is a tool that lets us review through the repository of all of the installed com objects. I'm gonna go for the registry, sort my com objects based on their prog IDs. Then I'm gonna find the interesting com object by its name. If you can just look for what is installed in there, you can also just scroll down and then right click on the interface properties. There you have it. Okay, now there is a method called run. Method.run, statically exposed method, could also be reworked. I actually found that doublescript.shell.run is being picked by the defender ASR rule, but I also noticed, and I documented in the VBA macros appendix, I also noticed that there is a dump, absolutely stupid workaround bypass for ASR. At least it used to work last time I checked, and it works by using different method exposed by the wscript.shell. Just pay attention here. I'm just asking you to pay a little bit of attention. I find it very interesting what we're going to be showing here. So now that I have wscript.shell, and I found that .run method was being picked up by the ASR, I thought to myself, is there anything else I can squeeze from the doublescript.shell? And I just forgot that there is yet another function that can be used in the doublescript.shell for running commands. And the thing is, yeah. Let me get back to the prog IDs. Here we've got the com server. Now, instead of clicking properties, this time I'm going to instantiate this com object myself. So I'm going to hit create object, create instance. Now we are creating an instance of that com object ourselves, because thanks to the James introspection tool, we have that ability to dynamically map out the interfaces exposed by com objects along with their methods. So now I see that these are the interfaces exposed by doublescript.shell. As you can see, there are 3 versions of the .shell interface. Let me now instantiate the first operations view. Yes, sorry, open dispatch. Operations open dispatch. Here is the list of static methods exposed by the wscript.shell. We can see what this particular object can actually is actually capable of. And we can see that it's capable of running commands. This is what we know so far. So we know that doublescript.shell exposes method, right? Nothing interesting to it yet. Let me get back to that object. Let's review maybe the last version, the last interface, right? The interface valued 3, the version of 3. Operations, open dispatch. And here what happens, to our surprise, we've got the exec method. Let me get back there. Well, actually, there used to be exec method in the previous interface as well. Sorry, I'm just mistaken here. Probably I just kind of mixed it up. But there is yet another method called exec. And interestingly enough, if you switch from run to exec, it used to be enough to fly past ASR rules. I haven't tried it anytime lately, but I think 2-3 months ago, it was still a thing. So using the James tool, we can double click on the method and we can even invoke it. Command invoke. Oh, that's uncool. So for some reason it breaks here. Maybe let me just invoke the run method instead. Okay. So as you can see, James tool can also be used to invoke methods if we please. So we can use James tool to inspect com objects installed, look for, I don't know, lateral movement, UAC bypasses, or even initial access launching primitives or so. This was enough to find an alternative to run and then refactor our launcher, the run launcher, into the exec launcher. This was enough to bypass ASR at some point. Now, what else? Naturally, IOCs. Well, every SysNet analyst will be firstly looking for the network traffic, the endpoints being used during the connections when the connection was being established, but also the HTTP headers. It goes without saying that we should be rather trying to blend in with the somewhat least unique set of headers. Here, for instance, it is very likely that this user agent may stand out, even though it looks pretty solid. It looks like it resembles Chrome user agent actually, but it may happen that across the entire organization there wasn't anyone using Chrome in version 86, and in that way our user agent will stand out. And now comes the quick win for the defenders. So in one of the environments I used to work with, the SOC team came up with that clever idea for writing threat hunting queries that will be building up that build up the dashboard for the unique user agents used across the company. So they have this dashboard listing all of the user agents flowing through entire bank environment. You can only imagine that we can expect they will be having like millions of different user agents, right? But actually, they show enough to me. They show it off to me after I failed with my delivery, and then they shown that they had like maybe 100 of entries on that list, meaning there's only 100 unique user agent strings used across the entire gigantic organization like the bank is. And the quick win for working with those 100 worth of user agents and not getting lost in them, they were sorting them based on the unique servers used to establish connection of that user agent string. So if you happen to have your Cobalt Strike and you configure and you hard-coded your user agent, and this Cobalt Strike user agent hasn't been seen across the entire organization yet, this is the first time that user agent is being seen in the organization, and it so happens that this user agent only connected to like 4 servers, this is going to be standing out. This is going to be highlighted that, hey, we've got anomalous user agent that only connects to 4 servers, as opposed to 100 other user agents that typically were used to connect to like thousands of different servers. So this kind of anomaly, they were able to coin it into the alert. And in that regard, when I delivered my Cobalt Strike, regardless of how sophisticated shell coding primitives launchers I used, they busted me because of the fact that I just used unique Cobalt Strike user agent, even though I was pretty sure it's gonna be looking rocket solid. But even though that was the case, that was when I came up with the idea, and also it kind of like overlapped with the Adam Chester's article. I'll get back to this in day number 3, where we can use a pretty ingenuine notion for retrieving the currently installed user agent from the system and then dynamically build user agent string. Simply put, before you build your own user agent string, you can go for the Chrome installation directory, like appdata, local, Google, Chrome, user data, and there is going to be that file called last version. Now you get the picture. All of the Chrome versions installed across the world will be having the same user agent, with only one bit changing here, being the var. And the var applies only in those 2 places. If you can extract the var dynamically, you can construct the user agent yourself, and that user agent will nicely blend into whatever user has installed. Simply put, read this file, last version, take this number, put it into user agent, you're gonna blend in. This was enough for me to kind of push back on their idea. Nonetheless, the attacker might not know that, so it just takes slightly more efforts to up our game, right? So HTTP headers among the other IOCs. Then finally, the target directory. Naturally, temp is probably the worst idea for saving the files into. Any particular alternative you would use for dropping your stuff to the system? Any of your preferred file system paths for holding your app data? Seems solid, but depends on detection rules. Yeah, well, absolutely. If you can get pretty deep into the file system, like into the app data Office installation directories or so, that's gonna be pretty solid. But one of the probably most abused directories I have actually seen, and myself, I also been using it pretty much, is just this users public, because it is word writable, so we can use it pretty heavily. But naturally, I understand that this can also be pretty easily picked up by the mature socks, right? So any attempts to writing files to this users public, probably not the stealthiest idea, but it gets the job done, and it's still far better than temp. You can agree probably on that. Okay, it is just about time to hit the dinner break. I can say that we are slightly falling behind the clock, hence why I'm just rushing so much. But then again, don't worry about not completing all the slides today. We can still safely just move some slides for tomorrow, or at least when we hit the 8.5 time slot gap. Then I'm gonna ask you if you can stay for a little bit longer to complete the slide deck, or would you like to move it for tomorrow's? So stay with me. Use the 45 minutes opportunity to catch a breath, maybe go for a little stroll, smoke some cigarettes, or maybe just use the opportunity to take a dinner. Also, if you have any issues, problems, questions, this is the best time to ask them around. I'm gonna quickly wrap up with my own dinner, and then I'm gonna get back to the Discord, and I'll try to sort them out one by one, if that's helpful. Before we head for the dinner break, let me finally see if that works. Okay, just one bit, because we made a bunch of changes here. I just want to see if those changes we just applied are gonna actually work. Oops. If you see that your batch files doesn't work, it means that Python would need to be set back to the Py instead of Python, because I just forgot probably to fix it up. Instead of Py, that needs to be instead of Python, needs to be Py. So we've got the web server running. Now let me see if we can get that dropper. C users public. Let me go the C users public and the VBS dropper. If all goes well, it should drop the file. Let me see if it really dropped it. Outruns. Oh, sorry, I just forgot to change the extension here. Naturally, we'll need to have JPEG here. Okay, dropper VBS. Looks like it downloaded the file. Okay, but then it failed to save it. So I'm blaming that probably the syntax for that com moniker is wrong. So instead of those curly brackets, I'm gonna need to strip them all from the curly brackets. This is probably my failure here. Let me see without those. Okay, it looks like it didn't really actually help much here. Outrun 64. Nope, I'm still pretty sure it has to be with the curly brackets. For some reason, it didn't really save it. C users public dropped. File exists, false. Yeah, probably something's going down the chain. In the 85, yeah. I'm right now trying with curly brackets once again, because I'm pretty sure it has to be with curly brackets. New create object. I'm just missing probably one bit here. Let me see. The first time we are using the object, are we actually getting here? Message box test. Okay, so it looks like it doesn't really fail here. So probably the syntax is all right. but it's just having some hard time with dropping the file. Launch command dropped. Okay, looks like I'm missing something here. Probably rushed too much with some changes. Hang on, let me just refer to my notes maybe. Okay, I'm gonna simplify that. Just drop the file and then carry on. In a troubleshooting manner. Still no lag. Drop the file, save the file, drop the file, pulls from the. Okay, that's quite peculiar. Why it doesn't really download? That's the question. Version, response body. So far so good. Message box downloaded. That's kind of unfortunate. Send. Okay, probably one of the ways to troubleshoot the CMD, the VB scripts, is going to be with C script, and then there is this flag called eggs, right, and then one dropper. No, actually, we've got send, we've got downloaded, then never hits the. Okay, I don't want to keep you waiting too long, so let us maybe hit the break time, and I'll try to troubleshoot it during that break time, okay? Because otherwise we're gonna be just staring there, seeing me trying to sort some nasty things. We don't want that. So let us now just hit the break time. I'm gonna just move my VM to the other monitor, and let's do the proper dinner break. And after that, I'll just show what was wrong. Question: the recording will be posted right after the day. So immediately right after we end it, right after we finish, like literally 15 minutes later, you'll receive an email coming from ClickMeeting with the ClickMeeting recording, and then 2 hours later, the same day, I will deliver the OBS studio recording, the higher quality one. Cool. Okay, let us now hit the break time. I'm gonna fix up the POC, and if you have any other questions, be sure to let me know on the Discord. Okay, see you in 35 minutes then. Cheers. Okay, guys. So we're back after the break. Just troubleshooting that the previous exercise that we were having. I'm now having the executable executing itself properly. Now the final shot is just to substitute that create object prog ID so that it uses class ID instead. And this is what I'm gonna do now. It's just the last kind of a blow here. So 1 sec, let me see if that's gonna work here. I'm expecting the executable to run now just fine. All right, my web server. One last try. Okay, so it looks like the culprit is in fact with that with the syntax here, the com object constitution. So probably. Oh, there we go. It just pains so much. Okay, so instead of create object, we had to use get object, and then instead of curly braces, we had to use no braces at all. So this is how we can get rid of prog IDs. I just happened to forgot the proper syntax here. So let's just substitute doublescript.shell and then create object into get object invocation, because apparently in safe in VBS, which is something I kind of forgot here, requires in VBS we can only use that moniker inside of the get object. So with this technique, we don't call doublescript directly. First and foremost, our VB script still runs in the hosted C script, the doublescript process. So anyway, there's going to be doublescript or C script being figuring on the process tree. So that's for sure. And also then we are still initializing the same doublescript.shell interface, the com object, the DLL that implements that logic. It's still gonna be there in the system. So that wshom OCX, yeah, it's still in there. We are just referring to it instead of its prog ID using its get ID. So here you get the picture. Let me now try it once again. So what we did here, first of all, we changed the extension of the hosted file to JPEG. This really doesn't make too much of a difference because that's still executable. And then in the place when we are running it using the indirectly with a lolbin that is a con hosting here. So that kind of works. The only problem we had was to change the create object to get object. So what I wanted to give you a gist of out of this example is that we can get rid of prog IDs whenever constituting com objects, and this applies across the technologies. So as long as the language gives you the create object, get object functionalities, as long as it exposes those, the access to ActiveX, then as long you can abuse those ideas discussed here. You can get rid of those com object names, as well as we will see in the next example, implement even as complicated, sophisticated code execution primitives like .NET to JScript. Let me now show you what I mean. So this is the first example. That was the first exercise. I take it that was probably the simplest, most naive exercise we could ever think of. Well, just straightforward VB script that simply pulls the file from somewhere. Isn't that much really fascinating, I take it. But let's let's discuss something more relevant then. So I'm gonna just see, yeah. Okay, now the .NET to JavaScript and its sibling gadget to JavaScript. So 6 years ago, James Forshaw told us about the fact that .NET subsystem was designed in a way to be interoperable across the languages, which means that if there is a language that gives us the access to COM objects, then we will be able to instantiate .NET using whenever creating instance for COM objects as well. And when we can instantiate .NET from such a technology, then we can abuse some .NET shenanigans to execute in memory a .NET assembly. So James applied some outstanding thinking outside of the box here, and he showed us how we can create a gadget that a simple straightforward class that when that he serializes, that when it's gonna be deserialized, this will instantiate its class objects a constructor, which then in turn will create a delegate type. Delegate is just a function pointer in .NET world, and that function pointer will point towards static method called load in the interface called assembly. So there is the assembly.load static method implemented in the .NET ecosystem that literally takes .NET assembly, meaning DLL or executable, bytes on input, and literally reflectively loads them in memory. So we've got reflective DLL injection by design, as implemented by the Microsoft engineers, disguised under the assembly.load umbrella. And then we can further on, after instantiating, after loading reflectively the DLL that will point, we can then use the dynamic invoke to invoke, for instance, our .NET assemblies static methods, class methods, and so on and so forth. So here are 3 different ideas how we can weaponize that primitive. This is the most straightforward, the simplest .NET assembly we can think of. Here we can run some shady code in the constructor of the class and then instantiate that object like so. Dynamic invoke, all to array, create instance, yada yada yada. Then also here's the command to use with .NET to JavaScript. Then also we can create a dedicated method that will be accepting some parameters, like we can see here or here, run me, and then invoke that method and pass the parameters from the script. Whether that's going to be VB script, JScript, or like we see in a second, we could also use, for instance, Autoid script to invoke the same interfaces. Not to mention that PowerShell is going to be also naturally compatible here. So long story short, we're gonna provide our .NET assembly, then we're gonna convert it to the VB script, and then we're gonna run that VB script or VBA script from macros, or just deliver the VB script directly. Now comes the Autoid. So I'm not very much experienced in abusing Autoid because of the fact that we were just having some better vectors, better ideas for the past years, but these days, since we are kind of pushed into the corner, we are kind of undusting and refurbishing the previously seen vectors, previously seen ideas, and the Autoid, it tends to be grasping a lot of traction lately. More and more traductors are actually using Autoid, as we can see, for instance, in the link that I'm just about to share, on the Discord. Here you can see, for instance, tweet coming from, I think, literally today. We've got Zerik's toxin here. Let me just show it off to you. we've got thread actor, missed voicemail, dark gate loader, and that dark gate loader, what it does, from the email message, Google Drive zip download, which is password protected, followed by VBS. Threat actors are still using VBS scripts within the zip archives, as we can see, followed by some further downloads from some kind of a website here, and then we got Autoit executable, which is you'll be surprised. Autoit is a code signed executable, and it's a self-contained standalone interpreter, meaning we can have one single executable side by side, accompanied with the AU3 script, and that's the pair of two files can be used to actually inject shellcodes and do some crazy stuff in the Windows system as well. And this is far from a new threat vector. It is actually, Autoit has been abused since several years by now, like since 10 years or so. But since, like I said, we are pushed into the corner, we have to, unfortunately, we have to undust old tactics, old ideas, and then reinvent the wheel and then reuse them because we just have to we just still have to keep on moving, right? And since threat actors are adapting those old ones as well, there is some rationale in emulating those actors' ideas and then seeing how is our customer's network going to react when being hit with the Autoit script. So that Autoit is loading shellcodes, and then we've got dark gate. So plenty of such ideas that we can see that are actually related to the Autoit. And as you can see, after installing Autoit, you'll find the examples directory, and in that examples directory, which is also something you can see for yourself in our repo. I have actually included the Autoit interpreted in our repo, which is looking for it. It's not here. I've got far too many Google browsers, Chrome browsers here. Okay, so when you go for the C training tools, then you'll find Autoit directory, right? And then you'll find self-contained 1 megabyte worth of an interpreter. You will find some hello world message box script that you can see for yourself how it works. And also you're gonna find in examples here, for instance. And those examples, I just picked a subset of them just to show you the ones that are referring to COM objects. As you can see, object create is just a shorthand for the create object, which means we can still constitute COM objects, we can still instantiate COM objects from the Autoit technology, and thus we could also implement .NET to JavaScript within the Autoit free technology. And this is something I'm gonna be doing first thing after this training, because it just occurred to me like recently, few days before this training, and since I had I didn't have enough time to come up with a proof of concept for you guys. I'm just giving you my my train of thoughts. Maybe you'll be the first to implement .NET to JavaScript in Autoit yourself. So so now that we have access to the COM objects from the Autoit, it just craves for being abused for that really purpose. And as you can see, there's a lot of threat actors undusting that plain old vector. Quite recently, we've got here January article from January, as well as a bunch of other ones, even from as soon as August. Here you can see some threat actor just lured their victims to the phishing URL, which then dropped the MSI. That MSI, I've got it on my hard drive. I was looking through it. It was just used by using the MSI wrap technology, a program that just takes exe, turns it into the MSI, and then executable is actually the Autoit itself. And then somewhere, I didn't yet figure it out, somewhere it takes, I think this is just the Autoit compiled, it then takes the AU3 script, and it just runs it right after. So MSI install drops a self-contained Autoit interpreter, which then runs included embedded script, which then delivers the shellcode execution. And this combined AutoIt combined with access to the COM objects gives us the opportunity to implement .NET to JScript in just a different lingo. So we don't have to be using VBScript or JScript. Just take any other tooling that has direct access to the underlying COM objects. Now, if you have been playing with .NET to JScript, you might have already noticed that that vanilla plain .NET to JScript outcomes are going to be probably very pretty much picked up by some antiviruses and EDRs, and this is quite expected from the publicly released tooling, especially the one that was released 6 years ago. However, and this pretty much aligns with my own experiences, to our surprise, it takes very little efforts to slightly adjust the script contents to make it still usable and somewhat slipping through the radars. Here we've got Istvan Todt with us, I think Hungarian red teamer, and he's shown us, and this is really pretty much aligned to my own experiences. He's shown us how one single line of code was enough to fool the Windows Defender here, Defender SAMC. Here you can see we've got JavaScript version of that .NET to JScript. We are merely messing a little bit with the object properties. I'm gonna delve too much. I'm gonna delve a little bit more into this shortly, right after this slide. So just a mild modification of the script will still get you up and running, even nowadays in a tightly locked down environments. And we've been using .NET JScript, Gadget JScript quite a lot, especially from the macros. Now that macros are killed, we are still using macros from the internal perspective after breaching at least one user and then pulling up the lateral movement using the internal phishing ideas. We'll still then idle deliver attachments with macro-enabled attachments internally over the email, or just drop them to the SMB shares and then point our victim to the SMB share documents. Now let us see .NET to JScript in practice and see what we can do to maximize our chances for still reusing it. So I have included in the training repository a pretty straightforward yet still capable shellcode loader. It's put in the C training tools rogue.net, and it's called generate rogue.net. It just takes the shellcode on input and then spits out. Then it constructs the C# code and then compiles it to the DLL or executable based on input parameters. We're going to use it to quickly compile a DLL, then turn that DLL to the script, and then we're going to see what we can do about that script so it comes a little, slightly lesser detectable. Now let me get to my VM, and let me quickly turn up the console here, training tools. All right, now hang on a sec. I'm just gonna open up my notes so that I'm not spending too much time. Rethinking those samples. Rogue.net. All right, we've got our generate rogue.net. We are being presented with a bunch of different use cases. As you can see, that straightforward shellcode loader is still quite capable. So you might squeeze it a lot to get yourself a nice .NET assemblies that you could just then plug into your own initial accesses. I really recommend you playing a little bit with it. But down to the chase. What I'm gonna do now is that I'm gonna specify this the architecture for my shellcode. Now I'm gonna point the tool for the C beacons HTTPS beacon shellcode. Exit process will be just fine. Then the output C, for instance, devel. Let me just create a directory there. C devel .NET to JS. All right, .NET to JS, and then I'm gonna call it just the beacon DLL, right? Okay, that's pretty straightforward. The script now constructs C# code, then compiles it to the DLL. Then what we're gonna do is that we're gonna go to the .NET to JScript directory in C training tools, and then run it with a following set of parameters. Firstly, we're gonna specify the language. Secondly, we need to specify the program namespace. Well, we need to designate the program namespace. So the syntax here is following: namespace followed by comma followed by class name. So that's what I'm gonna do. First we're gonna go with language. This time JScript. Then we're gonna go with the program namespace specification. So where do I get the program namespace from? The script actually it conveniently spits out for me. Also, all of those parameters are naturally customizable using dedicated scripts parameters. We've got program namespace followed by program class name. So program namespace followed by program. Then we're gonna go for the output file, cdevel .NET, and then we're gonna go with something like beacon.js, right? Okay, no. Oh yeah, actually the only missing bit, I am missing the DLL itself. So I need to go with devel.net to JS beacon DLL, right? Okay, if all went well, we should be having. Let me just remove all of those. If all went well. Yeah. Oh, there it is. If all went well, we should be having a JScript, script that will reflectively load Cobalt Strike Beacon's DLL in memory and then instantiate it, giving us the code execution. Okay, that naturally worked out quite well. But then when we take a look at it, naturally we'll start seeing some problems with the code itself. Namely, let me open it up. Namely, what, in your opinion, what don't we like about the script itself here? What's the first we would need to probably think about changing before we can actually, deliver that script? Any ideas what we can do with the script itself? Base 64 to base 32? Probably yes. Probably that's one of the ideas worth applying here. That's for sure. Well, changing the default vanilla template would naturally help here. So just by messing with the encoding algorithms, absolutely. Changing the function name, symbol names, absolutely. More than one string name change names, sure, yeah. And also probably we'll just need to figure out what to do about this big ass concatenated string, right? Because it really stands out, especially when you think when you take a look at the view sidebar here, minimap. It really stands out. So we'll naturally, in order to get rid of it, we would ask ourselves a question: is it possible to change from stageless, like in this case, to a staged delivery? So are we comfortable with pulling that shellcode from elsewhere? If the answer is yes, then simply remove the shellcode, simply remove that entire blob entirely from that script, host it somewhere on the Azure blob storage or so, and you'll be far better good to go. If for some reason you really need to leave that big ass hell of a blob here in the script, if there is absolutely no way you can go for the staged delivery, then we're gonna discuss some of the viable tactics shortly in a second, but let me just maybe face some somewhat simpler solutions first. Yeah, that the stage will be first. Absolutely. Well, stage delivery has its own cons and pros. So first and foremost, naturally, what has been already said, changing the names of the default functions. Firstly, we've got the debug. The debug function probably isn't really that much needed. Set version as well, because if you take a look at it, those two versions were either way just blank, so we can just simply remove them. Then we're gonna go for the find and replace. Ensure to match the whole world, whole word. Otherwise, we might be changing a substrings surrounding within the particular longer words, which is something that we don't want. So instead, just ensure that you've got match the whole world setting checked in the find and replace. So that will be one of the approaches, just renaming the symbol names, right? I won't be going through all of those. So that's for the starters. Then secondly, naturally, we could be even trying to shift some contents around, because there is no justification for having that function being left in the starting bytes, in the starting position of the script. Clearly, even more, since that particular function is only called once, we could even remove the function at all and just directly move the entire body of that function right into the where it was invoked by just unwinding it in place, right? So that will be yet another idea. Other than that, naturally, we can also apply some straightforward string splitting, right? So stuff like splitting long strings by concatenating them all together, like we have here in this case, in the case of ActiveX object. However, even if we mess a little bit with symbol names, there is still a lot of IOCs, a lot of hefty words being left behind, because the question is, what can we do about that particularly pesky deserialize _2? I'm not sure if I have ever seen any benign script invoking deserialize _2 function, not to mention transfile final block, get by account. You get the point. You get the idea. And now, to our favor, this is why we far better prefer to be working with JavaScript instead of VBScript. We absolutely dislike VBScript for its lack of features, for the fact how simple, how limited, how constrained that technology is compared to, for instance, syntactic sugars offered by the JavaScript. Because if you have been hacking around JavaScript a little bit yourself, you probably might have come across the idea that JavaScript is a reflective language, meaning we can, during the runtime, we can get access to the object properties, fields, and collect some information about those properties, their parameters, and so on, using the reflectivity feature of that language, which is something that is missing. The reflection feature is missing in languages like C++, for instance, or the VBS. So, since that's the case for the in the JavaScript world, we can apply a bunch of different obfuscation tricks seen from the thread actors, and instead of referring to the properties or methods using their hard-coded names after the reference parameter, the .1, we can also refer to them using the association brackets parameter operator, and refer to them by their stringified name, which opens up the potential for obfuscating JavaScript code quite heavily here. The same, another trick to apply in the JavaScript world is that JavaScript tries really hard to normalize the types of the variables here, right? we've got the array plus integer equals string. Now there isn't any obvious or kind of a understandable logic why did we ended up having string, but we can use that for our purposes, because we can split the strings in this way and try to further obscure and obfuscate our strings. So for instance, hello followed by empty array followed by world will equal to hello world, right? So this is one of the ideas we can apply to further obfuscating stuff. The same holds true if we even further complicate this. Here we can see that, well, comma out of the sudden comma was inserted instead. Well, this is quite counterintuitive behavior, at least to my taste. Okay, also we can even ask GPT-4 to write a JS obfuscator. Absolutely. So now that we've got those primitives laid out, let's apply them to the actual problem here, which is getting that .NET to JavaScript past some antiviruses, at least from the static perspective, from the static content perspective. So first and foremost, we're gonna need to ask ourselves a question: which keywords really stand out? Unless we are capable enough to write a Python script that would simply loop, iterate over all of the objects, and then extract their methods or properties and do it automatically. So actually, it took me a lot of efforts, but I actually managed to implement my own obfuscator that does just that. And with a potent JavaScript obfuscator, we can nicely fly past. I'm still referring to the static analysis protections, at least, fly past some antiviruses, some scanners, and then push forward to the second phase, being what are we going to do once we execute the code. But before we can do so, we need to work our way there. So we've got the string position. Now we know that we can simply obfuscate it even further, right? And this ends up giving us this very nice option. Hang on, I'm just looking if that's okay. For some reason, probably that syntax wasn't really much anticipated here. Okay, then we can do something about that dynamic invoke as well. The same holds true here. Create instance. Naturally, we can nest those obfuscations, so to say, as deep as we please. You get the picture. Now, naturally, once we got those, we can then also simply apply some further tricks, like create an array, right? Let me just see if that's gonna work. I'm gonna get back to my Chrome, see if that works. If that works, it works according to the logics of a straightforward programming primitives. We've got the array, then we are referring to its second object, and that's gonna constitute us with that string. That string is going even further. It's gonna be even further splitted. Okay, we got the picture. So this is what we can do about the property names and the methods, right? And then we could be trying to play some tricks with the with changing .NET interfaces names into their class IDs. That could be also somewhat helpful to come around with those. But what else can we do? Well, naturally, we would need to do something about that big ass nasty string here. So the first that comes to us, I don't know if you noticed, but there is this there are these magic bytes in here, right? There was this Florian Roth got this quite a relevant meme. Let me see if I can find it real quick. Yeah, there it was. There is this quite relevant meme made by the Florian once, where he kind of laughs. This is kind of a very malware analysis and malware researchers specific joke that whenever you are seeing a repeatable sequence of magical characters such as T, V, Q, Q, A, that's going to indicate that underneath of that base 64, there is something pretty much repeatable, recognizable, what you have seen in the past, which in this case, in the case of DSMEM, is going to be opening magic bytes for the executable. So whenever you see, or the experienced malware analysts see a base 64 blob starting with TVQQQ, AAA, then he's going to immediately know that behind it there's an executable Marks-Bikowski file. So magical bytes that are being recognized by, for instance, experienced web hackers that are trained to be looking for serialized PHP objects or Java objects or Python objects. And here we got the same notion with the serialized .NET object. So probably it wouldn't hurt to split it in this case, split it in this place. So naturally, something like that. Then just follow along with some concatenation parameters, right? It also wouldn't hurt to throw in some further brackets and empty arrays. However, what about that repeatable stream of lengthy lines? So if I would be training my machine learning model, one of the characteristics would be the length of the line, right? If the line is quite long, and there is a repeatable sequence, or maybe there's plenty of long lines, then this might be constituting that the script is suspicious, especially if, like, for instance, 70% of the file contents is made of long lines, right? In order to combat those machine learning models, we can split those lines, try to randomize their length. So write a Python script that will be splitting them in a non-repeatable stop mark, and then interleave those lines with, for instance, randomized comments. That is going to be an awesome and quite potent idea for evading, for maybe fighting back, pushing back on the machine learning models. So the idea is following. We're gonna toss in as many. English-looking comments, and then interleave those lines with those comments here. First and foremost, I've got the first object, serialized object. Now I'm going to define second variable that's going to be called, for instance, obfA, followed by next variable, obfb, and so on and so forth. Even further, I'll have to end up that string at some point, so the string doesn't have that fixed amount of bytes in it. Here as well, I just have to ensure that my string ends up at some point, because I don't want to have too many lines of code having the exact same length byte-wise. Like here we've got the string that comes with I don't know, that had like 76 bytes, right? We don't want to have repeatable stream of lines containing 78 characters in a subsequent manner, in a streamlined manner, because this might be getting picked up by the machine learning models. Can we automate this in some way? The answer is yes, we can. I got it automated. Been that, done that. However, it just takes slightly little efforts. I would say that probably if you spend like few days writing a Python script that loops through those strings, you'll be probably having a pretty nice and elegant solution to the obfuscation problem. Also, you can probably just leverage some of the online-based JavaScript obfuscators. Maybe not JSFAQ, because that will be probably just overkill. You'll end up having like thousands of lines of code. I wouldn't be using that. But probably there are some JavaScript minimizers, for instance, right? So JavaScript minimizers and other ways to minimize / obfuscate your JavaScript script. But then if you want to go custom, just writing a straightforward Python script probably wouldn't hurt. I've got something like that automated, so it's completely doable, especially if you are working with a predictable input like the .NET to J script is. You could, for instance, write a specific obfuscator for .NET to JavaScript scripts, right? In that case, the input would be always the same, predictable one. So you could be messing around with that as much as you please, because all of the inputs passed to your script would be ever the same. Other than that, if you want to write yourself a generic JavaScript obfuscator, you would just need to spend far more time, but still a pretty much doable task. Well, yeah, absolutely doable task. So this is what we got here. Plus, let me just leave it like so. Now I'm not gonna be repeating myself too much in here, but interleave all of those lines with the comments, right? And the more the comments, the more you're gonna impact the entropy of your script, and more you're gonna decrease the percentage of that big ass string occupying in your file. So if you're gonna toss in like hundreds, like thousands of command lines, eventually your concatenated base64 blob will be just getting lost among all of your command lines, right? So it really wouldn't hurt to throw here as many garbage lines of code or garbage comments as you can think of. And naturally, this can be automated even further. Maybe do not repeat the same comment, but just rather randomize the sentences made out of just English words. In this way, we're gonna be positively impacting the entropy of the script. We're gonna be trying to kind of hide away that big hell of a string concatenation. But as you probably already feel this intuitively, this approach isn't as elegant as just simply using the staged delivery dropper instead. So if you can just rip the entire blob out of that script, put it to the internet, and then pull it afterwards, since you can just pull the binary blob instead of base64 blob, you could always just pass the directly downloaded stuff from the internet right directly into the .NET interfaces, constituting your weaponization there, right? So you don't really need to leave it in the stageless. But if for some reason you still want to deploy your malware in a stageless approach, then you would need to just interleave all those lines with comments and make sure that your subsequent lines will be having varying length byte-wise, characters-wise. So now let me fix up the script. obf-a followed by obf-b. So that's gonna be my my payload concatenation here, and we are using it in here. So instead, I'm gonna go and do something like this: serialized object followed by plus obf-a, obf-b. Just remove that semicolon here. I should be pretty much good to go. Now let me see if that worked. .NET to JavaScript. We've got the cobble strike. Now the question is, will it blend? Probably I just screwed something up in the process. Well, it sometimes happens when I'm just rushing too much. I still can see that it's kind of a. Let me see if it works or it doesn't. Script, no, it actually doesn't work. So I probably just messed up the syntax here. Let me now see. I'm gonna go. Yeah, that's one of my favorite sayings. Let me just see double script. Oh, actually C script followed by beacon.js. Well, the downside is that we don't have any syntax errors, which is unfortunate, because if I had the syntax errors here, at least I could know where did I made an error. But here, as you can see, I probably, oh yeah, I see. I'm assigning the value, and then I'm just removing whatever I have assigned. So I just kind of I have just break and corrupted my own payload. So that should help out. Fingers crossed. Okay, chances are there is yet another error like so. Got okay, serialized object followed by OBFA. OBFA is concatenated here. OBFB is concatenated here. Okay, probably I'm gonna undo just those line concatenations, because I see probably I just pushed it too far. Let me see if that's gonna work. Okay. Yeah, maybe it is. Maybe the first operator. Or maybe it's just somewhere about those property names. I think it's the latter. I think we just broke it. We just broke the property name somewhere in here. I'm blaming this syntax. Let me see. Okay, so I'm blaming that syntax. Let me now undo all the changes. Well, no, not that direction. Actually, I would like outline, no, timeline. Oh, that's uncool. I don't have those changes made beforewards. I wanted to get back to that form when we had all of those. Oh, there it is. Concatenated. Yep. Let me see if I can get back there. Okay, looks like there's no turning back. So you just need to believe me, because I just don't want to spend too much time on that. But just splitting a big ass string into subsequent variables, concatenating those, ensuring that that your subsequent variables will be interleaved with comments, making sure that those comments are generated out of the English words in a randomized order, and then ensuring that your lines will not be looking like so, like the consecutive block of code. We don't want to have a repeatable sequence of 76 characters in a row, but instead just varying number of those. And that's gonna be, there are going to be heuristics against machine learning models, against AI models, because clearly we won't be able to cheat even in an experienced analyst, because this at the end of the day, this hell of a big ass concatenated string, it still really stands out. So the best we can do is just to get rid of it by putting it on some kind of a host-based distribution point, like for instance, landing page within the cloud-based storage. So the gist of this example is that JScript based on JavaScript is very nicely obfuscatable. I'm not sure if that's even an English word like so. We can really obfuscate it quite heavily. Also, always, whenever writing your own code that you know will be processed by some languages like AMSI, when you feel that your code will be statically analyzed, then make sure to get rid of, to rework, to refactor, to hide away the suspiciously looking properties names, naturally symbol names. It goes without saying function names and so, but also, for instance, COM objects, and especially those oddly looking properties like deserialized underscore here is quite standing out. So those are the straightforward primitives we could nicely automate and reuse. .NET to JavaScript, still in 2023, is a gift that keeps on giving. So if you haven't been playing with it anytime recently, I really still recommend you getting back to this and understanding the concept. But do be sure to equip yourself with some notion for further obfuscating the source code. And also, as a homework, I myself, I'm also going to be working on that. And since you have the account, and since you have the lifetime access to those materials, to the materials shared on the training, meaning the next session when I'll be having the next session at the end of the October, when I'll be updating materials, because I'm updating materials before every session. You will be able to download the latest pack of the materials, slides, snippets, code, source code. By that time, I should be having my own AutoIt .NET to JavaScript implemented, probably. So you'll be able to also grab my proof of concepts and then use them for your own gigs. But maybe you'll pick up the challenge and implement it yourself using different than Microsoft's technology. Can they block the execution of .NET to JavaScript? I haven't yet seen any reasonable way for blocking the execution presented here by James. There would have to be some way for blacklisting interfaces from instantiating in the CLR runtime. Like, for instance, we could be having some policy applicable to Office applications and macros. If there is a CLR instantiated in Office, then this CLR is prohibited from instantiating assembly reference, for instance, because just simply killing the script is prone for any obfuscation attempts, right? So this doesn't really scales that much. And then finally, there isn't any straightforward hook point that EDR could think of that isn't based on the static inspection of the script. So that the best thing that antiviruses and EDRs can do right now currently is to only scan through the script contents and look for the strings such as position, the transform, final block, get bytes, this kind of stuff. This is the best they can do against that .NET to JavaScript execution primitive, the idea, the foundation behind it, not the implementation. So this is the most that they can do. They can only statically scan through the code. If you can customize it, they will be blindfolded. So what else they can do? So what else they could do? Well, Microsoft could try to implement some kind of a blacklist banning some certain interfaces from being instantiated, but apparently they didn't implement it throughout the 6 years. So maybe at some point somebody decided that this is just infeasible to implement. Therefore, from the policy level, on the protections level, I am not aware of any way for killing .NET to JavaScript other than statically looking through the code and finding any resemblances, any fingerprints, any indications that this might be .NET to JavaScript outcome. And if that's the case, if they don't have any strong hook points for finding .NET to JavaScript, we can customize the implementation as much as we are able, and then still pull that trigger away, like we've been doing for the past years. So I myself, I'm still using .NET to JavaScript and its sibling Gadget to JavaScript, but it just takes a little bit of an effort for obfuscating it. But luckily, I've got it implemented, spent the efforts, so I'm sure you'll be able to. Okay, and also as a homework, try to pick up the challenge and maybe try to implement that idea in AutoIt language. Let us see if that's gonna be somewhat feasible. Okay, So that was the .NET to JScript. Now that we have that JScript script, let's see what else can we use. What else can we use in the from the script perspective? I promised to you that this third exercise and the last one are going to be absolutely the last ones closing down on the scripts, VBS's JScripts, and then we're gonna be proceeding into far more relevant vectors from then on. So third one being the XSL. It is still quite useful vector, maybe more of the from the internal perspective, because of its beauty, because of its simplicity. Just take a look at this. We've got VBS, and it hardly comes with any specific keywords or IOCs that could be that could be matched against that stager, other than the maybe URL, maybe their COM object class name, and finally the only thing that the defender could actually rely on will be the presence of the transform node keyword. So if there is a transform node followed by async, followed by Microsoft XML DOM, then defender could be denoting that this might be suspicious, this might be resemblance of the XSL loader, stuff like that. And since we are dealing with VB script, we cannot really do anything about that transform node string. It has to be there. If it was the JavaScript, I could just simply change that dot into the associative operator, but I cannot really do this with VBScript because VBScript is just such an ancient technology. So it really you get the point. It really hurts. But naturally, we could simply rework it, re-implement those 5 lines of code into JScript, and then the problem is gone. So you can even further, you can implement those five lines of code in the AutoIt, and then see if that really works. So let me get back to the slide. We've got that example here: object create scripting file system object. This is the syntax behind AutoIt in instantiated COM object. Now I could see putting here, in place of the file system object, I could just place here the reference to the XML DOM object, followed by referring to its async property, transform node. So I'm pretty sure we can have the same implementation in AutoIt, and then combining AutoIt with the XSL primitive, because the primitive itself is just so elegant based on how straightforward it is to pull off, merely 5 lines of code. What happens then in the XSL is following. The XSL is just the XML encompassing JScript or VBScript inside of it. So at the end of the day, there is still going to be WScript or CScript program hitting the process list. There is still going to be Windows script host being executed here, which is still going to be eventually augmented by the AMSI. So either way, we are still going to be subjected for AMSI analysis. However, the bigger upside is that there are merely 5 lines of code for constituting it. But there comes another big downside. Since we are pulling the XSL, and the XSL is XML, and it includes the JScript or VBScript out there in plain, the proxy or the network scanner, such as Network Intrusion Detection System, maybe Bro, maybe Suricata, if they find references, resemblances, if they find indicators pointing there is a VB script flowing across the wire, some solutions might be unhappy. So what we can do about it? Well, we could corrupt that intelligence. We could just break that elegant, consist implementation, 5 lines of code. We could complicate it a little bit further, so that we'll be pulling the base64 encoded blob from the internet, decoding it, and then running it in memory ourselves. Let us see how we can go about doing so. So I'm gonna go and create XSL. I'm gonna copy those samples here. Actually, what I'm going to do is that I'm going to take my beacon example, beacon to XSL. I'm going to also take that. Actually, as you can see, we've got already sample 3 containing .NET to JavaScript blob. So I'm just going to reuse it, followed by the dropper. Now, to avoid the confusion, I'm gonna name them accordingly. So 0, 0 beacon. Okay, then we're gonna have the first, that's gonna be payload XSL, right? And then we're gonna have second, it's gonna call stager VBS, right? So in this way, it doesn't look that confusingly enough. So we've got the beacon.js. We're gonna go and take that beacon's contents. We're gonna put it into the XSL template. Let me now remove the previous .NET to JavaScript payload. Paste the one that we just came up with. You can see that dynamic invoke being reworked here, which is an indication that this is in fact our sample. Now the trick is following. I'm gonna, since there is going to be an XSL being downloaded, I don't want to transfer my XSL in the plain form across the wire, right? So what we're gonna do instead, we just need to encode it in somehow. So naturally, the Swiss knife for any kind of encodings and decodings being CyberChef. Here comes the CyberChef to the party. We're gonna cook something spicy here. Let's open up the file as input and specify that XSL. Now that we have XSL, now the trick is following. I want to base 64 that, right? Well, not from base, but to base. I want to base 64 my blob. Well, probably somebody could say, Nikos could say, how about base 32? And that would be absolutely equally elegant, equally applicable solution. Base 64, base 32, whatever. Just try to get rid of the suspicious contents. But now base 64 is just too easily recoverable, right? There might be some automated solutions trying to recognize that, hey, this resembles base 64 based on the alphabet being used. So I'm gonna blindly run base 64 deobfuscation and then try to apply my Yara rules at whatever comes out, right? So how about destroying, corrupting the base 64 algo? First idea that comes to you. Anyone has any idea how to customize base 64? Alphabet, not that channel. Again, a GW. I know that it gets confusing, but not that channel. That channel is just left for questions. So absolutely, alphabet. So we could just kind of a reversed alphabet. Instead from starting from A to Z, maybe just strip some characters, maybe just toss in some additional operators like, I don't know, underscore, ampersand, this kind of stuff. So the most straightforward way for customizing base 64 will be just to playing a little bit with the alphabet. But then, if you play with the alphabet, you would have to implement the base 64 decoder yourself from the scratch. And I promise it to you that the VB script implementation is not elegant. As you can see, it is quite painful. It's like, I don't know, like 80 lines of code, far from elegant. And instead, I would really want to use the built-in genuine original base 64 just to avoid messing with re-implementing it. But instead, I'm gonna apply the shifting byte trick. So there is this decoder idea. Here we are just using, well, somebody could argue that this is equally lengthy implementation, and I give it to you. It is equally lengthy implementation, but at least I'm not implementing base 64 myself. We are just using the base64 coming to VB script as implemented by the native COM objects, DOM document, and so on. But with that tiny little bit of a plot twist here, that after base64 decoding, we're gonna add fixed value of whatever, like 35 in this case, modulo 8-bit characters of a value, and then we're gonna nicely decode our customized routing. So firstly, what we're gonna do is that we're gonna need to subtract a fixed value of 35 before passing the output to the base64 encoder. So I am subtracting value of 35 from every character. Notice the decimal indication here, and then I am pushing the outcome to the base64. So far so good. I'm gonna now name it like free stager. No, not the free stager, but maybe one payload encoded. One payload encoded, right? So that's gonna be my encoded payload. Now that I have that encoded payload, I'm gonna host it on my pound drop. So just going to the pound drop, authenticate. All right, now I'm gonna upload it. So far so good. Now I've got my URL. I'm gonna get back to my stager. This is my stager, and substitute the URL, right? But now I need to think of ways for how can I download the XML myself and then pass the XML decoded to the XML DOM. So quick sneak peek into allofyou.net. I know that we are just right now running past the break time, 1 minute off. So just give me a few minutes. So just give me a few more minutes. In this during that time, I'm gonna take base64 decoder, which you'll find in C training exercises day 1, base64 decode VBS, a ready-made implementation. I'm gonna just simply copy and paste it around. So here is it. Here it is. Now what I need to do, I need to download the contents. The contents, for instance, right? Now contents equals download, followed by the code, whatever you have downloaded, right? So that's gonna be the code base text 64, something like that. The code base 64. Okay, so I've got the decoding stuff. I don't have the downloading portion yet. Now let's get back to the allofyou.net. Prog IDs. I'm gonna now see in the XML DOM, is there any function I could use to load the XML from the string instead of from the URL, because we had the URL here before. Now I want to see if there is any other method that would accept just the XML code. In the meantime, I'm gonna go for the stager. URL stager, we'll find it in the Visual Basic dropper in the first exercise that we had. Here is the stager. Download from URL. I'm gonna copy this, paste it around. This is my download from URL, right? Let's just substitute the name of that function with that stager. Response body. This has to be changed into response text because we are interested in getting textual data back instead of binary data back. And now we are downloading from that URL, putting it into our customized base64 decoder, and then we got the contents. Now the question is there any method in the XML DOM document interface that we could use to load the XML? And the natural, obvious answer is yes, there is. The method is called load XML as opposed to load. load XML accepts XML string on input, whereas load accepts URL on input. I'm going to use the latter. Load XML followed by contents, right? So we are downloading this the payload from the URL, decoding it, passing it to the XML deserializer, and the actual deserialization happens here. This is the place where the code is going to get executed. Now it all looks cool. Let us see if it blends. I've got my stager. Well, it was so elegantly concise. It all originally it only took like 5 lines of code. Now we can see it's far longer than that. Actually, I can probably remove. Yeah, I can probably remove that function. The code base 64 isn't really required here. This one is the string. That probably isn't. String to binary. This isn't used anywhere. The only one is used binary to string. The code base. Yeah, that's probably just about it. Okay, so we end up having like 60 lines of code where we started from 5 lines of code. Still not that bad. Okay, now the question, will it blend? Let me now keep an eye on my color strike. Sorry for killing the beacons. I hope that you guys forgive me if I killed any of your beacons. All right, lo and behold, hitting an enter. If all goes well, it typically takes like 15 seconds up to the 30 seconds, depending on how busy the VM is. Let me now see. As you can see, double script still executes just fine. So it now pulls the contents from the URL, from the pound drop. Then it's gonna decode those contents. Then it's gonna deserialize XML object. Then when XML object deserializes itself, it's gonna run the inner JScript, which then in turns concatenates the entire big hell of a .NET assembly blob, and then uses James implementation for running that .NET assembly blob in memory. So if all goes well, we're gonna have .NET to JScript initiated from the XSL ground, and all of that started in a staged, more elegant staged delivery manner. Let's just wait a little bit more. The double script still runs, so I still have high hopes for that to succeed. Just bear with me a few more seconds. And naturally, if you despise the VB script as I do, then think of ways for turning that VB script stager into other technology, like maybe AutoIt, maybe PowerShell, or maybe just simply JScript. And now we have it. As you can see, the pits check out, which is an indication that it actually worked quite well. I'm gonna add all of those samples we are working on to the repository, so you won't miss anything. The entire devel directory is gonna be added, actually during this break. So, guys, do you have any questions to this part, to the VB scripts, JScripts, and stuff we have covered so far? I know that maybe discussing VB script concept isn't the latest cutting edge vectors we all came for in this training, but I just wanted to lay out some interesting concepts and foundations independently to the language used. And now I promise we're gonna be after the next example, after the XLAM, which is going to take like 10 minutes maybe, we're gonna be then moving into more relevant stuff for the remaining 2.5 days. So, questions? Are there any questions? I've got a question. Can we use VB for initial access still, or we should move to other things? If you want to be sophisticated, I wouldn't be using VB, to be honest. But as you could see already, well, some where I have it, some traductors, they are still using VB script. So it pretty much depends on how mature your target environment is going to be. If you are targeting public infrastructure, public administration, or the companies that haven't been having red team in the past, then probably you can try out VBScript and see how they behave. Or maybe whenever you are playing with, a little bit with a maybe not so greatly configured AVs or EDRs, you can also see. But rule of thumb, VBS script should be rather disregarded in the currently and modern ops. Just yeah. How would you deliver .NET to JavaScript? One of the ideas I've been using it with was the MSI. So you can run VBScript or JavaScript inside of the MSI. That's one of the ideas. Other than that, internal perspective, internal angle. When you're already in the company, you can just drop the VBScript or JavaScript to the SMB shared drive and then share the link to the employee. The employee is going to click on and then refer to that script and then get infected. Also, other than that, if you can pull off the macros trick, that entire implementation in VBScript could be easily translated to the VBA world, to the macro. So if you have any window of opportunity for working with Windows Office macros, then you can use gadget to JavaScript, that XSL primitive that we just laid out in the macro world, assuming you are using those internally. So there are still some opportunities for using VBS. And also, if you think you are working with lesser capable, lesser mature organization, then probably trying some old school tricks might be somewhat worth the salt, just to ensure that they have coverage for the older stuff. Before you move to the most advanced, most complicated vectors, you could be for instance wanting to you could be starting off with something simpler, depending on what the scenarios you have agreed with the customer for your exercise. Sometimes the customers will want us to just emulate some of the threat actors, and if you are being told you just need to emulate this or that threat actor, and you see they are using scripts, you can be just trying to scripts yourself as well. And also, in the light of AutoIt, for instance, since AutoIt, even though it is very well known across the malware researchers, it isn't that much. It isn't having that much media coverage and that news coverage, that it really strikes a question: would AutoIt actually work against some of the environments, especially if we were to implement something more sophisticated in it? So I am really looking forward to implementing XSL loader in the AutoIt lingo, and in that case, we could be using the same foundations laid out right now, just using different technology, just using different language. I hope this resonates to some extent, and it makes a sense. So now let us hit the break time. We're gonna spend next 5 max 10 minutes on the XLAMP, because it's still worth our time vector if you haven't been toying with this yet. And then we're gonna move forward to somewhat more relevant stuff. So with that being said, let's just hit the 10 minutes break time now. See you guys in 10 minutes. If you have any questions, anything I could help you out with, let me know either on the comments or in the private message. Okay, so cheers. Okay, guys, are you ready for the final round today? So one last tiny little, I promise, example on scripts, and then we're gonna proceed to something more relevant, I promise. So we just ended up with the introduction, with the idea behind the serializing XML objects. Now let's see the sometimes forgotten, sometimes lesser known vectors such as XLAM, that is being XLAM, Excel-enabled add-in module. This is just an Excel spreadsheet. It is not an executable, just a spreadsheet that has macros in it. But the nice thing about it is that when it's getting dropped to the Excel start, being a trusted path location configured by default on a vanilla installation, that code is going to be automatically executed the next time user starts its Excel. So since we cannot just simply download macro-enabled document from the internet and drop it there, we would need to create the one from the scratch ourselves. So if you are using COM-enabled language like VBScript, JScript, or maybe AutoIt, we could be creating an Excel spreadsheet automatically, which is something totally possible in the AutoIt. Let me just show you the example, because I actually have it here. Examples. I'm actually having it open here because I was kind of looking at it when doing that research. When starting doing research on AutoIt, as you can see here, we've got the examples. We've got the AutoIt examples, and here you'll find how the Excel can be referred from AutoIt here as well. So we are creating. Let me see if I've got out. No, I don't have AutoIt highlighting here. Maybe let's just apply something generic like maybe PowerShell, maybe Visual Basic instead. Visual Basic, yeah. So so we are instantiating Excel application object, and then we can create a new workbook, and then from that workbook we could inject the source code, the VBA source code into the just dynamically created VBA workbook. As you can see, we've got all the tools required offered to us by the AutoIt technology. So there's nothing stopping us from reworking that principle, that notion, the idea from the VB script, from the JScript lingo to the AutoIt as well. Firstly, creating an Excel spreadsheet dynamically. Secondly, injecting the code. Thirdly, we're gonna save it down to the XLAM, and then we can either run it or just wait until the user runs it. Here is how the code looks in the VB script. So we are creating Excel application. Let me just zoom it up. We are creating the XML application instance here. Then we're gonna need to modify the so-called access VBOM property. That property indicates that that we can dynamically inject the VBA code to the just created Office document. So this is the telltale that that something shady is going on that machine. So from the defensive perspective, in order to actively look for the XLAM attacks, we would need to closely observe that registry key, the access VBOM. If there is someone writing to that key, especially, well, the value of 1 has to be added there. If there is someone writing the value of 1, then we're gonna be probably tackling, and then we might be dealing with a threat here. And from our perspective, offensive perspective, that's gonna be required. Afterwards, naturally, we will be interested into reverting the defaults, just to not downgrade the security perspective, the security configuration of the workstation once we're done with it. So after that, we're gonna create a new workbook. Then we're gonna use the lingo here VB project VB components add, just to inject a new VBA module to just create that Excel spreadsheet. Here is our VBA code. That VBA code is naturally base64 encoded. And after that, as you can see here, there's a method called add from string, and that method will accept the code on input and then inject the code to just create a module. After that, we can save the file. When saving the file, there is this third parameter called password, which can be used to save the encrypted Excel document to the hard drive. So we can just use some kind of a password. However, we don't want to have the user type in the password every time he opens up the Excel. So instead, we could be using the transparent password, such as the Velvet Sweatshop, a phrase that is very well known across the malware analysts, malware researchers, and some of the old school malware developers as well. That transparent password is going to be the first password used automatically by the Excel anytime it sees that it deals with the password protected Excel spreadsheet. If the password is correct, then the Excel will be automatically decrypted without asking user for the password. Otherwise, the password prompt will pop up. So we can use it according to my researchers. According to my research outcomes, it seems like some programs, some AVs are falling into disregarding Velvet Sweatshop encrypted spreadsheets. So they see, hey, the spreadsheet is encrypted. I am not scanning it, yielding unknown or just clean status on the output. However, most of the products these days will probably be aware of that Velvet Sweatshop idea. So other than that, we could naturally be using some randomized password, but then we would have to explain it to the user that he needs to or she needs to provide that particular password phrase in order to proceed. After that, we can, but we don't have to, open the workbook just created using the workbook's open invocation, and then we could also even indicate what method in VBA to run after that. Like here in this case, OBF runtime, right? But this is really not that much required. Now let me quickly show you the example, and we're gonna be finally wrapping up with the scripts. So this is my my VM. It isn't that too much surprising. Now what I'm gonna do is that I'm gonna go for the C users, user, app data, roaming. Then it's going to be Microsoft, Excel start. As you can see, this directory by default is empty. Now on the left-hand side, exercises, day number 1, exercise 4, Xlam dropper, and here is my straightforward Xlam that just simply pops a notepad. Now here's what happens. When I then run the Excel next time, that Excel is expected to spawn a notepad, as you can see it. So we can use that primitive, that Xlam idea, to instantiate phishing to persist. So the next time you're going to be having some code execution, and you're going to be, for instance, using Trojan dropper, how about downloading Xlam from somewhere and then dropping it to the Excel start? After that, we would naturally need to shake off the mark of the web. But if you have code execution, this should be fairly simple. Just a straightforward, maybe partial command, or just simply creating the Excel dynamically, like we can see here in the example provided in the exercises once again. So in the exercises, you'll also find that script in the HTA, in this case, Visual Basic. As you can see here, this is the sample implementation for creating Excel dynamically and injecting the VA codes. So you can also create the Excel during the runtime, and that won't be that won't be marking it with the mark of the web flag, right? Because we just created instead of downloading it from the elsewhere. So this is something to bear in mind when you'll be looking for the phishing to persist opportunities. Think of ways like, I'm gonna drop a file like xlam, and then next time the user does something, that user will be responsible for popping up my previously preset persistence. So it's just a clever way for avoiding running your own stuff that you just dropped to the hard drive. Finally, we are finally done with scripts. Let's focus on something more relevant that isn't related to Visual Basic nor JavaScript. So, CHMs, blast from the past. It's a vector known since like several years, I think. Compiled help message file format that was promised informally, was promised to be obsoleted soon, but as you can imagine, it isn't that simple to obsolete a file format, especially when plenty of programs around the world are distributing their documentations and references in CHM files. Like, just take a look at the sysinternals suite itself. The sysinternals also comes with CHM file, with a bunch of CHM files. So there we have it. This is just a convenient technology for a standalone single file documentation pages that the program can use after installing itself. Instead of just distributing PDFs or HTMLs, they can just distribute the compiled set of HTMLs, JavaScripts, and so on within a single CHM file. Now here's the drill. In CHM file, generally speaking, there's only one way. There's only one very well-known way for running, for abusing it in an offensive manner, and it just revolves around running commands from the CHM. So CHM is just a bunch of HTML files, right? And in HTML file, we can inject that particular object tag that will be invoking the bitmap shortcut method from that particular internet hhcontrol1 com object. Now the trick is that this interface was supposed to be creating bitmaps, to be displaying bitmaps, and all of a sudden it happens to give us that ability for presenting bitmaps that are being pointed to by shortcuts, like LNK shortcuts. And since we can specify where the shortcut points to, that interface is expecting to get a bitmap out of that shortcut, and all of a sudden, instead of being pointed to the bitmap, we are pointing the shortcut naturally. Well, it isn't that much of a rocket science here. We are pointing it to the CMD, followed by some calc, right? So we can just have a straightforward command execution primitive. So there we have it, a file format that is capable of running commands in the system. Now, by itself, it may be not that super useful, because in order to turn it into the actual system compromise, we would probably need to throw in here some very lengthy PowerShell one-liner, doing some shady stuff in the encoded command kind of a format, far from perfect, far from stealthy, but we're going to be using that CHM as a trigger for our complex chains. So this CHM will just act as a one single step in a convoluted chain full of files that are designed to deliver the compromise, the infection to the system. So in other words, we are going to be revisiting CHM tomorrow in a far more devastating manner, devastating context. But here, just to lay down some foundations, so we can just run some commands. The only, well, maybe downside, after several years of observing viruses and malware starting off the CHM, Microsoft finally decided to do something about CHMs, and they finally decided to kind of contain the threat. And all they did after all of those years, as you can imagine, is this lousy message box telling, hey, do you wish to view the blocked content? Like literally, this message box wasn't present there like half of a year ago or so. I was showing CHM examples half of a year ago, running on top of the latest updated Windows system. No message box. Then all of a sudden, very next training session, there comes the message box. So this is all that Microsoft did after all those years. They are just showing that lousy message box. But then again, let's see how can we actually weaponize CHM files. So in the repo, you'll find the exercises directory naturally. Let me just close down all of those irrelevant scripts here. We've got CHM just about here. CHM spawn calc build. So you'll find convenient PowerShell scripts that I created for you, just so that you don't need to be typing all of those commands yourself manually. All they do is that they refer to the HH compiler, HHC, as well as HH, which is also used for the compiling stuff. So here, for instance, we are compiling HH based on the HPP project file. HPP project file looks like so. Just a straightforward contents file line defining the left-hand side pane. Like, let me get back to the slide. This is the, let me now use my terrific drawing skills. This is the contents table pane, and it may be empty, can be empty. So we can get rid of those contents, table contents. So let me get back to VM. I'm gonna show you how in a second, and then we will have to define all of the list full of all the HTML pages. So HTML page can look like so, just a straightforward text that you can think of. Naturally, all of the HTML formatting applies here, followed by that CMD. The only thing here that we would like to probably change is that anytime you're about to run some commands, anytime you want to run some commands in the Windows system, always ensure that you can run those indirectly. If you really want to spawn a calc, instead of popping a calc, ensure that you're gonna pop a calc, well, using some kind of a lol bin. This is an imperative. I think that's gonna work. Yeah. So this is an imperative statement. It cannot be stated enough that indirect execution is the key for lowering the detection potential, instead of just simply resulting for PowerShell or /CMD. And there's actually a beauty behind leaving off the con host, meaning I myself came across several instances of environments where con host was deliberately whitelisted. Like, I was literally seeing Microsoft Defender or Symantec Endpoint Protection entries defining that con host is excluded from scanning, is whitelisted. And the reason being, after speaking with when the debrief session came in, the engagement was just about to wrap up. We are having this brainstorming on what was found, what not. That typically I was hearing that con host was left on the exclusions because plenty of scripts need to run, and they were being quarantined by the Defender or Symantec, and those scripts are just crucial for the organization to work properly because, for instance, they map some network drives, or they are communicating with some network printers or so. So plenty of legacy GPO objects that are running some VBS, PowerShell, or batch scripts, and most of the times the CMD running the batch script will be starting the con host underneath of it, and the con host was the culprit for running some shady commands in those batch files, hence making the decision for whitelisting the con host, because somebody considered the con host wasn't a threat in that context. And this opened up the backwards depth, the compatibility depth, the configuration depth that nobody right now has a courage for reworking, for changing. And this is how we are ending up having the adversary emulation exercises when we see that the con host is excluded from scanning and nobody wants to touch it, nobody wants to remove it off that list, because they will be just terrified what might be the consequences for that, removing some scripts maybe, or maybe just breaking some corporate assets. So I'm so in love of abusing con hosts. Anytime I can run some commands, I always make sure to run them through some kind of a low bin. And con host also has this peculiar feature. First and foremost, it can run with the headless parameter, right? Secondly, con host can be even further nested. So we can run con host, which runs con host, which runs con host. You get the picture. Con host followed by headless, followed by calc. Then we have calc, right? So it just gets crazily complicated and just crazily complex, and this may impact and affect some weakly and poorly designed detection use cases. If you happen to be having maybe novice blue team that is just starting writing their own use cases, that might now you complicated our detection capabilities. Yes, I know, Revit, I know. I even know what you're referring to. So if you happen to be having some novice blue teams, or maybe the blue teams that are heavily relying on the command line analysis, you can be kind of fooling around with those rules by just playing some tricks like the con host. Not to mention that naturally it goes without saying that the very old school trick for further obfuscating command lines, like using the tildes. This is probably already very well known to some seasoned hackers, that we can even further obfuscate commands in the CMD world. Yeah, sure. So anytime you're running commands, and we can run commands from the grounds of MSI files, CHM, LNKs, Visual Basic or VBA scripts, J scripts, AutoIt scripts. Literally anytime you run some commands, always have this in back of your head to run those commands indirectly. And if you can get rid of CMDs or PowerShells, you'll be better off without them. Okay, next thing on our agenda. Let us now quickly compile that example, just to see how that CHM is gonna actually play here. Spawn calc, build script. Since we don't have time for writing all of those, and even though it's quite boring, all of those building commands ourselves from the scratch. So instead, I'm gonna just run the script provided, right? Build PS1. It should nicely build me the CHM file. Now we've got the CHM file. Let me see if I recall correctly. It moves the compiled spawn calc from the project CHM here to the spawn calc, right? So this is 838, right? This is the one, and it just spawns a calc We've got that lousy message box I was telling you about. Now we've got that that calc. We could get better. We could do better by hiding away that CMD headless, right? And even though you can see that contents page here, right? It isn't that much visually appealing. I don't like it, so I'm gonna go back to my project file and I'm gonna remove those 2 lines. Options, no contents pane anymore. Let us now rebuild the CHM, bang, and rerun this stuff. Yes, I do like to run the contents. No more CMD, no more content pane. This is what we can get. This is what we can squeeze out of CHM. And if you complain that CHM is sluggish and lousy and very old looking, and even it's not that much visually appealing, and even you don't really like the way that this interface look, that I am 100% playing to your team. I also don't like it, but from the execution perspective, all we care about is just to run some commands. And the CHM, since it's being used by the threat actors, we can emulate that idea and see how the customers' protection systems, how the use cases, how the blue teams are actually picking up CHMs. Maybe by some chance, you'll stumble upon a lesser experienced analyst who has never even seen CHM file before, and that analyst won't see anything suspicious about CHM, and maybe he'll close down the ticket by marking that this is false positive. Because as you can see, let me get back to the previous message, to the previous directory. We can even decompile existing CHMs. Here you got HH followed by -decompile. We can decompile, for instance, procmon sysinternals CHM, then inject our HTML code to the just decompiled HTML website, and then we could compile it back. In this way, just take a look at this. We can have procmon CHM or any other legitimate genuine CHM file, and then when the user browses to the specific website, like introduction in this case, he's gonna be presented with the calc, right? So we can also backdoor existing CHMs. Now take this and mix it up with the inexperienced analyst who doesn't see anything suspicious about CHM file, and you're gonna have the mixture that might get you away with that trick. So there's still some value in testing those legacy old vectors, because firstly, your customer might be not aware of those. Secondly, your customers, or maybe your blue teams, your blue teams partner policies defined in place might not be really looking towards the CHM files, or maybe somebody is just not paying attention to the hh.exe execution, because naturally when we run CHM file, underneath the hood there's going to be that hh parser, right? Because this is just a file format that gets processed, gets parsed, just like the JPEG file gets parsed, just like the docx Word document file gets parsed by some kind of a parser. Here the parser is hh.exe, and maybe by some chance, maybe your customers' use cases, they doesn't really include hh into closer inspection. So just like the MSHTA or regsvr32 should be among the suspicious processes to look for actively, like let me get back. Just like the regsvr32 is suspicious, maybe runDLL32 is suspicious to some extent. MSHTA is clearly suspicious. The same happens to the same holds true for the HH. It also should be considered suspicious. However, it just takes the context to deem that particular process execution as actual threat, because sometimes CHM file will not pose a threat, especially when you hit F1 button in the total commander when you hit the F1 button, it also pops up the HH. Now the question is, should me hitting the F1 button, should this be causing some alerts and incidents on the SOC side? Probably not. Hence, it is not that straightforward to implement a robust use case policy that wouldn't be causing false positives. Therefore, we have to have some understanding, some empathy, and some and just feel some compassion to our blue team colleagues, because it sometimes is far easier to attack rather than defend. All right, so that will be the CHM file. As you can see, maybe it isn't too fancy, good looking, but it still can lead to the command execution. Here you can see a bunch of threat actors and the things they are using. As you can see here in this example, CMD that starts up the PowerShell. Like, I don't see any reason why they didn't start the PowerShell in the first place. They had to run it through the CMD. This doesn't make any sense. This doesn't make that parent-child hierarchy any less suspicious. And also, they could at least use some kind of a lol beans. But as you can see here, some threat actors aren't that much maybe experienced, maybe aware of how the actual EDRs, how they work, what they're looking for. So this example is pretty straightforward. PowerShell that drops Visual Basic and then runs it. Ends of story, right? But what about this example? Anyone want to pick up a challenge and explain us what the heck is going on in here? Anyone wants to try to explain what is happening in that command? What this particular threat actor wanted to achieve with his CHM? I actually like this example, even though it doesn't really look that complex. So I'm gonna try myself. First, we've got Papa Dope. It's not, yeah. So pretty straightforward. Yeah, well, firstly, at least I can admire the creativity. They didn't use CMD nor PowerShell, right? So you have to admire, at least they tried to do something differently. There is no CMD nor PowerShell. This is what I like. Then they use scheduled tasks. Now, according to my experiences, in some environments, scheduled tasks are very thoroughly examined, and there are some bespoke tailored policies, use cases that are trying to look for the newly registered, newly scheduled tasks, not to mention the sole invocation of scheduled tasks command from the command line. So plenty of EDRs or use cases would pick up the sole execution of scheduled tasks, right? But then some of the other environments I also was operating don't have the same level of scrutiny. So under certain circumstances, in the lesser mature environments, this may actually work out. Then, what happens here? Anyone wants to delve? Looking for exit option? Yeah, well, Revut, I know that you know that. 4698. Yes. Well, this is what I'm talking about. Mature blue teams will be aware for what to look for, what kind of events, how to correlate them, and what severity should they be applying on the particular event. So that scheduled task, it's gonna create a new task called Microsoft Outlook. Naturally, that's gonna run every 15 minutes or after 15 minutes, and that's gonna then run what? It's gonna then run the com spec, which is going to roughly translate into CMD, followed by, and here you have to admire, or maybe not admire, but at least notice they have been trying. Okay, they have been trying to further obfuscate their intents. At least they use the tilde trick. So they are then starting off the new CMD, the new con host environment, followed by installing MSI from the remotely hosted file. So they are quietly installing MSI file. And in this way, they are pivoting from the CHM to MSI. And what happens next in this picture is a mystery. So this is what we have. Sometimes some traductors will be a little bit slightly more creative, but either way, there's going to be some commands created off the HH. So if you see HH, and that HH is going to spawn a child process, and you can look proactively for those, you can craft it into a use case, and you can just react on it, call it an incident. We shouldn't be having HH running any child processes. However, in this case, the MSI exec would be run indirectly because the scheduled task would create a task object, which would then, after the 50-minute start of the services SVC host, which is kind of a slightly more confused execution primitive. But even though, either way, the CHM still has to run scheduled tasks, right? So either way, there's going to be some kind of a child process. Okay, enough on the CHMs. Let's review the LNKs. Long story short, LNKs are absolutely relevant these days. I am using those. Probably you are using those too in your own ops. So probably you also have your own success stories that started off the LNKs. They still fly past DDRs, at least some of them, not all of them. They are still pretty much often overlooked, and then they might be nicely abused for gaining some initial accesses. Like literally a few days ago, my friend told me that he was trying different files and he only succeeded with LNK. But then, unfortunately, when he got his Brudertel Badger, after the very first command, the Sentinel one or I forgot what the EDR he was running on, just killed his Badger anyway. So the LNK did its part, but then he just wasted the chance by running some shady post-exploitation command. Either way, LNKs are still pretty much helpful in terms of delivering the infection. Embed in LNK works very well, but highly dependent on what you do after. Absolutely, yes. So let's just focus on the LNK as a carrier instead of what we are going to do next, because naturally that depends on our tradecraft. So as you can see, threat actors are very much interested in LNKs. They even create builders. They are selling those for some money. As we can see here, Quantum LNK builder. I happen to have that Quantum builder myself because I was able to pull it from the VirusTotal. And I can promise it to you. It's nothing. It's nothing that much complicated. Just a straightforward builder that encompasses MSHTA into the LNK, far from being interesting in any way. But even so, it kind of shows what's the market behind those payload builders and another commodity malware being distributed on the dark virus and other shady forums. So if you can create a straightforward LNK builder yourself, you could probably make it for a living, like the Quantum guys are doing. They even brag themselves that the Emotet guys are using their creation. I highly doubt it, to be honest. Now, I've spent a fair share of time looking on what's possible in LNKs. There are some opportunities we can actually squeeze the LNKs to. Let's quickly discuss those. Naturally, we cannot really describe all of the ideas we could incorporate into the LNKs, merely a few of them. But well, let's just go ahead. First and foremost, LNKs may contain some other files. Like we've got Whiskers, who has been using embed in LNK. I myself, I've been using pretty heavily the concept of appending zip to the LNK. The notion is following. Let me now bring up my drawing tools. So we're gonna have LNK file, right? And that LNK is going to occupy first, like, I don't know, like 500 bytes, and then we're gonna have zip bytes concatenated to the very end, appended to the very end of that file. And then when we double click on that LNK, we can use some creative, however lengthy and quite obnoxious PowerShell one-liner, like you can see here. It is quite lengthy, I take it, but even though last time I checked, which was still like 3 months ago, it used to work against Defender like a charm. I was even presenting that idea in front of the security architects in one bank, and we were all just surprised how it comes that such a shady lengthy PowerShell gets actually passed, not only Defender but also other use cases that they have been having there implemented. So some EDRs will be particularly suspicious about lengthy command lines in LNK. This is true. Some EDRs, whenever they see lengthy LNK, they will kill it right in the spot. But some other EDRs, I would risk saying that Defender is among them, will simply ignore the notion that the command line is lengthy, but instead they will try to figure out whether that lengthy command line is in fact suspicious or not. So they will accept the LNK, which is actually looking anomalous, and they will simply wait for what happens next. Other EDRs, like CrowdStrike used to be prone to that embed, to that zip in LNK attack. It used to be prone for that. It used to pass it along. Then I was informed by one of my framework subscribers that this particular payload is getting whacked by CrowdStrike. So I figured that CrowdStrike no longer accepts lengthy PowerShells in LNK. But then the same subscriber, the same customer of mine, came back to me after like 1 year or so, and he told me that he undusted, he just tried out the same LNK, the same idea embedded in LNK against, once again, CrowdStrike after a year, and now all of a sudden it still works. So as you can see, there is some shady logic being applied on the LNKs that sometimes consider particular one LNK as suspicious. Sometimes it still lets it run. So probably it's far harder to comprehend, or maybe to model and to detect whether the particular LNK is suspicious or not, because we need to understand that legitimate vanilla Windows installations are full of LNKs, right? We've got plenty of shortcuts being present on the desktop or not. And if you take that and combine this with some of the shortcuts being created by, for instance, Chrome browser or Edge browsers or any other browsers, you might probably see that those browser shortcuts, they will be sometimes having a lot of command lines appended after the executable. So the point I'm getting, there are plenty of benign shortcuts that are actually lengthy in terms of length. So if you are the EDR developer yourself, you cannot simply put a rigid threshold saying if command line exceeds 100 bytes, this is suspicious. Because if you deploy this to the world, you're going to have a huge backlash coming back to you that you just disrupted plenty of businesses around. Because maybe out of the sudden, a lot of legitimate softwares are using LNKs that are containing plenty of command line parameters in them, and you just kill those. So it isn't that simple to just simply distinguish on whether the LNK suspicious node based on the command line length. It's just a weak signal. This is just a weak signal. However, what we can do, we can look for keywords like PowerShell or CMD. But then again, even if we do so, it still can be quite tricky to distinguish if you're gonna face the very first benign LNK running CMD. The very first benign LNK that runs CMD or PowerShell, you're gonna have a big problem. How would you recognize benign LNK running PowerShell from the shady one? And that's gonna be a different problem to tackle. And this is what I'm trying to. Maybe I'm not doing the greatest job, but I'm trying to give you that notion that from the defensive perspective, it isn't an easy task to do to close down the LNK threat, because of how LNKs prevalent are, and because of the fact that there are plenty of legitimate use cases for running CMD or PowerShell on top of LNKs seen across the world. So we cannot just simply kill that bird with that stone. Yes, anything electron usually has a singularly absolutely brilliant addition here, Whiskers. So let's get down to the slide now, maybe. Other than that, LNKs turn out to be polyglottable. So we can append, for instance, archivers like zip to the LNKs, and then when you open up that particular LNK confused as being a zip using some zip archiver, that archiver will disregard initial bytes describing the LNK structures, and then just simply scan through the bytes looking for the recognizable format, such as zip or 7-zip, and once it finds so, it's gonna unpack the contents, right? The same happens. The same holds true with the HTA. We can append HTA to the LNK and then run the LNK with the MSHTA, and MSHTA will happily load our code. I'm gonna show you the example shortly. So there are a bunch of files we can actually make polyglottable. I was also able to create an LNK that was a valid ISO, but then I've noticed that this combination isn't that much usable because that ISO had to be very small. I couldn't really include plenty of files in that ISO, which kind of outrolled its offensive use case, but still probably doable, probably usable under some contexts. So most of the LNKs we'll be looking at will be probably typically running PowerShells or CMDs. If you can avoid running CMD or PowerShell, you're gonna be having a winning card there. And I'm gonna give away you one single trick for running PowerShell or CMD indirectly shortly in the next slide. But one of the generic ideas, anytime you need to run something, always run it through a load bin. So even if you have to run PowerShell, make sure that PowerShell is going to be run through the load bin, for instance, conhost or anything else. Then, in order to make your LNK visually appealing to the victim, we would want to set it up with the icon. The downside is, the problem is that the icon cannot be pointed by a relative path. That it has to be absolute path, meaning we cannot just simply deliver the victim with the container containing both icon file and the LNK. This won't work unless you can predict the full absolute path to that file, to that icon file. So instead, what we can do, there is a file called paths to icons.txt that I gave you in the repository, and it just contains a list full of file paths that you could expect being present in the system, and you can abuse those icons by presetting them in the LNK. So, for instance, if you want to look like a good old Word document, you can use this particular lengthy file path because this file path is expected to be always present, irrelevant to the Office version and the Windows version. This path is expected to be always present if there is an Office suite installed. But also, what's even more peculiar, I'm gonna show you a little bit, kind of a very good look, a very cool trick here. So most of the threat actors and red teamers, myself included, will be delivering LNKs disguising themselves as Acrobat Reader PDF files, right? And there is a reason why we are so fond of using PDF icon instead of, for instance, Word icon. The reason being, in order to have Word icon, firstly, there has to be Office suite installed on the system. This is something we can assume probably most of the times Office will be installed. Also, then we're gonna be relying on that lengthy path, which is also somewhat reliable because I've seen that path present pretty much oftentimes. But there's a better path containing the Acrobat Reader icon. Let me now show you what I mean. In the C training tools, you're gonna find a tool called Icons Ext. It's the icons extractor tool made by Nearsoftware from the Nearsoft. Now what I'm gonna do is that this tool is able to scan through the executables and extract the icons out of those. But what I'm gonna do instead is that I'm gonna go for the Microsoft Edge. Where is it? Well, since I don't remember the path to the Edge, I'm gonna just simply start the Edge myself, right? Like manually. Let me just start the Edge path and then grab that path because I just forgot where the Edge is actually located. So yeah, now Edge, there you are. Let me just copy and paste it. Yeah, Microsoft.edge something something something. Now just take a look at this. In the Edge executable, out of the sudden, there's a PDF icon in the msedge.exe. If that's the case, and the Edge is expected to be always installed in the system, we can be always having predictable location, predictable path to the PDF icon. This is how we can make our LNKs looking just like the PDF file. What we're gonna do is that whenever defining the icon to the LNK, we're gonna point that icon path to the Edge executable, followed by the number of that icon being, in this case, 13. So let's get back. This is also included here in this entry. Microsoft Edge, followed by 13. 13 designates the index of the icon within the executable repository. From the defensive perspective, from the forensic perspective, be sure to check your LNKs under some hex editor, ensuring they don't expose your host name or the MAC address, because this is going to be entropy actively looked for by the skilled detection engineer. You can use less CMD tool to extract that piece of information. Finally, on this slide at least, there's also a trick for prepending your command line arguments with a 500 plus spaces that's going to overflow the edit control here, making this visually impossible to understand the command line of the file from the Explorer perspective. So in this case, the not so much technical savvy personnel wouldn't be able to comprehend what's going on that LNK, so it would need to be examined under hex editor. Now, as we have told so far, always run your commands through the lol beans. So the conhost trick is one of the examples, but also there is another pretty cool example, the for files. The for files, being very well-known lol bean, can actually encode the commands in the hex form. In this way, whenever looping through the system32 and coming across user32 DLL, right? This is how the for files work. Then it's gonna have that CMD followed by space followed by C encoded in hex, and that's gonna run 2 commands one by one, notepad followed by calc. In this way, we are not leaving CMD, not PowerShell, visible enough in the command line. So this kind of regular expressions or static signatures looking for the CMD or PowerShell just simply won't match this particular LNK file. So there we have it. This is quite an interesting trick for getting rid of the CMD phrase of your LNKs. Then finally, from the defensive perspective, it is impossible to simply implement a detection use case that if there is an explorer that runs CMD, then call it an incident. Defenders shouldn't be really tempted doing so, because they would be disrupting the built-in Windows mechanisms for running CMDs from the explorers deliberately by the technical savvy personnel. Like when you hold down the shift button and then right-click, the explorer will let you run the PowerShell command here, like in this particular directory. It used to be the command line here, but then they reworked it into running PowerShell. So we cannot just simply the defenders cannot just simply come up with the rule saying if explorers found PowerShell, then it's end of the world, because there's plenty of likelihood. There's some likelihood that they will be just throwing some false positive in this case. So moving next, what are the different ideas? Naturally, there are plenty of ideas we can really think of here, revolving around what we can actually achieve from the LNKs. One of the newer examples I've seen was a threat actor that used LNK running CMD that copied C Windows system32 curl into whatever, into like current location and then something exe, right? And then use it to pull out of it free, like in the screenshot we've seen previously, pull out of it, and then use it to pull some further script like evil au3, naturally attacker.com, right? Attacker.com, and then we know the story. Well, actually, sorry, too much of a shortcuts. That autoit was then used to run the script, right? Evil au3. So as you can see, the LNKs can get really creative. We cannot really really detail and describe all of the ideas that we could throw into the LNKs. Nice thing is curl doesn't seem to retain mark of the web, at least last I checked. Not sure if this is true today. No, that's some curious tip and hint here. I'm gonna play around this myself, yes, as well, because I'm quite interested in taking this step a little bit further and maybe downloading some more files. But yes, this looks like an interesting take. Not to mention that instead of downloading from the HTTP service, instead we can also copy from the webDAVs, right? So attacker.com followed by SSL followed by webDAV followed by autoit. So we could also use the LNKs to run something off the webDAV. We don't even need to copy files around. If that's the executable, we can just run it directly from the webDAV. So something like this would equally apply. Attacker.com, SSL, webDAV, hello au3, right? In this case, just take a look at how simple and straightforward the command can get within the LNK. we don't need to resort to overly lengthy PowerShell command lines. We can just simply run executable hosted on the webdav directory, and then refer to the script also hosted on the webdav directory. In this way, we are not pulling anything to the system, at least not directly, and the command gets quite short and concise. Reboot. I use webdav command to bypass DLP because it's mounted as a local disk. Yeah, sure. So I also seen traductors doing tricks with the LNK CMD followed by net use, right? Like net use Q, and then some webdav attacker.com. I even have this on one of the slides, this example. Webdav followed by password, right? Followed by user, some user. And then after having that drive mapped, they can, for instance, run the commands as easily as so, evil qexe, right? So you can get pretty creative with webdav, and then also with some other further commands. As I'm going to show you later on in the CMDs, in the MSI session, we can even run using a single command. We can deploy the MSI stealthily without pulling any MSI files, and then install it like so. Quietly install, for instance, original webex.msi, followed by transforms file, followed by evil mst that is equally present on the HTTP server. So we can have those two, like MSI file along with the MST file, being hosted on the attacker's machine. In this way, as you can see, we can have one and single command that's gonna install code signed MSI file, Cisco WebEx software here, then apply malicious so-called transform file. I promise I'm gonna describe what the MST stands for a little bit later on. And all of that happens to be revolving only around one single command. And the beauty behind this, we don't need to be using CMD. We can just use loading, like conhost or 4 files, right? So we're gonna have 4 files. You get the point. System32, right? Something like that. Windows, and when you some flag, when you happen to see user32 DLL, then run this command. You get the point. As you can see, we are avoiding using CMD and the PowerShell. So loading followed by MSI exec, plenty of ideas we can squeeze out of the LNKs. Let me copy them to the notes file if you want to play a little bit with those yourself. Other than that, we can play a little bit with the embed zip idea. So just appending zip to the LNK, that's gonna be then the lengthy PowerShell one-liner will locate the LNK, extract the zip out of it, unpack the contents to the directory of our choice, and then run whatever was unpacked, was extracted. Other than that, some polyglot attempts. So LNK can be also run by the MSHTA, and pretty much do it. Let us now see what I mean by that embed zip idea. So there is a script in the exercise LNKs directory. Let me maybe show it off to you in the little commander. C training exercises day number 1, LNKs. That's gonna be embed zip generator. In that generator, it's called gen embed zip cpp. This is how it looks like. This is the script originally authored by 86 Matthew. So it's not my script. I just merely slightly enhanced it, augmented it, just to prove the point, just to show off that proof of concept. Now let us show how the Matthew put it up. So he just simply creates an LNK shortcut in the C++. Here, I absolutely can relate. He's really outside of the box thinker. Now, what it does is just simply creates an LNK. Well, actually, myself, I don't like to be using C++ for creating LNKs. We can create LNKs far simpler in Python using the library called PyLNK3. So PyLNK is an absolutely outstanding library for creating offensive LNKs, at least if you ask me. But let's get back to the chase. So here's the lengthy PowerShell badass. You can see that it's prepended with 500 spaces, and then that it does all of its magic in terms of what's going to happen after double clicking. So this is pretty much straightforward. We're going to see that CMD is about to run the PowerShell here, right? We could further play a little with putting here some conhost maybe. And then finally some parameters. So what I'm going to do now is that I'm going to take that paths to icons file. I want to use the PDF icon instead of the user account control. So I'm going to go for the edge path. Now the problem is with that edge path, as you can see here, that edge path, it contains the PDF icon, however, under the icon index 13. Now I'm gonna find the index word, and you're gonna see there is a property called icon indexed, and it is defined in the line 97. So this field, it needs to be changed into the 13, value of 13, just to refer to the proper icon, right? And that's pretty much to it. Now you're gonna also see that there is this description. That description, we can inject new lines into the LNK description, and I'm gonna show you how it's gonna nicely impact the way that the Explorer presents the LNKs. So the LNK in question is gonna have like 300 bytes, so like 374. And the date modified, well, naturally 23, 13th, 09, and the 09, 38 time. Okay, so far so good. Now let me just build it up. Here I'm gonna, let me see, I just forgot, should I use the MingW? No, I should use the MSVC compiler. So in the Windows terminal, drop-down button, developer command prompt for VS22. Plain and simple, we're going to end up in the developer console, well, developer configured console session. Okay, now I'm going to compile the tool. Oops, I think I just made a typo. No, it's just without the exe, it's just the CPP file. Okay, so we've got the CPP file now compiled, and gen embed zip, and how to use it. Firstly, we're gonna need to point it to the zip location. So my zip, it's gonna contain a malware, for instance, Mythic. Let me see, program training Mythic, Apollo. Why not? Apollo is gonna be put to the zip archive. Right. So this is my path. Output LNK. Here, just the, I don't know, report.lnk. Why not? Then what to run in zip. So the name of the executable is going to be one Apollo exe, right? And that's pretty much to it. So, oh, it actually didn't work. I think I'm going to need to recompile stuff. Looks like it shows some errors, I think. No, warning. Let me now rerun the command. That's weird. I was expecting the icon to change into the PDF-like. Let me see where I'm. What am I missing here? I think see training tools. Okay, I'm messing with the wrong tool. So the source code gen embed zip. I was supposed to be messing with this file, with the file contained within the embed zip directory. So this is my issue here. Let me just quickly recompile it. So far, so good. All right. Now we've got the LNK. When we hover the mouse icon over the LNK, we're gonna see that familiar text document, date modified. We've seen that we have complete control over the tooltip presented in the Explorer, which means that we can confuse the user into thinking what that file actually is. Combine this fake tooltip along with the hidden extension, and we're gonna have mixture that looks just like PDF. It quacks like PDF, it walks like PDF, so it has to be PDF. Then, when we right-click on the file and try to explore properties of that file, because we feel suspicious, we are technical savvy users, and we feel something is rather odd here, we're gonna find out. We're gonna fuck around to find out, right? So, in this case, the field is completely empty. So we wanted to act as a smartass, but it actually didn't really pan out. We are clueless. Well, maybe the CMD stands a little bit slightly odd in here, but since we don't have anything else in this to consider this suspicious, we're gonna double click it anyway, right? We're gonna just double click it, and then if stars align, well, where's my mythic? Let me. sorry for not authenticating here. Yeah, there we go. So I've got a bunch of. Well, maybe that's gonna be far more visible if I just leave the console window here open. Maybe I'm just gonna close down those Apollos, right? Refer back to temp. Apollo, there you are. And as you can suspect, after double clicking on the LNK, the Apollo gets unpacked to the temp. Oops, looks like it isn't there. Well, it is expected to be there in the temp, and then we're gonna have the 12072, right? 12072, that is expected to be that particular 12072 payload. So this trick, I know that it looks very suspicious because of the way that PowerShell command line is structured, but it used to work against the Defender quite nicely. I believe it can still work. However, haven't checked it for like 3 past months, so I'm not 100% certain. But we've been using it quite a lot against Defender. It used to work against CrowdStrike, then they killed it. Then my colleague told me that it works still. So you got the point. You got the picture. There's some opportunities with running lengthy PowerShell lines still. However, if you can keep your LNK's command lines concise, like in the examples shown previously, we will be having probably better chances. So this is just an idea. Okay. So that's about the LNKs. This is the picture coming from that CrowdStrike alert that my colleague sent me once, like a year ago or so. Well, actually in December. And he told me like literally a month ago that it still works against CrowdStrike. So yeah, mic drop. Okay, anything else? Yeah, I think that pretty much sums up the LNK. LNKs are still pretty powerful ideas to get your commands executed, especially in the complex infection chain scenarios, something we're going to be discussing tomorrow. So I really recommend you playing a little bit with those. And now my favorite topic for today, MSI shenanigans. Yeah, it seems legit. That lengthy PowerShell especially, I take it. I give you that. So MSIs are my absolutely favorite pony because of how elegant we can get with abusing somebody else's MSIs, backdooring the existing ones, and how largely unexplored they are by the defensive folks. I think I haven't yet met any defender who was actually dissecting MSI file himself manually. Like, I know that defenders know, my blue team colleagues that I am working with and that I was discussing those formats with, they know that MSI can get shady, but no one has ever actually looked into it. Like, no one has ever actually dissected it, examined it. Nobody can actually explain what the MSI underneath the hood actually is. Is it a picture? Is it a song? Maybe it's a executable. No one knows. And this is why I'm so in love on the MSI, because everybody knows MSI can get shady. Nobody happens to know into what extent. Let's get down to Notion. Let me just pour myself a glass of water. And yeah, and let's embrace the MSIs. Surprise! Yeah, I would right now quickly throw in surprise, and then that very popular saying coming from Pulp Fiction, but I'm gonna resist myself from swearing out loud in public. But the Pulp Fiction quote just pushes to be perfectly fitting here. All right. So MSIs. MSIs can be created using a freeware toolset called VIX toolset that is open source initiative. You can find the source code on GitHub if you're interested. And then MSIs, well, they are known for installing programs, right? The problem they try to solve is how to install the program in an atomic way, in which if one of the actions fails, how to roll back the entire installation. By rolling back, we mean reverting all the changes introduced. If you were about to design a format that is going to install and then uninstall some program, you need to equip that format with a list full of all the changes you introduce to the system to make sure the system will be able to roll back those changes. So from that perspective, MSI has to be a list of changes that are going to be introduced to the system. And if that's the case, we can extract those lists of changes and maybe do something about them. Among the different entries that MSI can contain, we can have so-called custom actions. Whenever software gets installed, there are going to be different actions being executed by the system. Action first can be simply extract the files out of the MSI to the hard drive. Second action can be adjust the system registry appropriately, just to prepare the software for running. Third action can be drop some LNKs around, maybe set up some directories, some file paths, something like that. And then the developer, the creator of that wizard, installation wizard, can also define some of his own custom actions. So developers were equipped with ability to, for instance, run scripts. Whenever their program gets installed, they were encouraged to run Visual Basic scripts, JScripts, just to apply some custom procedures, custom steps for further setting grounds in the system before using the program. If that's the case, we can weaponize those primitives for our needs. So we can create MSI that runs VBScript or JScript, and it happens to be done completely in memory. We can run .NET assemblies in memory. We can run DLLs in memory. We can run system commands, obviously. We can run executables that are embedded within the MSI that will then get unpacked to the C Windows installer directory. So here's the example. Here you can see that I'm not sure if that helps. Yeah, I think that helps. Okay, you can see here that we used to run an MSI. That MSI created MSI exec. The first MSI exec, the MSI installer facility in Windows works in a client-server architecture. So whenever you are double-clicking on the MSI, that's going to be handled by the MSI exec, which then sends a signal over some mail slots or named pipes to the privileged installer facility, to the services SVC host, which then spins up the another privileged MSI exec, and that privileged MSI exec running as a system is going to actually process all of the instructions laid out in the MSI file. So a privileged MSI exec server facility will execute the MSI exec that was, will execute the MSI that was pointed to by the unprivileged client host program. Now, if there is an executable in the MSI that was deemed to be run when the installation completes, then this executable will be dropped to the C Windows directory, C Windows installer. And regardless of what was the name of that executable, it's going to be renamed into MSI, followed by 4 digits, followed by .tmp. We don't have any control over that path nor the file name. There is nothing we can do about the path. So anytime you're running executable, it's going to be dropped there, period. Then this executable running from the C Windows, it's gonna then do whatever you wanted it to be doing. This can be some suspicious activities, perhaps, but more importantly, we're gonna get the parent-child relationship primitive by design, out of the box. Like, we don't have to do any additional steps for just decorrelating the parent from the child. Here you can see that executable would be executed by a different MSI exec than the one started from the Explorer. So we double click on the Explorer, and then all of a sudden, in a different place of the system, our executable starts executing itself. In this way, EDR has no mean for correlating that this activity is related to the Explorer. Q. There's some Q. Let me. This MSI file must be run. No privileged. Privileged context is not required. You can be low privileged user, and you can equally just fine install the MSIs. I'm gonna show it how is that possible later on. But Windows is giving us the option, configurable through the global policy objects as well as registry, for disabling the lower privileged users from installing anything at all. So we can actually close down the problem quite easily by just reconfiguring the registry. But this is not the default setting. So by default, lower privileged users, even in the highly scrutinized environments, will still be able to install the MSIs. Take this and combine this with UpLocker, and you're gonna see where I'm getting at. So UpLocker letting the MSI exec go, and the MSI that runs something in memory equals win. Always install with elevated. No, you can actually configure the MSI by using its manifest, as I will show you later on, so that it runs without elevating current user's token. So it just impersonates current user. Okay, let's carry on. Now, what's the fuss with the MSIs, how they are structured? MSI file is just a compound storage file format, which means this plain old FAT-alike database devised by the Microsoft in a late 90s that we know from the Microsoft Office pre-2007 formats, that they were just compound objects as well. Compound file objects. Now, the MSI is a database full of tables, and tables are made of records, right? Among those tables, there will be a table holding all the cabinet files. Cabinet archive is a Microsoft proprietary format for storing files, right? Just an alternative to the zip, Microsoft alternative. Now, the cabinets will be holding files, and MSI will be holding cabinets. According to my experiences, I never found a MSI containing more than one cabinet. So all of the MSIs you will be ever analyzing will be having only one cabinet. However, from the offensive perspective, I didn't find an elegant solution for backdooring MSIs by inserting new files to it without creating a second cabinet. It is doable, but far more complex implementation-wise. Therefore, I failed, got bored, never implemented it, which means if you see two cabinets, probably that MSI is up to no good. And for instance, my tooling, my initial access framework I'm selling, or the MSI Snatcher tool that I'll give you today, it is also injecting files to the MSI by inserting second cabinet, which is a clear giveaway, which is a clear tell sign to whoever is aware of that problem. So this is an anomaly you can easily use to pinpoint probably malicious MSIs from one another. It's still doable to extract cabinet, put there the file, and then streamline it back to the MSI. However, I failed implementing it, so I would say probably it isn't that straightforward. Q, does the standard MSI process check any kind of hash for installer integrity against a manifest, or does it depend on the file, its components? I'm not aware of any facility that would be enforcing integrity of the MSIs other than code signing the MSI itself. So the MSI can be code signed, which means one single bit changing that MSI will result in completely invalidating the signature. So probably that kind of addresses your question, Whiskers. I hope. Just thinking how likely mods to existing MSIs would be detected or not. So if they will be detected, I'm not aware of any product actively decomposing MSIs and scanning through the contents. But yes, if somebody is actively validating signature of those files, then probably they will notice. But like I said, I am not aware of any product that actually does it. Not saying that there aren't. With the exception of Defender's smart screen. Sorry. So the smart screen, when it sees MSI and that MSI is signed, and the signature and the certificate is of the type extended validation, the EV, the strongest certificate, the smart screen will happily install MSI that has mark of the web marked on it. But if you have MSI downloaded from the internet that isn't code signed or is signed with a weaker certificate, then Smart Screen will kick in and just introduce 2 more clicks before we can install it. So the way we can work around Smart Screen is by using transform files, a lesser known vector for the MSIs that can be think of the DLL side loading, but in the MSI world. I'll just get back to this later on. Okay, now, what else is there in the MSI world? There are also the MST files. Well, I am root. I have played around with your MSI snatcher already. I've seen mixed results on MSI's behavior based on if the program is already installed, if admin is required, admin privileges required for. Do you have any go-to MSIs you backdoor? Like WebEx, for instance, Cisco WebEx. If you just scroll down few slides forward, you'll see URL towards that MSI. Some MSIs, as a matter of fact, they'll be missing the so-called streams table, which makes it a little bit harder to backdoor, because they would require messing a little bit with the common. Well, I don't want to bore you with the implementation details. As you have pointed already, I am root. Some MSIs will be easily backdoorable, others are not. I've been toying a little bit with the WebEx. We've been toying also with some customer-specific MSIs that we've noticed and we've abused. So maybe your mileage will vary. Also, there's like, for instance, Zoom installer MSI. I think I've been toying with this like year or more than a year ago, manually, and it was also kind of a useful. But lately, we've been rather generating the MST files instead of just backdooring MSIs. Lately, we are more interested in playing with MSTs that start from the LNK file. So that particular vector. So this idea, creating MST file, it doesn't require to injecting anything into the MSI, which would anyway result in invalidating the MSI signature, which is imperfect when you target the Defender protected asset, because the smart script would then kick in, which is far from perfect. I'll get down to that slightly, a little bit later on, I promise. Now, those MST files, these are like the diff files known in the Linux kernel development world, or just the Git world. When you take one MSI, compare it to the other, and there's some difference, you can clash them against each other, pull the difference file, and that difference file containing only the records that changed is going to be so-called transforms file, and it's going to have its own non-clickable MST extension. Now the trick is that we can apply changes to the MSI after it installs using that MST, and Smart Screen doesn't really seem to be interested in MST files, and we can apply those changes to the digitally signed MSIs, because we are not invalidating we are not changing any bit within the files. So the idea is following: the digitally signed MSI installs itself. Before it installs itself, the MSI exec will take the transforms file, will apply all the changes we have introduced, so only the varying records, and then we'll carry on with the installation, applying our changes to the installation process. And those changes, they might include, for instance, updated cabinet file, or some additional commands, or maybe .NET executable to be run in memory, which is something I am very fond of. Now, from the defensive perspective, how do you pick into the how do you dissect, how you examine MSIs. There are a bunch of tools, less MSI, giving us the read-only access to the MSI structures. It falls short with previewing binary contents included within the MSIs. We've got also Orca, which also cannot be used to dissect binary data included within the MSI, but Orca gives us the ability to edit MSI files. So we can use Orca to mess around tables and records, and in other words, backdoor the MSI. And then finally, I've made a tool in Python called MSI dump, which can be used to quickly triage MSIs, extract all the things, all the records, all the records along with those binary entries. So I just made it to help the fellow defenders to quickly extract the binary data injected. Now, in order to understand the MSI structure, we just naturally need to pick into there. So maybe, for instance, let me just download Zoom installer MSI. Let's see if I can quickly pull Zoom installer myself. As you can see, this is the Polish way of saying MSI installer. I've got 64-bit one. It's now downloading itself, but I won't be waiting until that happens. Let us maybe just go right to the tools, see training tools. Now in exercises, day number 1, let us dissect the most well-known example for a PuTTY installer. So we're gonna start off with less MSI GUI. You can then drag and drop the MSI, the PuTTY installer. Firstly, right-click on the MSI. Notice there is a digital signature, Simon Tatam, and that signature checks out, right? So the MSI is digitally signed. Now drag and drop it here, and the less MSI gives us the ability to extract all the files contained within that MSI. Now let's get down to the tables. Here in the table view, you can look through the tables. Firstly, what can we find? Binary table. It contains all of the binary data used by the MSI installer itself. So the files contained here, they are not constituting the software installation. They won't be thrown into the installed software directory. They are going to be only used by the installer itself. And when we'll be weaponizing that, weaponizing the MSI, and for instance running .NET assemblies in memory, those .NET assemblies are going to be stored right in that binary table. And this table can only be reviewed or extracted using my MSI dump tool. I'm not aware of any other tool that would be extracting binary entries. Then we've got component. It includes references to the files and in which cabinet they can be found, something like that. Then we've got custom action. Custom action is the most important table from the offensive and defensive perspective. It contains all of the actions that are going to be taken, non-regular, unusual actions, such as, for instance, running some commands in the system, running some DLLs, running scripts, and so on. So from the offensive perspective, we'll be interested into inserting new entries solely into that table. Then we've got environment, just the environment variables to be used during the installation. Naturally, you can get creative with your malware. You can, for instance, inject some data here. Then we've got file. File also lists a list of files along with their expected names. Here you can see even CHM file, URL link here. Then we're gonna have the second most important table from the security perspective, install execute sequence. Now that you defined your custom action will run .NET assembly. We need to schedule it when it's going to be run. So the installer, it just follows through subsequent stages installation stages. So that's going to be cost initialization, cost finalization, install validation, install initialization, some removal before installing, unpublishing, removing existing shortcuts, followed by removing existing files. Then we're going to install the new files, create shortcuts. As you can see, there are subsequent stages that the system follows in order to install the MSI. It just goes through the subsequent tables and applies the changes introduced in there. Now we need to specify where our custom action fits in. And the rule of thumb is to always make it second to the last. So we're going to need to specify that our custom is going to be just right before install finalize. So instead of 6600, let's just make it like 6599, right? Just one number to the last. Then another table, install UI sequence. This is absolutely similar table to the install execute sequence. So it also lists all of the actions that are going to be executed whenever MSI installs. But the difference is the actions defined in this table are going to be only executed in the GUI installation mode. So there has to be GUI dialog window in order to process that table, as opposed to that install execute sequence, which will process all of the events even in the quiet installation mode when no visual interface is depicted to the user. Then we've got media. Media contains list of cabinets. If you see more than one cabinet in here, I would roll the dice that something is suspicious in here. Most of the MSIs I've been seeing are having only one cabinet. Have been having only one cabinet. Registry, pretty self-explanatory. If you can create an MSI that messes with registry and then drops a file, what gives? Any idea how could you combine the registry write primitive with the file write primitive and unleash the beauty behind phishing to persist? Anyone's having any idea how we could use those two facilities? Number of things like auto-run registry. Absolutely. Well, you're absolutely correct. Plenty of ideas we could think of for dropping a persistence. I think my favorite would become hijacking. So just dropping a key into the registry and then dropping a DLL file and then waiting until either system or in some other way will be able to invoke that particular COM object. So we can have MSI that hijacks a COM after installed. I would call it a beautiful combination. Shortcuts. So as you can already suspect, we can drop LNKs across the system as well. Yeah. Okay, that's all good and cool. But how do we actually make it working? So firstly, we are right now hitting the 8 hours point. So my idea is to continue for the next 20 minutes, 23 minutes, and then we're gonna see where we are. And I think that we should be having the we should be hitting in 20 minutes. We should be hitting the MSI backdooring portion of the material, and then the question will be, can we do we want to continue and then just complete all the slide decks today, or maybe leave the MSI backdooring remaining slides for tomorrow? So let us maybe continue for the next 20 minutes, 22 minutes, until we hit the backdooring section. And then I'm going to ask you how you feel. Okay? I'm gonna ask you if you still stay with me or you're just falling behind, or maybe just getting exhausted by that time. Okay, continuing. So let's now continue, and then I'm gonna see how it unrolls. So in terms of the of creating our own MSIs, firstly we're gonna need to create an XML file with the extension of WXS. That file is going to nicely detail what entries are we going to include in the final MSI file. And in the Wix toolset world, we're gonna need to use the compiler called Candle and the linker called Light. Firstly, we're gonna be naturally compiling XML into the intermediary binary object Wix object file. Then we're gonna compile multiple Wix objects into one single MSI. Now, what happens here? Let me now zoom it up. What happens here in that XML is following. Firstly, we're gonna define some of the product names. This is completely under our control. The manufacturer. The only absolutely important piece of information in every MSI, and this is an imperative piece of information, is so-called upgrade code. The Windows system distinguishes multiple MSIs one from another, not based on their names, but based on the upgrade code. So if you happen to install one MSI that creates a file, and you then forgot to randomize that upgrade code, and all of a sudden you compile another MSI that creates another file, and that newly generated MSI is going to have the same upgrade code like the previous one, and you then decide to uninstall that latter MSI, the system will remove the file introduced by the latter MSI, but you're going to end up having a dangling state in the system with the first file being left as a leftover, because that second MSI never introduced it in its tables, so the system doesn't know that the second file, the left one, comes from the former version of the MSI. Meaning, I would really recommend you always randomizing those upgrade codes, or at least whenever you're playing with those, just play with them in your VM, that you can always just revert back in a snapshot, because otherwise you might end up really messing around with your system. Okay. Then again, we can also specify that the MSI is going to be hidden from the installed programs list in the control panel. Firstly, we're going to hide the application from the programs list. We're going to hide also repair button, modify button, end of story, and it's now gone from that list. Then we're going to specify the cabinet's name. We can make an MSI coming without the cabinet and the cabinet stored elsewhere. And then we can also compress it even further. This isn't that much interesting. Finally, we have next, we have complete control over where the MSI is gonna get installed by default. We can also throw in here some environment variables, like you can see here in this case. Then, in order to run any kind of custom actions, we need to always drop at least one single file. It can be dummy, empty, blank file, but we just need to drop something to the hard drive. Otherwise, the custom actions won't really kick in. So hence the dummy.txt. Then, let me scroll down. Then the more important things are happening here down below. Now that we have the MSI defined, now we're gonna need to inject the file. For instance, in this example, here we are just discussing the weaponization aspect for running executables from the MSI. When the MSI runs, it's gonna unpack the executable run it from the C Windows installer, and then continue with the execution steps. So in order to embed the executable to the hard and to the MSI, we're going to specify it in the binary table. Here is the table name, right? And here we are filling in all the columns required by that table. Now that we have that binary entry injected, we're going to need to refer to it from the custom action. Here's the custom action. We are referring to it by its binary key. And then we can also toss in some command line parameters here, some arguments, pretty easily. Finally, now that we have the custom action, we need to schedule it so that it runs. And to schedule it, we're going to add it to the install execute sequence table, right? And that action is going to be run just before install finalize, like we said before. And here is so-called condition. The condition tells to always run this action, the custom action, when you are not removing. So when you install the MSI, when you update, when you modify, when you repair, but not when you uninstall. So this is just the condition that defines whether to run this particular action or not. Pretty straightforward. Now let us see how it looks. I'm gonna jump. Oh, right. We've just downloaded the Zoom installer. Let us maybe now review what's inside of the Zoom. Yeah, let's use the MSI. So as you can see, plenty of files this time in that Zoom installer. What else can we find here? In the custom action, because this is the most interesting table from the security perspective, we're gonna find plenty of commands, along with some commands that are probably running commands in the system. As you can see here, plenty of command line parameters. Probably this action just runs. Oh, it actually sets property. It just messes around with perhaps further command execution. Then we have some DLL that's going to be executed. As you can see, benign legitimate programs, they also use the functionality for running DLLs. So it's not that uncommon to be seeing MSIs running DLLs, opening up the nightmare for defenders for distinguishing one from another. How do you tell if MSI is malicious if everyone is running DLLs during the installation, right? So yeah, it's quite of a problem here. Other than that, we've got, oh, there's also, no, actually there isn't. There's also digital signature. Probably not Weasel. Yes, you're correct. Service control, service install. Oh, well, actually, those tables they don't come with any entries. Shortcut. Oh, the Zoom event doesn't create a shortcut. At least not from the MSI perspective. Some registry. Well, to be honest, there isn't plenty of stuff going on here, at least as seen from the MSI perspective. Just a bunch of files that are going to be dropped to the system. For the shortcut, it might be happening while you are in the installer GUI. Maybe it just drops it a little bit later on. But I don't see anything too interesting in the MSI. Apart from that DLL that we just mentioned, there is actually a DLL that's going to be invoked at some point, and then naturally those custom action entries referring to some command line parameters. This could be probably of interest to someone. Okay, then let us build one from the scratch now. So naturally, we won't be running all of those commands ourselves manually. Instead, I prepared the convenient, helpful builder scripts. So I'm going to go to exercises day number 1, MSI shenanigans first exe. And then you can just simply type build. For the record, what build does, it just simply runs the compiler and runs the linker. Nothing too complicated. So we're gonna be installing those. Now here's how the MSI can look like visually. There is nothing we can do about that that prompt, that dialog box that just popped for the second there. So I couldn't really figure out the way for getting rid of that visual indication. It looks like the MSIs are just expected to be presenting some visual cues to the user that the installation is ongoing. So probably there's nothing we can do about those. At least I was unable. And now we've got that executable that was just executed. And if you pay close attention and you go for that executable, you will quickly see that this executable was actually started off the MSI exec, like we discussed before, and it actually occupies the Windows installer MSI followed by 4 hexadecimal letters, right? And as you can probably see, this process, this is actually the elevated one. So the system spawned our executable, but naturally it never our executable never really inherited the system's token because of the way that MSI installation facility is designed to always just downgrade the token unless told the otherwise in the MSI manifest, which will be negated by the UAC shield icon. Okay, there we have it. Right-click, uninstall, just to make sure that our system is pristine clear. We could also think of ways for installing it in an automated manner, just simply calling to the CMD followed by MSI followed by /q for quiet install. But I'll get down to that in the next slide. Another idea, .NET. So in order to run .NET in the MSI, we cannot just simply plug the .NET assembly because Wix toolset only works with native DLLs, and .NET is a managed DLL. So we're gonna need to compile our .NET. We can use generate.rogue.net for that reason. It comes with that convenient capital M flag, and that capital M it just inserts that annotation called custom action here. So in order to create your own C# code that will be compatible with the MSI.NET execution facility, firstly you need to insert the Windows installer reference, which also will have to be included in the compilation command line. And then you will also need to include that annotation. And finally, your action needs to be accepting one single parameter called session. Well, one single parameter of type session. Now, very important bit is that the namespace name that you choose and the class name that you choose and the method name that you choose will be present in the command line when we execute that. I'm gonna show it off to you in a sec, but those 3 names, they will appear in the process command line and under the command line parameters. So this is something to look for very closely. It looks really ugly. I'll show you what I mean by that in a sec. Then, once you've got .NET DLL, we're gonna need to wrap it around self-extractable CA. So there's a make sfx CA executable coming in the Wix toolset. We're gonna use it like so. So firstly, there's going to be our the output name for our native DLL, followed by the native runtime for that DLL. followed by our managed DLL, followed by that reference that we need to include, the Windows installer one. Then we're gonna compile it and then link it. Here in the WXS, from the WXS perspective, here's how it differs. So this time we don't have that exec command attribute here. Instead, there is the DLL entry that defines the name of the function exported by the DLL that has to be executed, right? So our my custom actions method name. The problem with running DLLs inside of the MSI is that they are going to freeze the installation. I'm going to show you what I mean by that. So firstly, I'm going to dive deep into Visual Code, and then I'm going to go back to the MSI shenanigans, .NET, and build script. Here's my build script. Now, what I'm going to do is that I'm gonna go for the C training beacons, and then I'm gonna pick up the exit thread beacon, right? Let's just reconfigure that. Oops. Okay, it looks like I've been having this issue before. Visual Code messes with the copied paths to the files. So I'm gonna need to do it manually. All right, then the Pi standing for Python, right? The V2 and x64, it all checks out. All right. So now let me build it. Okay, now I've got the MSI well compiled. Now let us run it. So far, so good. Now we've got the beacon coming back from the MSI, which is something what we expected. It actually comes from the run DLL, and this is the way that the generate rogue.net works. It actually spawns a calc that creates a sacrificial run DLL process. Sorry, it was expected to actually, well, hang on a sec. Actually, it doesn't run in the, well, it doesn't actually create the sacrificial process. Sorry, I just messed up. I might be just a little bit tired at this point. The MSI exec itself, it ran the DLL inside of the run DLL 32 host. And here you can see what I was telling you, oops, about that nasty nasty command line here. So let me try to grasp it. Oh, there it is. So here we can see we've got run DLL followed by the path to the TMP file, followed by that nasty ZZZZ invoke managed custom action out of process. This is very malicious, period, followed by sfxca, followed by namespace, class name. I don't know what that is. Oh, sorry, namespace. This is namespace here. Sorry, this is module name. Oh yeah, module name, namespace, class name, method name. All of those are there out in blue. So we are probably not gonna hide our intents that easily here in this case. So if there is a vigilant defender looking at this kind of a picture, they will be pretty good for writing their own threat hunting queries right now. But soon enough, when a threat hunter runs such a query across the organization, it may happen that there were plenty of MSIs installed that way that actually run .NET assemblies at some point, because we are just using the legitimate built-in Wix toolset mechanisms for turning managed .NET into unmanaged one. We could further simplify that command line by just using native DLLs instead of managed ones. But still, I would be expecting to have such a command line present across the different MSIs, because anyone who's using that facility that we just abused should be revealing the same command line behind. So if that's really that suspicious, I would say not that much, because we can always try to hide our intents by naming the module something like, for instance, runtime host, followed by runtime host namespace, right? Because why not? Followed by class name, like for instance, manager, followed by method name, like for instance, initialize runtime manager. Why not? Such a combination of module namespaces, names, and class names wouldn't be really that much standing out, or at least they would be looking far more viable, far more digestible, so to say. So now we've got the dangling installation dialog, and now we're gonna see what I meant by saying that the DLLs are gonna end up waiting until the action finishes itself. You can see I have exited from the beacon, but the run DLL host still remains running on the process list. And here's the problem, right? Anyone can identify what I did wrong? How should we proceed and recompile the MSI so that next time we'll migrate away from the Cobalt Strike, the installation finishes cleanly? Anyone is having any idea? The hint is it is being present in the upper side of the screen. The culprit, the problem, is present in there. Probably, I'm taking the probably we are all tired at this point, so no guessing here around. So let me just help you out here. The problem lies in the shellcode I used, the exit thread. When we exit from thread, we don't wrap up with the entire process we just introduced, the run DLL, which makes the installation facility to ever waiting for the run DLL to wrap up, which is never going to happen. So we end up having dangling state in the system, and all the subsequent installations are going to be denied because the system hasn't yet wrapped up the previous one. So this is clearly a problem. Instead, now in this time, I would need to close down the entire tree of processes. I will need to uninstall that MSI so that the system is pristine clear, and change the exit thread here, shellcode, to exit process. Now let me just recompile that MSI, remove the previous from the list, and now install it once again. You're gonna end up having the beacon once more here. Now pay a close attention to the run DLL on the process list. Next time I'm gonna hit the exit, it's gonna wrap up the run DLL process, which will enable the installation to complete itself. So this is the way to go. If you'll be ever running shellcodes from the MSI, ensure that they migrate away from that MSI. Otherwise, you'll be having those nasty leftovers and artifacts behind. Okay, so that was about it. The .NET idea. We can also run VBScript, JScript, execute some commands, mess around with registry, but I'll just leave it here for you to play with, because probably the most interesting idea would be to run DLL/MSI /.NET. Sorry. Now, with regards to installing the MSIs. The MSI can be installed naturally by double-clicking, then from the command line. So if you have like LNK or CHM, you can install the MSI from that point. But also we can use some straightforward piece of code script that will be calling directly to the COM objects here on the example of VB script. But we could also use AutoIt or PowerShell or JScript to install the MSI just like so. And the fun fact is that we can put here the URL. So we can install the MSI from the remotely hosted asset as well as from the WebDAV, right? So as you can see, 4 lines of code written in, for instance, AutoIt or JScript is enough to install the MSI from the remotely hosted resource. Then in order to uninstall it later on, MSI exec followed by /q/x, or just toss in the additional remove equals all parameter, denoting, well, how to install it, what to do during the installation. The UI level equals 2 stands for the quiet installation. So now we just hit the 8.5 hours slot point. So the question is, do you want me to carry on, continue, or maybe we're gonna just maybe just drop those remaining slides for tomorrow, when we will be fresh and full of energy after having some time to sleep and catch a breath, because there is a lot of value in the remaining slides, especially right in those. And I'm super excited to show you the trick behind the MST and the fact that they can be pushed to the WebDAV distribution point. So I don't want to spoil the remaining slides. Hence, let's just postpone them for tomorrow. I think that we have been having a lot of questions today, which kind of extended the entire agenda. But this is okay because it happens every session I'm having. It's also my fault because I'm just tossing too many slides, and I'm never making it in the 8-hour slot. So this is absolutely okay. So we've got like 50. We've got like 15 of us out of the 17, which means nearly all of us have made it this far. Like, you survived the 8 hours straight, listening and watching actively and interacting in the discussions. I'm super proud of you guys that you made it this far. There is the cue coming from Whiskers. Is that hanging run-DLL PID mostly a byproduct of MSI artifacts? Hang on, if I follow. Hanging run-DLL byproduct of MSI. I understand the distinction of the exit thread versus exit payload, but the behavior wouldn't always occur, right? But it stays here because of the way MSI handles it. Well, I'm not sure if I understand your question. MSI waits until the action completes itself, right? And since the run-DLL that was spawned never completed, the MSI cannot proceed to the next stage. So the problem lies in the fact that that run-DLL never really completed its execution. It never really turned down. Is that answering your question, Whiskers? Cool. Yeah. So we have covered a lot of stuff today. I don't want you to get too much bored with that VB script. Well, I don't want you to take a look at this VB script tradecraft as a kind of irrelevant, because the foundations laid behind the idea for referring to COM objects and directly invoking COM objects, like in the slide we've seen here, is quite powerful when you can pick a distinct technology, if you can apply this notion working directly with COM objects and implement this in another lingo that isn't Visual Basic, that isn't JavaScript, like find another technology like AutoHotkey, maybe Perl, maybe Python, maybe AutoIt, then you can still incorporate the same ideas, same implementation strategies that we covered today in just different language. The Visual Basic acted solely as a straightforward example, just not to complicate overly too much those concepts, because I just didn't want it to get you diving too much into the Python com stuff or such. But now in the times of AutoIt that is currently getting traction, I would expect we'll be seeing more and more AutoIt threads coming pretty soon. Even though the AutoIt thread is out there for the past years, it just been having a lot of attention lately, and it has now because we've noticed how easily it fits into our complex chains, something I'm gonna be showing off to you tomorrow. Then I'm gonna expect that we're gonna be seeing more AutoIt scripts, and we can implement all of those ideas, the MSI installation, the XSL loading from the AutoIt, hence avoiding the Visual Basic scripts. Now the question is, are the EDRs and antiviruses are prepared for our shady, hefty, customized AutoIt scripts that we are going to be throwing against them anytime soon? The answer is still unknown. We're gonna need to check out, right? So I'll be naturally re-implementing those ideas in AutoIt, and then we'll be sharing those with you when I got them. So always be sure to just get back to the student area and then check if there are updated pack of materials. You can see the timestamp there on your student account, the timestamp saying when was the last time I have been updating materials, so you can always refer. And also, there's this tiny little right-hand side version indication, .10, which indicates this is like 10th iteration of the slide deck. So you can expect that I'll be revamping the materials as new things pop out and as I'll be having new snippets. So this is what I mean by giving you the lifetime access to the materials. Now, any other questions that I could refer to? There is a queue. Same time tomorrow, same link, same password. Fingers crossed it's gonna work just as much. I'm gonna be dropping the recording within, I think, like 1 hour or so. Just need to upload it, that general stuff. This channel on Discord, how long it will exist? I am not planning to be tearing it down anytime. Like, there is just no point. I'm not paying for those servers, so there's no point for tearing it. So we can always just collaborate, exchange ideas and stuff. So the Discord channel is going to prevail. Okay, with that being said, thank you very much, guys. I don't know about you, but I myself am exhausted. So I'm gonna just lean back and focus, right? Probably I'm gonna just play some games, Starfield, Space Odyssey or so. So I hope that you guys will relax yourself as well. Don't think too much about initial access. Let your brain cells breathe a little, and let us sit here together tomorrow, same time, same link. And I hope that you guys enjoyed it at least a bit so far. I hope that you were able to catch a trick or two that you'll be eager to try out the very next time you have an occasion. So let me know if you have any questions, any issues, anything I can help you out with, maybe some missing materials, missing links, anything at all. I'm gonna help you out. So with that being said, thank you very much, guys, for staying with me. You are brave for surviving 8 hours. Super cool. and let us see each other tomorrow, next time. Thank you. Cheers, guys.